Of course, it has many aspects. I try to focus it, but let's see how far we get. So with a very quick introduction on the Copernicus program itself, but I know that some of you are very familiar with it, so I will keep that very short, of course. I will speak a bit about what was the situation until now, the legacy that we had in the Copernicus program, specifically regarding data and access to data. And then, of course, want to show you what is really new. What is the European Commission, together with ESA and us, changing for the user community. That is already, I think, one of the biggest data using communities in the world, as we have already more than 700,000 registered users that regularly make use of Copernicus data. And then, of course, what is the impact going forward? Mark was talking about data spaces. What will it mean? What can we learn from this project? So very quickly about Copernicus. Copernicus is the Earth observation component of the European Union Space Program. And with that, we can look at our planet. And I don't have to repeat how important that has become in the context of climate change, environment, but also agriculture, businesses like insurance. We all have seen the effects of extreme weather. I've also seen in the entry some of the posters where also science is contributing a lot to understand these effects better, to analyze them, but also to help that we can take action. It is really important that we take actions more and more quickly. And this collecting of data is done with a whole range of satellites operated by ESA, the so-called Sentinel satellites in different sensor types, optical, radar, infrared, and others, so that we get really a full picture of all kinds of effects that we see on planet Earth, be it the land, the oceans, and the atmosphere. And this data then leads, of course, to a whole range of services that are operated under the policy of the European Commission and generate a whole range of value-added products. So all the satellite data that's being collected is then changed into products, and these products are used to then generate services, for example, for agriculture or for marine monitoring. And how that is done until today, it was one of the very first, I would say, data spaces with maybe the drawback that when we start building this 10 years ago with the first satellite that was brought into mission in 2013, the data was, of course, at that time still very limited. There were hubs created that then developed not really into a coherent system, but the data being in several places in the well-known silos. And of course the EU provided, through these portals that you see here, access to this data, but it was not that trivial to combine data, to get data from different sensors, to use them in one particular service or particular product generation. And maybe the biggest drawback was that the data has become quickly so huge. We are collecting more than 20 terabytes of new data every day. It was difficult to put all this data online, to have it in immediate access. So most of the data was actually then quickly deferred to an archive, so that only the freshest data was made available immediate. And that was a drawback, because if you only think of climate, what do we learn from climate? We only learn from climate by comparing a whole time series, looking back in time, comparing the data from 5 years ago, 10 years ago, 15 years ago. That is what shows the development. So it has been always very important, and I think especially for the science community, to have this complete mission data, complete time series to do the analytics. And that is the change. And how complex it is, you see from this slide. Will not explain it. This is the EU Copernicus program organization. And then you see, of course, how difficult it is to really put things together, to make them work together, and to, of course, for the user, make it, in the end, very easy to access. the results. So the Copernicus data space ecosystem, it's the next step in this evolution. Yeah, I think we are very thankful that the European Commission, together with ESA, from the learnings of the past years, said we have to make a big step forward. We will now bring everything together in one contract with a very long time period. It's up to 10 years, like within the Galileo program, to have really this sustainability aspect also covered, that people, either being from science or from business or from policy making, will be sure that they can access the data all in one place for this period of time, and that all the data will be collected here and made available. So that is a revolution, I would say. A revolution in two aspects. First of all, it was also a revolution for us in industry. Yeah? We are an IT player, and a very large one, but even we are not capable of managing such a thing alone. And I think not any company in Europe was capable to do that alone. So one revolution was really for us as one of the key players to bring together, I would say, the champions in Europe, yeah, to say how can we do this together in one project, even if we might be sometimes competitors or sometimes have overlapping interests. And that worked, actually. That is the good thing about Europe. If we have a good target objectives, and the lead of the Commission, of course, has helped a lot with that, we were able to bring together these range of experts. And you can see, maybe you will know, recognize some of the names, like Vito from Belgium, Synergize from Slovenia, DLR from Germany, Acri from France, Rea from Italy and Belgium, Cloudfaro and T-Systems being the lead IT players in this from Poland and Germany. You will see it's also very European and very complementary. Yeah, so we have Earth observation experts, a space agency, IT players. This was a whole new strength that we could provide together and build this new data space. And what does that mean? What does the data space do new? So first of all, under the requirements, of course, of the program, we are now for the first time able to provide all the Sentinel data from the beginning of mission in 2013 online, immediate access to that data. That means already today we have 35 petabytes, and that is growing by this number of 20 terabytes per day. So we also know in 6 years' time it will be around 90 petabytes. There is not any other Earth observation data set in the world that is this size and this complete. This is really unique for Europe and for the world. And this allows us all to do new things. For instance, there is now a huge reprocessing campaign ongoing by ESA to use the Sentinel-2 data with new algorithms, new correction algorithms, and bring them onto a new quality level. So the whole Sentinel-2 mission is being calculated new and provided. And this data set we will make available as soon as all the processing has been done, from around September, October timeframe. And then people can immediately also access this latest version. And then there will be other value-add products, yeah, like the famous temporal mosaics. We all know from the internet, yeah, it is not nice to see clouds, for example, in optical data. So mosaics help, yeah, to get rid of the clouds, get the best possible data per pixel, and put that together in a mosaic. So very easy to use, also for non-educated users. And then we have also new elements like on-demand processing. For the first time, ESA will make its processors that they use in the production system, they will make it available online. And that's not all. There is a whole other set of data that is very interesting. It's the very high resolution data of commercial satellites. And this has also been made available, especially to science and to policy makers by the EU that has acquired this data for the next coming years, to make that available free of charge for these registered users. And that is, of course, another very important source of information. And that will also be in the data space available. I will not mention all the names, some of you will recognize. Then there is a traceability service, also very new. It will allow you to really check if you are using the original data, with the trace to that original data, and with what programs this data has been corrected. Just to show you some pictures, of course, of the interface. Yeah, it is very important that we not only serve the specialists that know how to program this and how to do this, it's also important for new users to get acquainted with the data, understand it, to have this very easy browser access to the data, to be able to filter it, select it, curate it, and then use it maybe in a certain application. So also this browser, I would also invite you to go to dataspace.copernicus.eu and have a look for yourself. The self-registering only takes you like 20 seconds, and then you have access to all these tools. Just some examples here. Yeah, you can also do automated time-lapse videos that you maybe know from your GoPro. Very effective, yeah, to have a quick understanding of the data, how it has developed in time. And of course also these nice 3D pictures. Let me go to processing quickly. It's also about really serving the experts in science, especially. I know that a lot of you are very expert in working with the Copernicus data. And here we have also done a new step in that we provide a whole range of new APIs, like stack APIs, that has become very popular in the community. So very easy access to the data based on these APIs. And two very important tools to use that. So I believe we don't need Earth Engine anymore. With OpenEO, for example, developed also in Europe as an open source framework, you can really prepare everything that you need for a processing chain. And you can do that in a visual way, simply by having a low-code approach, using a web editor, prepare your data, prepare your workflow algorithms, and then let it run as many times as you want, change it, run it again. And this is very effective. And in the background, it uses well-known tools like Apache Spark to make that also very effective on the IT infrastructure. And an example is here from Vito, a company that also supports the Copernicus Land service for the Commission, where they have to create these maps for agriculture use, for example, and they are using this intensively and are able to really correlate data in a tremendous new dimension with this type of tools. And this tool is made available on the cloud, so you can directly use it without even having to install any software. Cloud, I mentioned it. It's important that users can do something with the data and do not have to download it anymore. It is sometimes even impossible to download it because of the size of the data. Of course it is for selected data possible still, but many users want to process the data where they are. And that's possible now with two clouds, two OpenStack clouds. So also here, completely based on open source, one from Cloudflare and one from our services, Open Telecom Cloud, where you can have all the virtual machines, GPU accelerated object storage options that are needed maybe for a certain scenario. There will be, of course, a lot of people that want to understand how to do it. So documentation key, everything is online. And there is, of course, a service desk to see how you can use it or talk to the people. I would like to mention these two programs. Sometimes in research, very important to know where you can get funding for this. So there is the NOR funding from ESA that is accessible for research projects, where you can apply in a very pragmatic way and get funding for the use of that cloud computing resources, for example. Oh, what did I do? Sorry. Touched the wrong button.
Yeah.
Last slide. Yeah. Okay. Yeah.
Okay.
Thank you.
1 minute.
Yeah. And of course the OCR program, well known, I guess, to most of you, where both Cloudflare and Open Telecom Cloud are available to, of course, then also use this program to finance the cloud computing resources that you may need. So take home messages. And I hope we can, of course, use the panel afterwards to discuss this. It's the very first time, I think, that we really bring all the data in one place, have free access to it, immediate access, and along with the data, a whole range of tools in this ecosystem. It's open for anybody to join, and we are open to federate with any entity or any community to also allow them from their own environment, like a university or a research organization or a agriculture data space, for example, from industry, to share the data on the basis of the new data space standards and the EU strategy for data guidance that's provided by the Commission. So with this, I think we have a very long and, hopefully very successful future around this data. And remember, this is something we do in Europe for Europe. So participate, join us. Thank you.
So thank you. Martha, if you could switch the... While Marta's switching us over, I first want to congratulate Yuri on an amazing presentation that was on time, as well as all the amazing content as well. So thank you very much, Yuri. And we will take questions, but later. So please remember your question, and when we gather the panel, I certainly invite your questions at that time. At this moment, I'd like to invite Daniel Alonso. I've had the pleasure of working with Daniel on, I think this is our fourth session together here at this conference. Daniel is Senior Technical Lead for Big Data and AI Ecosystems of the Big Data Value Association. He's part of the Technical Architectural Board of the Data Spaces Support Center. And that, as you know, is an initiative supporting the data spaces across all of Europe. And previously, Daniel has been chair of the BDVA iSpaces group and coordinator of EU Hubs for Data, and which I'm sure many of you know is aimed at the creation of a European Federation of data-driven hubs. So Daniel will give us a bit of a BDVA presentation in this on our theme. And over to you, Daniel. Thank you.
Good morning. Good morning, everyone. Thanks, Mark, for organizing this session and inviting me to present BDVA in front of this audience. Actually, I like very much the title, Making the Space for Data, where data or data spaces also meets research. Because actually from BDVA, from the very beginning, we have considered every type of data, including industrial data, private data, but also research and scientific data. And what I will do through my presentation is basically describe BDVA, but also include some aspects that I think are important for what the discussion that we are having today, how we can see BDVA as a community, okay, where not only data industry, not only policymakers, but also scientifics and research can meet in our community. And again, I will provide with you some hints what we are doing, not only about data, but also about other aspects that we are considering. So let's start from the beginning. In BDVA, of course, data it's at the core of all our activities, okay? But not only data, okay? Also AI, data-driven AI, trustworthy AI, human-centric AI, and everything that AI can do, data can do about AI. But also about data and AI, we have those four pillars, of course, technology on the one hand, research and development, policy and regulations, and finally, value and creation to the market. And you will see, well, this is quite related also, these pillars to the data spaces. If you are familiar with data spaces, at the end, we are basically following always the same approach, okay, taking into account data, technology, and so on, through policy and regulation, created value out of this data. Around that, okay, we are attracting talent, we are also relying on infrastructure, we are also contacting and attracting individuals and organizations, and providing governance and interoperability to, at the end of the day, achieve these four characteristics that somehow define our landscape, which is sustainability, autonomy, resilience, and impact, okay? So this is basically the whole picture of the whole framework in BDVA, what we are doing. But also I would like to show you this picture because it shows very well the evolution of BDVA from the beginning. BDVA stands for Big Data Value Association. It was created in 2014 as the private part of the Big Data Value public-private partnership together with the Commission. But BDVA has evolved from that time, okay? Not only with the members, now we include more than 240 members all around Europe, but also regarding the topics that we have also included in our ecosystem, everything related with data, of course, but at the same time enlarging our ecosystem, establishing relationships with other initiatives, but also make the best out of this collaboration. So starting from the Big Data Value PPP, then in the Horizon 2020, then in the new program, and probably you are aware of that, there is a new PPP, which is ADR PPP, which is basically the private part is ADRA, AI Data and Robotics Association, which is composed by BDVA, Euro AI, EU Robotics, ELIS, and CLARE. Not only that, BDVA is also part of the Euro HPC joint undertaking, okay, that basically is fostering the collaboration in Europe of HPC communities to leverage not only scientific power but also industry. We are also members of the Transcontinuum Initiative, and in 2020 we also joined forces with IDSA, Gaia-X, Fireware, to launch the Data Spaces Business Alliance that also tried to, again, foster the adoption of data spaces all across Europe and to leverage data spaces for business acceleration. Of course, we are following the strategy provided by the Commission. On the one hand, the data strategy that was published in 2020, but also the AI strategy, and right now the strategy for the digital decade. So at the end, BDVA, we want to act as a facilitator, as a meeting point of all those communities, and also, again, to create value out of data at the end of the day, but also in contact with all those initiatives. Just a glance about BDVA composition. BDVA is a non-profit Europe association focused on big data, as I mentioned before. From 2014, we have grown quite a lot. You can see here the distribution, and also very important for this discussion, around the half of our members come from academia and research, okay? We include also members from large industry, SMEs and startups, association, and other public bodies. In total, we have two types of membership. We have full members and associate members, depending on the involvement of the members in the activities of the association. And of course, if you are not a member or you want to know more about BDVA, you are encouraged to contact me or contact us and get information about our membership. Just very quickly, this is a shot of our full members on industry, research and academia, also full members. You can see, probably you will recognize many names here, and also associate members for industry and associate members for academia. So all in all, we think it is a quite vibrant ecosystem. We are having meetings every month to discuss about hot topics, and I will go through the slides with some information about that, okay? This is how BDVA, how we work, okay? The content-wise work is done by the task forces, okay? Again, this information is in the web page, but let me just emphasize that we have three types of task forces. On the bottom, you can see the foundational task forces that include strategy, impact, and ecosystem, and program, and so on. On the middle, you have the most, let's say, cross-sectorial task forces that include technical task forces, for instance, data privacy and protection, data and technology, but also skills, also policy, social and regulation, and also business. Let me emphasize the task of data spaces that is quite important for this discussion today, and that, of course, is part of the whole ecosystem, but in the last months is gaining more and more importance. And on top, we have the sectorial task forces that are touching the different domains where we think that are important. So yeah, you are encouraged to, if you are part of BDVA, you can be part of those task forces and be an active member of this discussion, okay? At the beginning, okay, as I mentioned before, it already passed, but some projects are still ongoing, okay? The Big Data Value PPP started in 2014. Actually, the project started in 2016 and lasted until 2020, so the program is done, but some projects are still ongoing. In total, the Big Value PPP was able to leverage for more than 400 million euros for the Commission, but also more important, we were able to leverage from the partners of the projects more than 2 billion euros of investment. Okay, and we are really proud of that. Many of those projects were also related to research. I remember, for instance, data platforms that we ran a few years ago. They touch not only private data, but also public data, research data, and personal data. I wanted also to emphasize this aspect. It was mentioned by Mark in my introduction, but I chair in the past this group, not from BDBA, but in my previous position. But this group is still running, of course, and this is one of the main assets of BDBA, the IA Spaces concept, because it's very related to data spaces, but also to hubs. So I will not go into detail. An IA space is an experimentation environment, okay, where other parties, mostly SMEs and small parties, can have their data-driven solution and services very quickly tested and exploited before going to the market. So there are experimentation environments, and as you can see here, we include also research and projects on the research domain, where other parties can have these services tested. It's kind of a combination between data space, data innovation hub, testing and experimentation facilities in a low scale. But the concept is quite interesting, and it was going back in 2014 when BDBA was created. And the group has evolved a lot. Now this group is composed of more than 35 IA spaces all around Europe, okay, covering 30 regions in more than 20 countries. So we are really proud also of this group that, again, provides this experimentation environment where all of companies, researchers, projects, and can have, again, the solution tested and piloted before going to the market. I won't go into detail. Again, as I mentioned before, now we are also by ADRA private members of the AI Data and Robotics Partnership. There are other projects running under this PPP. And of course, you can see also here some figures. The PPP is still running, so we don't have the final figures. But again, we are quite also proud of the success of the projects that are running under this initiative. As I mentioned before, we are also members of the Euro HPC joint undertaking that is basically foster the collaboration between HPC parties all around Europe, again, to make the best out of this structure and put them at disposal of industry, researchers, and also other communities. Regarding AI, and as I mentioned at the beginning, it's not only about data. We are also very focused on AI. And on AI, we realize that many discussions are taking place at the national and regional level. So what we are doing here in this group, we are bringing together relevant initiatives on AI to discuss about hot topics that are about this technology. And I would say the AI Act, testing and experimentation facilities, trustworthy AI, human-centric AI, and more discussions. So we are having regular meetings with all those initiatives. We have our first meeting in the last European BDBF in European Big Data Value Forum in Prague. We are continuing our discussion again during regular meetings. We have also our last discussion one month ago, again, where we invited all those initiatives, and we will discuss also about relevant topics about AI I mentioned before. And again, if you are interested, we have a dedicated task force also to touch these activities. So my last slides are about data spaces, which is basically what we are discussing today. BDBA already, back at 2019, we published our first position paper on data sharing and data spaces. And we published a new version of this paper in 2021. I just extracted from the paper because we already identify, on the one hand, challenges for science, but also many opportunities for science. And you can see here that for us, science and research is also considered in our strategy. Also, you can see here the roadmap that we envision for the data spaces in the 10 years roadmap. So starting from highlighting the convergence, and this is, for instance, what we are doing in the DSBA Digital Business Alliance, Data Spaces Business Alliance. We are focusing now in the technical convergence. But after the convergence, it will start the deployment, and the deployment will be running two sides. On the one hand, with experimentation, and this is where what I mentioned before, the IA spaces are in place, just to provide this experimentation together with the deployment, and at the same time, standardization. So you remember from my first slide that for us, standardization is key, because standardization provides this scalability and also sustainability for data spaces. And more creating awareness among the audience, among the public, among the different communities, industry, scientific, and research. So this is the roadmap that we are trying to follow, and again, in collaboration with our colleagues on the DSBA and also other initiatives. And I will finish my presentation with the Data Space Support Center, okay? Probably you are aware of that. The Data Space Support Center is a coordinated and support action that the Commission proposed to support the quickly deployment and adoption of data spaces. So the mission of this project is to support all the CSA that are running now on data spaces, but also the new ones on implementation. Again, it is a CSA, part of the editorial program that started last year. The project will run for 4 years, so we have still some time ahead of us. And one of the main objects of this project is to produce a blueprint, which is called a blueprint, that is composed of a taxonomy of building blocks that you can see here, together with the description of the building blocks, standards, guidelines to implement data spaces, and more material. I will not go into detail. This is the taxonomy that we are proposing now. It is ongoing work, so don't take it for final, because again, we are co-creating this taxonomy together with other initiatives, but also with the data spaces that you can see here on the right. These are the actual the current running data spaces, and you can identify the different sectors here. So together with them, okay, we are co-creating this taxonomy, and we are co-creating this content. Again, I will not go into detail, but you can see here different blocks. On the top, business, governance, and legal. On the bottom, the technical building blocks that basically guarantee interoperability among participants, that guarantee trusted and sovereignty for all the participants. And I think it's also very important for the research community how those aspects are considered, but also data value creation. My message from here is that it is a co-creation work. So all the people are invited to participate. If you are interested, feel free to contact the project, because we are running periodic activities to engage with the audience and also to get the feedback, okay? And there are also more collaboration from this project, very important, because again, we are basically touching many HPC that you can see here, AI, data spaces, skills, and cloud. As the previous speaker, I would like to finish my presentation with, I wouldn't say conclusion, but at least some takeaways that we can also later on discuss in the panel. For us, for BDBA, research and scientific data has been important from the very beginning. Okay, our idea is to integrate those different ecosystems in the discussion that we are having in BDBA. Okay, many projects, at least in the previous PPP, but also in ADRA PPP, are running about research and scientific data. Also, we in BDBA we have run and are running different activities involving research and this type of data. Also, the connection with EOS I was checking yesterday our agenda. Back in 2015-16 was already identified. So for us, the connection with EOS and the collaboration is crucial, and this is why I'm really happy to be here with you. Mostly, as I mentioned before, in the Data Space Support Center ecosystem, data spaces, for instance, Health and Green Deal, include not only industry data, but also research and scientific data. So in that sense, we are also touching this part. And of course, the co-creation process and the co-sharing process allow researchers to participate in the definition of the taxonomy and the building blocks. Again, I just wanted to finish offering big data, BDBA, as a meeting point to discuss all those things. If you are interested, you can go to our webpage. And of course, if you are not a member of BDBA, I encourage you to be a member and continue the discussion in our different task forces. So this is all from my side, and eager for the panel.
Daniel, stay here. So there we go. So thanks very much, Daniel. Please have a seat. Yuri, if you could join us at the front. I'd like to invite a number of other panelists up to our little table here, who've offered to share their perspectives on this question. First, Sebastian Picadat, who's the Chief Executive Officer of Ag Data Hub. He's an expert in strategy and organization in agriculture, and solid experience in IT and institutional relationships. Global vision of the agricultural ecosystem, and he's carrying Ag Data's Hub ambition to decision makers in institutional and agriculture world in France and in Europe. So thank you, Sebastian. Welcome. Gianluca Lipari, He's technical leader of European projects at Electric Power Research Institute Europe. His research activities focus on the digitalization of energy systems, including cloud applications for cyber physical systems, monitoring, automation, data-driven approaches for electricity grid management and operation, distributed generation, and electrical storage integration. And he's involved in the Horizon Europe int.net or int::net project, which is focusing on an interoperability network for energy transition. Valentine Charles is joining us and working for Europeana since 2009, covering the field of data aggregation and quality. As you know, Europeana is involved with the cultural heritage area, and so before she was involved with that, she was coordinating the development of METIS, the data aggregation and publication infrastructure that is now being used at Europeana. She now serves as Data Services Director. Thank you, Valentine. And lastly, Esther Huyer. I think I'm mispronouncing that, so my apologies in advance. Let me just invite her to the stage, as well as, let me just quickly read her bio from Huva. She's the director at Capgemini Invent. She and her team build and consult collaborative data ecosystems in automotive, banking, logistics, life science, and a number of other industries. And she's in that area working to create successful data sharing and common European data spaces, collaborative data ecosystems. So thank you, Esther. So what I'd like at this point is to give everybody a short opportunity. Our four new appearances. We've got, at least for 3 of you, I think we've got some material queued up for you to walk through. You'll run the slides, so let's go from stage left to stage right. So Sebastian, you want to start with Esther?
Yes, please.
Oh, okay. So
Esther.
Yeah, I paid some money for that before, so I could be first. Yeah. Well, good morning. Thank you, everyone, for being here. Thanks for having me. My name is Esther Huyer, and I work as a director for Capgemini Invent. At Capgemini Invent, we are involved in the Data Spaces Support Center, which we heard already about, and I'm sure many of you know, where we conceptually and as pragmatic as possible think about blueprinting future successful and sustainable data spaces. I also have the honor to work with the Data Space for Cultural Heritage and the Data Space for Language Data to then actually think about what to do with all of these thoughts and concepts that we have. And thirdly, I also consult large international enterprises. So I see great lighthouse projects there, like Social Science One, but I also see the challenges of many of the big firms being quite, having some thoughts on data sharing, which is not as progressive as we think and we often exchange at these conferences. So I'm very happy to learn about more lighthouse projects, how to push them forward, but also how to get the tipping point to get businesses and research associations together and share data. Thank you.
Yeah, sorry. We have some slides there for Valentin.
Yeah.
Valentin.
Thank you. Good morning, everyone. So yes, the Europeana initiative has built since 2008 an ecosystem for cultural heritage data to be shared and reused across Europe. So in a nutshell, what we have built is an infrastructure where data is flowing from cultural heritage institutions across Europe into a central infrastructure where then data is published via several APIs through the europeana.eu website, but also the data is accessible for everyone. So we work with large communities of reusers ranging from creative industries, research, education. So the ecosystem would not exist without the people, so we have built around us an ecosystem of a large community. So we have the Europeana Network Association, which counts now 4,000 members. We work with more than 3,000 cultural heritage institutions in Europe. So building this environment, we had to develop a lot of rules for participation and engagement. So we have several frameworks that have been built on open principles, open governance principles, interoperability principles. So we have things like the European licensing framework, which regulates the rules for exchanging data and reuse, the European data model, which is our common ontology, and the European publishing framework, which defines the quality requirements for the data. So where we are now, we are in 2023. Next slide, please. So Europeana is now responsible for the deployment of the common European data space for cultural heritage, so one of the 14 data spaces that are being funded under the Digital Europe program. So what does it mean for us? In some ways, we think that we are already a data space. We have developed a lot of mechanisms, whether they are technical or framework-based, that correspond to the idea of the data spaces. So how we see our evolution. For us, we think that we have to work on basically extending this framework so that we can accommodate new type of new use cases, whether it's the type of data we are accommodating. So for example, we are working a lot now on 3D. So what does it mean to get 3D material into our infrastructure? We also are looking in ways to innovate our aggregation model, so working in a bit more decentralized way, and also trying to innovate by using the technologies that are available now, such as AI. So what does it mean using AI in the context of cultural heritage? So yeah, that's it.
Thank you. So now, Gianluca, if you could say a few words about yourself and your projects.
Yes, so good morning also from my side, and thanks for the invitation and for having me here. I'm Gianluca Lipari from EPRI Europe, and today I'm kind of representing the cluster of energy data space projects. The cluster basically is a combination of 5+1 projects. You see there the names of the data space, energy data space projects, all of them looking into some specific use cases, some common traits, but developing or designing the approach to data space in energy in Europe. And Internet has a 6th project, has the role of coordinating this cluster to be the ones facilitating then the deployment of a common European data space. So looking at what is the booster for putting together these approaches, which is interoperability. So together with the projects of the cluster, we look into the requirements, we look into the semantic and the technical requirements and interoperability needs. Of course, we also look into the regulatory framework and the data governance or the values and the business opportunities. And what we want to do as a cluster is to create a network together with the project, but also looking outside. Was mentioned the Data Space Support Center, learning also from more mature data spaces, what are the good practices in bringing together not isolated, but let's say parallel initiatives into what will be a common data space coming in the coming years as a deployment phase.
Thanks. I'm Sébastien Picarda, CEO of Agdatub. Agdatub is a private company funded by farmers' organizations and the French government in order to operate data intermediary platforms dedicated for farming industry. And right now we are the coordinator of Agri Data Space Support Action Program funded by EU Commission. This is the first step before the implementation of an agricultural data space. This consortium is formed with 15 partners present in 10 member states, and the goal is to make an inventory of the existing platforms and to prepare the implementation through a network of platforms. What is specific in farming industry is the decentralized architectures. I mean, we have to interconnect 10 million farms with 500,000 partners. upstream and backstream in the farming industry. And this is the challenge. You all know farmers, they love technologies, but they love technology which works and improve the revenue. And that's why business case and use case is really important, and we use not only the public research data, but also business data. And the goal is to make an interconnection and intermediation platform together and to provide innovation through processing industry to develop new tools for farmers in order to improve their revenue. And this is not our activities, this is the activities of some ecosystem of processing companies linked with us. So here is a challenge for EU farming industry.
Thanks very much, Sebastian. So I'd like to start off with a couple of questions that we've, if you will, discussed amongst ourselves and get the conversation started, but I will open it up for inputs from the audience. So first, I'd like to raise that first question, which is how do we see research and business data working together? And I'll start off with maybe throwing this to Yuri, and perhaps if our other panelists have some thoughts, if you could grab a mic and give us some input on this, and we'll start the discussion there.
Yeah, thank you. Yeah, we believe it's also an issue of what do you need, yeah, as a user or as a business or as a researcher. But we see, of course, from our experience from the working in Earth observation, remote sensing, that is such a generic tool, yeah, for so many different applications that there has been always this need, and it was, until now, I would say, always very difficult, yeah, to combine the Sentinel data that is free and open by policy, provided by the European Commission, and of course the business or commercial data, as it is called in the satellite world. And why is it so important? If you see how you need to analyze a problem, it's often that the free and open data is capable to make you understand where the problem is, but is probably not the high resolution or the detail to solve the problem or to decide what to do, how to act. Yeah? So for a user, even if it's a policymaker or especially in business, it's extremely important that you can combine the free and open data with commercial data and basically do that in one workflow, yeah, to analyze from the problem situation all the way down to the solution, yeah, to what to act, because that's the value that is created out of the data. Yeah? This is the intelligence that we need. And that is, I think, the big step that we are making with the Copernicus data space, that for the first time, the users will be able to combine these free and open data with commercial data really in one platform, operate with the same tools. They can select the tools, they can bring their own tools, and we also allow businesses to use their own tools and their own data. Yeah, like Sebastian was saying on the agriculture, very important that you not only manage the data that you can provide out of a data space yourself, but that you open it up and that you say, bring your data. Yeah? If you need to complement what is there, then bring it and provide the tools and the interfaces for the users to do that.
So maybe Sebastian, you could add a few thoughts, because I think you did in fact mention that in your comments. So if you could.
Right, I just want to add an opinion about that. For people who publish open data or free data, I mean, when you speak about private or business data, you think as a data product. I mean, when you have a data set and you publish it, the goal is to be used by final users. But you in the research, I mean, this is not only for you in the research ecosystem. You need to think data set as a product. Even if it's free, you need to think at the end about the final users and saying, okay, this is free because this is paid by taxes, by the member states or by EU, and this is not because this is free, there is no value. And at the end, if we want, or if processing companies want to use private free data, open data, and private data or business data, the goal is they must be reliable, interoperable, and useful for the final users. If not, there is no use for them.
So Gianluca, you want to talk about interoperability? I think that's something that you folks have been working on, and that's raised here by Sebastian, and you have no way to... Are you able to talk?
Yes.
Oh, perfect.
So maybe I can bring the example of the energy sector. Energy sector is historically somehow a little bit slow in evolving because the infrastructure is meant to stay there for 10, 20 years, even more. And then when we look also in research, all the applications that are data-driven, there is the challenge of interfacing with the legacy systems that are there. They are usually in a monolithic approach, also vendor locked somehow, and the wish of the research communities, but also somehow the industry is moving in that direction of extending these capabilities with the cloud-native approaches, with data-driven applications, and there the technical and semantic interoperability is crucial. So being able to have interfaces towards the multitude of new data sources that we have in our houses, in all the electrical grid. There are many new data sources with different granularities, different original use cases that can be combined to enable services that are needed for the new grids, for the grids of the future. Those are smart grids. So there is a lot of work to be done. There is a lot of interesting activities ongoing already. Probably what is missing while making this happen is understanding the value of sharing this data, of having a common data space, having a place where this data can be shared with other actors, and what value can bring this activity. So what other new business this can enable, or which cross-sector activities or use cases can be enabled. One example could be electric mobility. The interface towards that from the energy sector, it's huge, it's needed for the safe operation of the grid, but it's also quite crucial for enabling all the flexibility that vehicle to grid, vehicle to X can enable, can help in increasing the renewables, increasing a more granular management of the grid. So there are challenges, but there are also big opportunities, and transmitting this value is what will enable or boost the industry to move in this direction, in my opinion.
Thank you, Gianluca. One last comment from Valentine. I think you have some particular perspectives on how the research sector can add value to sectoral data and vice versa. And while Valentine is talking about that, I'd like to open the floor up to questions after that. And so if anybody has a question, let's have that conversation. Please, Valentine.
Going to take maybe a slightly different angle. So since yesterday, I was attending this event, and a lot of us speak about sharing data, but I've heard very few talks talking about the quality of data, what we are really sharing. So in the context of Europeana, so there was a lot of effort to articulate data sharing and data reuse around this idea of quality. We are not just sharing data just for the sake of it. So what we realized is that speaking about quality was a way to get cultural heritage institutions a bit more advanced in their digital transformation. So really thinking about why are you doing this effort and what are the reuse cases you are serving. And on the other hand, we are working with a lot of community, whether it's education, so primary and secondary education, but also research infrastructure such as Daria, Clarin, to also see the use cases that are coming from this side. So one of our framework, the Europeana Publishing Framework, has been built on basically having a definition of quality based on usage scenarios. So we have a system of tiers where we say, okay, if your data is tier 1, that means you will be able to enable those kind of use cases. And you go up the tier, so that means open licenses, completeness of the data, etc. And this mechanism has really helped us to have a better conversation about data with our data provider, so cultural heritage institution, and it has also helped us to develop really capacity in terms of also training and professionals and enabling those kind of use cases we were after. So I think maybe, quality could be something that we speak a bit more when it comes to data spaces, because indeed the idea now with this, I'm really excited to be in the situation of deploying this data space, because that means we can also put cultural heritage data into other data spaces, so having new type of use cases. But indeed, we won't be able to manage if also the quality of the data is not there.
Well, that's a great point, and we talk a lot in the research community about fair, but we don't always talk about quality. I do want to come back to some of these issues. Are there questions from the audience? Tiziana.
Thanks to the panelists. I'm Tiziana Ferrari, GI Foundation, and I have a question moving away from the quality to the exploitation of data. I was quite interested in seeing how different data spaces were being presented, from the Copernicus one, which is strongly centralized with the archive available online, and perhaps the Europeana case, which is completely decentralized with a lot of data coming from museums and cultural heritage institutions. And my question is, what is your view in bridging data and the applications which exploit the data? This is a problem we see in EGI as a federation. Working with research infrastructures, quite often the data is not collocated with an infrastructure for the processing and for the hosting of the applications. So going from federation of data discovery, quality, to exploitation requires quite often a big step, and also very longer term vision in how you will bring data to those that want to use it. So in your data spaces, if you have a comment to offer, how will you bridge exploitation and those who want to do business with the data with your data federation? Is that a challenge in your domain? What are the opportunities, the bridges, the gaps? Do you have any consideration on this topic?
So Valentine, why don't you start with that, but let's let Esther maybe jump in on that after that.
So but my take is when you speak about exploitation, I'm thinking more about reusing the data in your own applications, right? So so for me it comes, the very practical example I have, because it's what we are working on at the moment, is also putting in place some governance mechanism. And that relates also to some technical aspects. So for example, a big piece of work we are doing now is working on a persistent identifier. So everybody is using identifier, but we can see that we still have the problem of maintaining the persistence of resources within our ecosystem, and this becomes even more important when the resources are being reused outside. So we are doing at the moment a lot of work on these aspects, which is in fact not that much related to the technicalities, but also understanding what are also the practices to manage the data. So our approach is really to come back to the source, to data management practices, so that then we can also make sure that the exploitation of the data can be done in a better way, and also ensure sustainability for the reusers of the data. So it might not be completely answering your question, but that's the examples that comes to my mind right now.
Perfect, Valentine. So while Esther is getting the mic, Yuri, I understand you have an editorial, a correction or an editorial note.
Yeah, not a correction, maybe just to avoid misunderstandings, because Tiziana, you said Copernicus being an example of this central providing of data. from the user perspective, that's correct. But the data is actually already in at least 4 physical locations across Europe. Yeah, also to provide geo-redundancy. Yeah, we have to provide this day and night, 24/7, at a very high access availability. As you know, we have this huge worldwide community using this data. So being able, like you said, to use this data inherently already requires us to make the tools federated so that people can process that data wherever they are. And that is done on various levels. I won't go into technical details, but we all use, of course, the well-known big data principles, to be able to process the data where they are physically. And that can be very disparate across multiple physical locations, or even different, say, commercial data sitting in a totally other data center owned by somebody else. Yeah, that I think is the power of the new tools that we have and the federation principles that we use.
Thanks, Yuri. Esther, I hear tiering, I hear exploitation, I think tipping point.
Yeah, good point, tipping point. Coming back to your question to add on, which then hopefully leads to a tipping point. I've been leading the European Open Data Portal called data.europa.eu now for several years, and there we came from making as much data openly available as possible. That was, of course, the aim. Now we're going to data spaces. I believe that the use cases and the data come closer together. So we bring stakeholders together that come together because of a joint aim, like we see in Catena X. We define use cases, so we know what kind of data we need for a specific idea we have in mind for value creation. And this is why I believe, coming from your question, that we are now moving more to bringing these, like the providers and the reusers, much closer together. And speaking of the value, I believe this is the bridge to the tipping point, where we maybe speak a bit more about later on, because if this value and the use cases become more clear to all parties in the data space, this is where we then reach the tipping point.
Awesome, thank you. Daniel, I'm hearing interoperability, I'm hearing governance. How do we support all this with technical capabilities or other?
Yeah, well, I don't know if my view will address Titiana's comment, but again, in my view, or in our view, a data space is not only composed by data sources or data sets, it's also composed by services. In that sense, we can see data as another service, access to data, or data as a service. And this is what we follow in UHAS for data. Our catalog is composed by data, but by services. It's not true that we are not deploying the services in this project, but for instance, in DSBA marketplace, services are part of the catalog . So what I'm going to say is that it's not only data, it's also services, and of course you can include their infrastructure as a services. How we can instantiate that or how we can deploy is another thing that has to be addressed, and it is being addressed in different projects. But again, data space, only data, I don't think it's useful. We have to include services for sure, and where to deploy those services, and the whole picture is data space.
Sebastian, please.
That's a great question. I mean, what is the definition of data space? You have 2 hours. No, to be honest, I mean, go back to the basic. Of course, there is data plus services, but think as a data chain. You have collection, data exchange or data intermediaries, and data processing to develop use case at the end. And in agri-data space, we think that it is really important to separate all these activities. Collection from the farms. I mean, my president is a farmer. He has 30 sources of data, not on his farm, but all around his farm, because this is a decentralized architectures. Then you need to have a data intermediaries according to the DGR regulation, which is really important, where there is separation between data providers and data users. And at the end, you have the activities of data processing. And we decided as AgData to be a key partners for data intermediaries, because we do not need to be part of the transaction. We guarantee that data holder and data users can have great trustful transaction with access identity and certified data set, including quality. So we think that a key point is data intermediaries in order to develop a trustful environment to use and process data.
Thank you. Here we go. Marta?
Good morning. So, a comment. I would like to ask what type of governance for the data spaces, because you mentioned we've got data, we've got services, but I don't hear you speaking a lot about the end users. Just to give you, I'm working in the health data domain, and the access to the data is really critical. Just think about something about the data, why we need to create data spaces. It's for the end users. What is the cost of one Sentinel pixel? It's probably very huge. What we would like to see as users is to use this data as many times as possible. So you create it once, and then you use it as many times to create knowledge for the benefit of the society. And what is missing here in this discussion, to my point of view, and yesterday Pierre from GaiaX had a good comment, we are needed service level agreement, we are needed service level objective, service level indicators to be sure that we are designing the data spaces in accordance to a logic, create knowledge for the benefit of the society.
Thanks very much. So who would like to pick up on that? Sebastian, you actually, agriculture is the closest to the health world, I think, in terms of its governance. Tell us about that.
Yeah. The goal for farmers is to provide food to EU and non-EU citizens. And okay, so it's clear that we are really close, speaking about values. But I mean, to be honest, I'm not going to speak about governance, speaking about agreement, contract, technical issue. I'm going to speak about business. I said that we have in Europe 10 million farms in front of 4 multinational companies from agrochemistry or machinery, and this is a question of business. And the goal for the farmers is to get platforms in order to deal with the asymmetric market between small and medium companies and big companies. So this is a question of business. And the goal of the farmers being a part of the capital of the company, with the support of the French and EU partners, public partners, is to find some solution in order to find platforms in order to control or to make regulation between small and medium companies or farms in front of big multinational companies. And the goal of data intermediaries is specifically not to fight against digital integration of small company in front of big companies. So this is a question of strategy and business. And so when we spoke about governance, we need to speak about relationship between small actors and big actors.
So maybe I can ask Gianluca, you have a lot of small actors and big actors, and I'm wondering if you have some ideas about governance in that area, how to mediate the power difference in the power business.
Yeah, that's indeed true. Of course, we are all somehow users of grid services, and also it's quite a regulated business. So there are the aspects related to the critical infrastructure, so some data that somehow are limited or are intended to be limited in being shared or being publicly available. And there is the whole privacy related aspects, because you can infer a lot from data consumption, for example, from homes. So there is a challenge for sure. There is and I agree, there is the need to involve everyone, to have a fully participated governance structure, because cannot be imposed, cannot also be somehow centralized because there are aspects that are relevant at national level or regulated in some countries in a different way. So there is also the need to harmonize and have a structure that allows that in a participated way, harmonize the roles, the rights. We're talking about trust, we are talking about quality of data. That's also something that is part of the picture and is part of creating an ecosystem where everyone can participate and has to participate and can bring value and maximize the value. As you said, the more a single data set is used, the higher the value, or the lower is, let's say, the cost it has for the rest of the community. So that's also in the interest of everyone to maximize that usage of data in a single sector or with the interaction with other sectors. In the case of energy, it's kind of natural to be intersected with many other sectors. So that's also one aspect to not be in just on the energy vertical, but see where there are the interconnection points and the possibilities to extend this participation.
Perfect, thank you. Esther, data sovereignty versus enabling the tipping point. What do you have any thoughts on that?
Well, I actually wanted to say something else.
Oh, I'm sorry.
No, that's great. I love you throwing the ball. Let me quickly get back to your comment, because you encouraged us to speak about the end user, how you call it, and service level agreements. And while I agree with your point to think about the value that is created by the people that use a data product, I have the feeling that selling digital products is something that is not new, and creating service level agreements and a business model, for example, pay-per-use, freemium, we have been there. That's not that new, and maybe you mean something completely else, but this is what resonated with me. I believe what is newer is making an effort to understand the mutual value proposition, not the value for an end user. We don't want a end user to use the data as often as possible, like a digital magazine. Actually, what we also want is to have a data space where we understand the mutual value proposition. And maybe coming back to Social Science 1 is when the department at Harvard for social science realized we have good data and in our way of gathering data, that's good, but Facebook gathers much more data. And with that data, we could have amazing insights. So they reached out to Facebook and they created a very good governance to, in a privacy preserving way, use Facebook data for social science. And then Facebook realized, well, actually these great minds and university science can help our businesses because we are a bit stuck with advertising. We've reached our maximum users at the moment. We are a bit plateauing. So how can we make other and better business? And this is where the university researchers help Facebook to become a better firm and create social impact. This is a mutual value proposition which doesn't need to have an end user which uses a data product as often as possible. This is how we make better society, better business. And this for me is a utopia of a data space, a bit more than having a data product being used often. Thank you.
You're shaking your head, Yuri.
Oh, that's great.
Okay. Any other questions from our audience? Yuri. Another Yuri. A different Yuri. Different spelling.
Okay, so multiple data spaces. Do you have actually defined metadata definition process, standard template in each of data spaces? Are they actually can be compatible or interoperable? Can you integrate data from different data spaces? What is different definitely happens in data science. And one more question is data quality. Do you have data quality procedure?
Okay, well, I know that Valentine can answer the second question. She just told us that, but perhaps we could start with the metadata question. How who has dipped their toes into the question of cross-sectoral data exchange and whether it works? Valentine, pick that up and we'll go left to right.
Yeah, I can start. So it's a good question. So indeed, for us, within the cultural heritage domain, so we have built a data model that accommodate the needs of the different domain, whether it's museum, libraries, archive. And the way to do that was indeed not to create something completely new, but to rely on standards that are already existing and that are being reused elsewhere. So in fact, our data model is a combination of patterns coming from Dublin Core, coming from the OWL ontology. So we are using basically a lot of W3C standards, and by doing that, our hope is that then it will make it easier to integrate with others, because those standards are quite of the common layers that is provided across the board. So of course the semantics are a bit different because we still operate in a very domain-specific environment, but the construct in principle allows interoperability. So yeah, yesterday there was this great presentation from someone from W3C, and there was a list of standards, and I was like, yeah, we use this ODRL, we use it, you know, for the right statement. So in a way, yeah, having these common layers is probably what will make it possible to integrate our data together, even if the semantics might be slightly different.
Perfect. I know that Sebastian wanted to talk on this, maybe Yuri also. I don't know who would like to speak next.
Speaking about interoperability, I mean, before speaking interoperability, cross-sectorial, we need to do that into the same sector. For example, in farming industry, we have 4 main platforms in Germany with AgriRouter, the Netherlands, and Belgium and France. So we already faced to this issue. How did you? There is no problem speaking about technology. I mean, we are all implementing the Gaia X framework, so there will be some solutions speaking about technological standards. So that will be done, and it's ongoing. The main problem we have to face right now is speaking interoperability in terms of business model. Imagine, in one country, you have a platform paid by taxes, so this is free of charge for the final users or a subscriber. And in France, we are a private company, so we have a platform available through the software as a service business model. So imagine, I mean, there is interoperability between platforms. Technically, point of view, there is no problem, but the users or the data owner will go to the free of charge platforms, and after that, how can I make business on my own platforms? So that's why a business model governance is really important about interoperability. And just to be really quick about interoperability, there is a technical standardization. We have the solution. We are all here to do that. But after that, we need to have data standardization. This is specific for each sectors. And we speak about ontology, semantic, and all that stuff. And this is the job for all sectorial data spaces.
Daniel, you wanted to jump in on this?
Can I quickly add one thing also? Maybe after you. Is it also about metadata standards?
Yeah, this is what I want to say. No, because I went very quickly through this project, the Data Spaces Support Center. I showed you the picture of the blogs, and also I showed the picture of the different sectorial data spaces with whom we are talking about all this aspect. Okay, so we are having interviews with all the sectorial data spaces, those that are now running, but also the future ones, and we are specifically asking for what models, metadata standards they are using, because the final purpose, I don't know to what extent we will be able to achieve, is to provide some kind of synergies and collaboration between the different sectoral data spaces. Again, it is an ongoing exercise. We are still collecting those standards, those models, those metadata, sectoral oriented, and our work is to come up with some kind of proposal synergies that somehow includes all those aspects. It's not easy because, as Sebastian was mentioning, it's not only about semantic or syntactic interoperability. It's about how we attract users, and again, researchers are a type of the users of the data spaces, or should be. So again, it's different types of interoperability, not only semantic or syntactic, but at least this is what we are doing in the project. Maybe you want to complement? Because
please.
Very, very quickly. I think what we can conclude that we have standards there and everyone is working very hard to use the standards and have less standards and have the right standards. And we've been through that the last decades. And I greatly understand some impatience, as many companies feel the same way, being like, should we wait on standards or should we just do our own thing? And what I also like is that we're working, for example, Catena X together with DLRG is working on not just connectors, but also a technological bridge which translates different metadata standards as an intermediary in a way. So, for example, tier 2 and 3 suppliers, which are often smaller companies, can keep their metadata model, which works for them. They don't need to change to adhere to standards, but this translator, let's call it that way, in the middle, then kind of reconfigurates the metadata model to make it interoperable with, for example, the Catena X standards. And this is how we can lower barriers and get the move on, get the tipping point.
So Yuri wants to jump in on this, and maybe Gianluca, I see you busily writing, so I assume that you would like to speak.
Okay. Yeah, first of all, I fully agree with the other speakers. Yeah, very good contributions. Maybe just one more aspect I think that is to be highlighted, and if you read the data space standards, you will see that also a very important role actually in that is the moderator, yeah, of a data space. So there must always be this instance, yeah, that make sure that all these things are managed in a proper way, yeah, to get conflicts out of the way, to find the best, say, common ground to exchange, to make business on data. And that is to be taken very, very serious, yeah, I think, for every data space manager. And that's also why we are very happy that the European Commission has taken this responsibility and has defined a number of common data spaces that will be essential for Europe, yeah, like the health, like the energy, like the agriculture. And I think they are the best, yeah, to drive this, to make sure, yeah, that we will have this neutral moderation with a business, with a research, and of course with a policy background in mind, yeah, to get the best out of it. Will not be easy, but we need to have this moderation.
Do you want to jump in on this, Gianluca, or we also have a question from the audience? Okay.
So we always say the metadata interoperability always comes, yeah, it's our favorite technical easy hook, yet where we need it. The Commission has a long-term view of having a common European data space. So not only we need to define the standards are needed and models within the sectors themselves, but they have the view that everything is going to work cross-sectorial. And in this point of view, there are very important initiatives like Daniel, the Data Space Support Center is going to give us all the answers. There are also setting up the European Data Innovation Board. I would like to know if anyone of you has any views of, they're going to give out guidelines, they're going to tell us you must use the big one great standard, or somebody's going to make a lot of money making translations, yeah, from so many standards that we have around the table. Views.
Is the European Data Innovation Board going to solve all of our problems? No one wants that one. Okay. Well, I will say, you know, and Marta and I are working together in the Green Deal data space, so our problem is not standards, our problem is too many standards. So, and how do you work with that? So, sure, Patrick.
Just to comment what Yuri was saying, for Europe, for instance, it's very important to understand what standard to do what. So I'm just going to mention one standard for cataloging data sets on the web, and it has been mentioned yesterday during a session. The European Commission, since a couple of years, is promoting DCAT AP, which is domain agnostic, and I think this will be one governance recommendation for all data spaces to adopt such a standard that you can fine-tune to your domain. So I was expecting and to answer the question of the participant on the back. It's very important for the different communities to agree on some technical components they are building the data spaces. So back to what you said, the governance is essential in this.
So is DCAT part of the plan across the table here? You already have it. Europeana already has a system, so...
Yeah, I mean, we are using, we have a dataset application profile with DCAT, so we are not using it very much at the moment, but I think indeed it's also the question of granularity. Within our data space, we share data at a very granular level, but indeed, the first approach for interoperability across the data spaces is probably to look more at the level of the data set and indeed identify what are the key elements. So I have a colleague that refers to, data space is a space. So what do you need in space? You need a point of reference. So, persistent identifier. You probably need to have a license, a right statement information so that it's clear how you can reuse it, plus a couple of key metadata, and that's it. So I think this should be something that should be quite achievable. At this level of granularity, it should be something we could manage to do. And DCAT is indeed, I think, the best solution for this.
Anyone else want to jump in on that from your respective? So, does the Copernicus data space use DCAT?
I will check it.
And Ag Data Hub? If not, we will. I'm curious. This is not a value judgment. I'm just curious.
As Daniel said, I mean, this is an ongoing process. I mean, of course, on the principle, we agree to implement the same technological standards in order to make interoperability. This is the way. If not, we are going to die in our silo. That's a nightmare for farmers. But the goal is, this is the goal of my colleague from the DSSC, Data Spaces Support Centers, to define and to finalize these standards. And after that, we will implement, of course, these standards. So good luck, Daniel.
Well, we are not defining the standards. We are collecting from you. So yes. Of course, in DSBA, we consider DCAT as part of this definition of language definition and so on. And of course, for what we saw in different interviews, DCAT is present many times. I don't know if in all the data spaces, for sure not, but at least it's quite common to find it. Yeah.
So we're at the end of our session. I'm wondering if I could maybe get a final comment from each of you. Just your key takeaways from the conversation. I'll start with Gianluca, maybe, because he's been hasn't been as involved in the last couple of questions. Let's just pass this one. Oh, here we go.
Okay. I'm talking from maybe the youngest or the earlier development stage data space. Energy, I think it's a little bit behind. So takeaway, that's why I was taking a lot of notes. There are many aspects that are relevant for cross-sector, are relevant for intra-sector. I always focus on interoperability, but I think also governance is a very good question and a very important point. So from the energy perspective, there is a lot that we can learn from those that are a little bit more advanced. Especially in terms of what did work, what are the good practices, and what maybe is good to avoid. So we are eager to look into, and maybe the Data Space Support Center is also the place, what is already there and what we can take from, and maybe at some point also contribute. So we are.
So you intend to be a fast follower?
Hopefully, yes. Fast. I will not make promises on fast, but at the moment, yes, we are following.
Okay, Yuri.
Yeah, it's always good if you see the complexity that we face to look back. I remember very well more than 10 years ago when we started the first discussions on cloud computing in Europe, where it was still in infancy, and like with Tiziana, we were one of the fighters for this, and now if we see what has changed, it is tremendous. I think now cloud computing is the default. It is. Why don't we do it with cloud computing? This question is coming. And if I see from today's example, then the data space development, yes, it's still rather new. We started maybe more serious looking into it about 3-4 years ago. And then when I see today this conference, what we are talking about, it's great. It's moving. We are getting there. It will take maybe 2 or 3 more years, but it's great that we are really pushing this.
Valentine, maybe a quick thought?
Yeah, for me, well, it's nice to see that technology is the point that can bring us together. You know, we can have discussion across the data spaces through technology. What I'm wondering is, what kind of conversation do we need to have also to not be silos in terms of usage of the data? What will push agriculture to work with cultural heritage data, and vice versa? You know, what kind of conversation do we need to have to make sure that we are not only collaborating on the infrastructure level, but also truly exchanging data and developing use cases together?
So maybe when the farmer plows up an artifact.
I have a lot of use cases in mind, you know, like you have historical data about the weather, a period where, the collect in the fields were bad, you know, how that can be used in the context of the agricultural data space, for example.
Perfect. Sebastian?
Yeah, I mean, data space is only a tool. We have to know what we are going to do with. And for farmers, this is really clear. First of all, to find some solution to adapt their production to the climate change. And the second thing is to improve their revenues. And that is our goal together. And if we can find some resources in other data space, we will go there and we will develop business together.
Esther?
Here we go. For my final statement, I would like to pick up the note of this positive reflection on where we're standing, looking at Europe trying to do it all at the same time, having the data spaces support center, figuring out how to do it, and the data spaces running at the same time and just leaping forward. What an amazing step for risk-averse Europe. And I think we can be encouraged by that. Data spaces are multifaceted. It's legal, it's technical, it's governance, it's business. We cannot be experts on all of these in detail, but that should not stop us from trying to understand it better. We are already among the top % of people that try to bring this forward, and just because we don't understand every detail, we don't have an answer, or we have different opinions, should not stop us from bringing this forward. And just take an example of Europe and just taking the leap and making it happen.
Tremendous. And final word from the final panelist?
Thank you, Mark. Well, not only for what I saw today here in the meeting, but what I saw in the whole conference, the conversation that I had, also the presentation that I saw, I realized that there are many ongoing activities and a lot of knowledge in the community. So for me, rather than deploying or developing new things, I think it's a matter of bringing everything together somehow, or to leverage what we have, instead of just starting from scratch everything. So again, it's a matter of organizing ourselves, all the communities, BTBA, EOS, EGI, the AI community, and so on, and try to, basically what we are doing today, what we are doing in Data Space Support Center, to bring all the pieces together. Because again, I don't think it's a matter of developing new things, it's a matter of bringing the value things at each time, and from that, build this complex ecosystem that at the end of the day is a matter of agreement in common rules and governance, rather than, again, reinventing again the wheel and again. So I think that this, what we are doing with this conference is a huge step towards that, so perfect.
Tremendous. Thank you very much. I'd like to, let's all thank our panelists very much for an exploration of data spaces, the final frontier. So, thank you.
Hello, good morning everyone. Welcome to the CS3Mesh for IOSC final event. For those that are more back in the room, if it's okay for you, would appreciate you are welcome to sit in the front rows. So it will be closer, the engagement between the speakers and the audience. So I've been calling this the CS3Mesh for IOSC final event. CS3Mesh for IOSC is a project behind the ScienceMesh. But also the official title of the event is ScienceMesh Unlocking Open Science and Collaborative Research Landscape. We kind of call this the final event because the project is about to be over, but this is not the final chapter of the ScienceMesh. This is just the beginning. And here we are happy to show you the work we have been developing during these years. So here our event today will be split into two parts. So in the morning we'll provide you an overview what the ScienceMesh is about. We will explain how the users, software developers and also service providers can join the ScienceMesh and why they should do it. We'll have generic presentations, but also share some stories from use cases from different science fields, from Earth observation, astronomy, social media analytics, so you are aware how useful this tool can be within your daily life. In the afternoon, it's a more technical scope, so we'll have some demonstrations on how the ScienceMesh works. We have the invitation workflows demos about the on-cloud, the next cloud, but also, since, as the name of the project says itself, the ScienceMesh is also a very relevant output for the IOSC. So we have some panel discussions focused on this. We also have a presentation from our colleagues explaining how the CS3Mesh for IOSC, how the ScienceMesh and how IOSC can be happy together. And we also would like to thank the invitation from our colleagues from EGI for hosting our event here. We are very happy with this opportunity. And you may have noticed that there are some EGI roll-ups spread around the venue, and they have these very nice punchlines saying it's where research meets computing. And in my case, I like to think that the ScienceMesh is the place where collaborative research can be done in an easy way thanks to a smooth data sharing and data synchronization. Anyway, let's kickstart with our event. So I'm Rita Menezes, Project Manager, part of Trust IT, and I would like to invite my fellow colleagues who are here to present what we have been doing. We are going to start to welcome on stage our coordinator, Jakub Mączyński, who's going to provide you an overview about the project, CS3Mesh for IOSC, and also the ScienceMesh itself. Welcome, Kuba. We are very happy to have you. Just a quick overview of Kuba's professional experience. He's actually from Poland, so he's speaking at home. And he's a software engineer and researcher at CERN, based in Geneva, as the majority of you know. He has a wide portfolio of activities, has been involved in projects from high-energy physics, theoretical physics, medical radiation studies, and also telecommunication. Kuba, the floor is yours. Welcome.
Thanks, Rita. Actually, I would like to extend, first of all, I would like to start by extending many thanks to you and your team for organizing this event. And because it's been quite a lot of effort and dedication you've been putting to this. So thanks a lot. Okay, so do I have my slides here or? Yes, so actually it's the first time for me in Poznań because it's pretty far away from where I used to live in Poland. But I found it's a nice place, so well done, local organizers. Okay, so as Rita said, so the final countdown for the project does not mean the final countdown for the results of the project. And we'll explain you a little bit what we have done. The motivation, why we started this project, what was our approach, and also how we see the results of this project live on beyond the timeline of the project itself. So CS3 Mesh for EOSC, everybody agrees, is a horrible acronym. Actually, what the project is about is building an interactive and agile/responsive mesh of storage, data, and application services for EOSC. And this is the service that we call ScienceMesh. So it's a project, it's a 3 years project, which actually got extended by 6 months. So now it's a 42 months project, and it will end in 1 week's time, end of June, end of this month. And for us, it's an opportunity also to show to you what are the practical outcomes of this. So you'll see some demos, you'll see some user stories, you'll see some of the elements that are already deployed in production, and some of the elements that are still waiting to be deployed in production. The project responds to the call on the EU Horizon 2020 project and for excellent science, responding to a call on prototyping new and innovative services for EOSC. We have 13 partners, and you have the project website here in this link, and this is where we document the project activities, but there's also the ScienceMesh.io website, and this is where we put all the artifacts that we want to endure beyond the lifetime of the project itself. So this is the product of the project, okay? So the problem that we wanted to address starting this project was essentially several things. First is to reduce the fragmentation and data silos of the European research. So when we looked back in 2019, we realized that it was like around 500,000 users of EFSS storage services in Europe. And all of these different services actually were pretty much silos from 2 points of view. So from the point of view of being a silo, an institutional silo, so actually it was pretty difficult for these users to collaborate with users on other service nodes. And they were also kind of deployed in the pretty much in the isolation from other on-site services for research. So the goal for our project was to make it easier to collaborate on data products between researchers, scientists, and users across the existing boundaries, so be it institutional infrastructure in the country, and also to introduce more productive workflows that interconnect storage, compute, and applications. So essentially to take practical measures and steps to encourage data reuse, sharing, and applying of FAIR principles during the entire data lifecycle. Because we believe that if we bring closer certain functionalities, if we make it easier for people to reach out to functionalities that we want to encourage them to use, like for example, annotating with metadata early on, this is an opportunity for us actually to put these practices in practice, okay? Because one thing is to discuss about concepts on what people should be doing, but typically there is quite a high bar for people to do stuff. You know, people do their research, they are very short on time, so they just take all possible shortcuts, and the last thing that they think about is preservation of data or proper metadata annotation, all of that. And this is completely understandable. This is how it works. You're just focused on what's your immediate objective and the goal. Now, what we're trying to do is have an offer which makes it easier and actual advantages for them to introduce certain concepts early on during the entire data lifecycle. And then we wanted this, so what we wanted to do is to prototype a service that could be offered as a part of the global EOSC platform. And you know, as you know very well, what the EOSC platform is actually has been evolving for many years now, so it was not very clearly defined. And it is still evolving, but the vision here is pretty clear. So we wanted to make sure that if you want to access certain functionality, you don't need to export your data sets. You can bring this functionality to where the data is, for example. And also another common theme, you know, between organizations, you don't need to resort to the, let's say, to the hyperscalers to have a common service stratum, common service. There's a risk that this laptop will fall down. you know, as a common service stratum between organizations, right? So this is this fragmentation, this silos. If we have two organizations that want to do something together, well, what's the common stratum layer? You just go to some hyperscaler and try to use that platform as a common platform, right? And that's sometimes is good, but sometimes problematic from many different points of view, costing, policy, what have you. Okay, so now how we wanted to address this? Essentially, we wanted to capture the momentum which was generated by community work on innovative services, and we focused on sync and search storage. Sync and share, essentially, you know, it was initiated, and let's say the easiest metaphor is the Dropbox one. So we were interested in seeing how Dropbox model can function for science. You know, what's its place? And actually, sync and share storage is interesting because the sync part makes the data available on all devices. So if you have some data in the cluster, in your HPC cluster, with this system, you can make a subset of this data available on your laptop, and vice versa. Okay, so it's actually it makes for a much more complete data access continuum within your research environment. And sharing part is essentially makes the data accessible between users and user groups. So it's essentially a very easy way of making data accessible to others. The other principle is we wanted to do it, you know, we didn't want to have just a kind of a research project in isolation. We wanted to plug it into whatever the European EFSS industry is doing. So we have a collaboration with a couple of these, like OnCloud and Nextcloud. And also, another important component is the community. So essentially based on the work that is done in the community. So for the sync and share services, we have this community which is called CS3, but there's also many other things that are going around. So the way we wanted to do it is actually to innovate, do something innovative, but to reuse and leverage on existing elements as much as possible. Okay, not just a blue sky. Okay, let's start from a blank page and let's try to think of something that may or may not make sense. No, it's more like, okay, let's see what we have, what is already successfully used in different institutions, and let's see if we can propose some workflows based on these elements. And here, you know, so we've took existing interoperability protocols, EFSS products, existing services, and we try to interconnect them in a more meaningful way for the users. And also, it's an activity beyond prototyping. Even though the call itself is prototyping new and innovative services, we really thought that, you know, it only makes sense if you think of sustainability early on. So how do we do that in a way that when the project ends, which is in 7 days from now, these results simply do not disappear, okay? And clearly what you want to produce is more than just the reporting and deliverables, paper reports, right? You want to have something that lives on. So this is also how we approach that, including some elements in production early on. So we do have some specifically application elements that have been developed by the project in production already. That's very important because it also allows you to contrast your ideas with the real users, okay? And of course, test driving with user communities. There are several different user communities. You will hear more about that later on. Okay, I think I'm taking way too much time for Rita's schedule.
We should wrap up now.
Yeah, so I'm wrapping it up. So we have 3 dimensions just to set the scene, okay? So there are 3 main dimensions of this project. One, we create a trust-based federation between the storage systems. So essentially this means that individuals on different systems, do I have a pointer? Okay. So these fine individuals who are on different systems, one is at CERN box at CERN and the other one is on the Surf Drive in the Netherlands, they can exchange data easily, even though they are on completely different services, different countries, different institutions. They do it through a very streamlined UI. Okay, so it's a very easy user experience, and it's enabled as a kind of a global service between the participating institutions. The next aspect is we also talk about the application platform. So essentially, we have a technology stack here that allows us to achieve interoperability between these different service nodes and also between the research services. And here we are talking about 4 different application types. Okay, data science environments incarnated by what everybody has these days, which is Jupyter notebooks. So how we interconnect meaningfully the Jupyter notebooks into this distributed workflow environment. Open data systems, so this is open science repositories. Collaborative documents, so you need to collaborate on some documentation for your project. You can do it in the same space. Sorry, it goes like this. And on-demand large data set transfers. Here, we did not want to overbuild whatever is already available as large-scale data transfer infrastructure, but for ad hoc transfers between when you want to make a replica of some data sets, that's also possible. And the third aspect is the connector of the federations. So we've collaborated with a number of entities on understanding how we can use ScienceMesh and interconnect it with other infrastructures. So for example, how to use the EGI check-in in order to access and authenticate and access ScienceMesh nodes, or how to enable things like escape data lakes and data that is stored in these lakes to be visible within the ScienceMesh infrastructure, so that people can easily share and access these results in both directions. So that's it. This is just big lines, and we'll see more in detail in the subsequent presentations.
In the next presentations.
Yeah.
Thank you very much, Kuba. Round of applause. I think we only have time for one question. Is there any question from the audience? Here? Any questions from the online audience? Okay, so, sorry?
Oh, sorry.
Yeah, so one very important information is that each time we have a session, we welcome your questions for those that are here, but also we have an online audience, so they are welcome to make their questions by writing on the chat they will see on the Wolva platform. And the next speaker is already here. He's eager to start his presentation.
Yeah.
Ready on stage. What's your name?
Maciej Brzeźniak from PCC. I was within the project. I was responsible for the work package, working on integrating applications within the mesh. And as Kuba already explained, the mesh actually integrates systems and applications into at least in 3 dimensions, it was said, but I will focus on the vertical integration, which means enabling to use the different kinds of applications which serve various parts of the typical research workflow. So we integrated these applications with the sync and share systems in the backend. The presentation, which will more focus on the horizontal integration, actually building the actual federation of multiple nodes distributed geographically and also organizationally. This will be presented more in detail in the afternoon session after lunch, starting at 3, where we will more focus on the mechanics and logic on the related to putting different sites together. Here, as an introduction, I wanted to bring your attention to the fact that within a ScienceMesh, we already at the stage of preparing the project, we envisioned 4 main application scenarios where we wanted to provide a, let's say, built-in support within the federation to enable users to use their data efficiently. So it started from the observation that building a federation, the horizontal integration, which we do by nature, is one thing. And on top of this, we want users to reuse their data. For instance, we want to enable cross-site data science style of data analysis. That was actually the reason why we integrated this key 4 applications already into the concept and the proposal. More on the practical side, these areas actually include very concrete products which we integrated into the mesh. So we also tried not to reinvent the wheel and work with the components which are recognized as being the de facto standards or default tools in particular areas. Starting from data science, the Jupyter Lab is obvious choice. On the open data system side, we started from the existing, we started our work based on the existing system dealing with research data management, and we built in the feature for depositing the data from this system to popular data repositories. On the collaborative editing, documents editing side, we of course took these usual suspects, such as OnlyOffice and Collabora listed here, but we also worked on integrating tools which are more specific to code developers, to the research environments where people use not that different kinds of tools, which are not that mainstream ones, but still very popular, like for instance CodeGMG. And on the data transfer side, it was already said by Jakub, we wanted again to enable not only storing the data in sync and share systems, but also wanted to open them and make them a kind of interface towards the large data infrastructures. By providing interface, we mean the situation when a user could get to the, let's say, simplest possible data management system, such as sync and share, which doesn't constitute a doesn't constitute a steep learning curve. So he could easily start, but still have an access to large, scientifically interesting data sets through the built-in integration, and that was actually the assumption. So, oh, yeah, PowerPoint has some issue, so let's wait. Okay, so actually, I think I could actually stop here. These 4 areas were covered through 3 years of the project work. In every single area, we prepared proof of concept, but we also have production-ready existing installation at the partner sites. And what is important is that we also, by offering the applications which actually address the practical scientific workflows, we also kind of open the doors to the users so that they can immediately see the benefits of this integrated approach. And we managed to onboard several new institutions which are not initially included in the partner list. And the presentations which follow after my introduction actually show these cases where the adoption actually happened and it resulted in production-ready solutions. Okay, so thank you very much.
You're welcome. Round of applause. Are there any questions for Maciej before we go to the next presentation in the room? Okay, give me a second. Would you mind to say your name before posing the question?
Sure. Thank you so much for the presentation. I'm Sagar from SURF. My question is more on the on-demand data transfer side. How easy it is to instantiate this on-demand data transfer for a normal researcher? I'm not talking about a researcher from the big science collaboration community.
Okay, so let's maybe I will start the answer, and maybe this will be extended by Ron, who was actually coordinating this task. But starting from the easy answer, we wanted this automated, let's say, managed data transfer feature to be as easily available as all the other features in the sync and share system. So normally, if you have some experience with using sync and share systems, you know that your data are organized in your folders, your data, shared folders, group shares, and so on. And we wanted this transfer mechanics to be as easy presented, so that you in fact have some kind of your view on the data which are transferred is, in the ideal world, similar to actually some special case of the shared data. You just see them like they would be local. You can access them on demand. That's actually this on-demand aspect. So for the end users, beside the higher latency while accessing this data which were stored remote, the idea is that in terms of his workflow, his interaction with the sync and share, nothing changes. I mean, he could, of course, nothing is perhaps an exaggeration, but that's the approach we wanted to offer.
And how does it work in terms of geographical context?
And this is maybe the more difficult part of the answer. I mean, we, of course, to deal with geographical distribution, you have to implement and integrate mechanics which actually deal well with latency. That's why we use these tools which are listed here, like starting from rclone, which already can use multi-threaded transfer to just overcome the latency problem, but also these solutions which are well established in applications such as high energy physics, where you deal with really distributed infrastructure and large sets of data in terms of many terabytes. These all tools support multi-threaded transfer and so on, some kind of state control of the transfer itself, automated restarts of the transfer and so on. So we kind of reuse the mechanics which were developed for years for dealing with large research data, and we interface to these mechanics. We're not like replacing them. We wanted to provide an interface, transparent interface to these.
Thanks.
Thank you very much. Any further questions here? Do we have online questions from the audience? Not online questions. Okay, thank you very much, Marcia. Round of applause.
Thank you.
Thank you very much. Ball is crush.
Now we have the remote presentation. Okay. Okay. You'll manage.
Okay, we are getting ready for our next session, which will have the presentation of the use cases we had in this project. So I would be happy to call on stage my colleague Marcin from Software Mind, also my colleague Ron Trompert from SURF, and we also have two other panelists, one from remote, which is Henrique Tejedor Saavedra, and we also have a fourth panelist, which is Leonard Hofditz. Unfortunately, he cannot join us in the last minute, either here in Poznan or online, but he prepared a recording of his presentation. And if you have questions regarding Leonard's presentation, we have colleagues here, namely Holger from University of Munster, who will be happy to help you and reply the question regarding to his presentation. So, maybe a first overview of our dear speakers. Let's start with Marcin. Marcin, he's an experienced system architect and research and development project manager with more than 20 years of enterprise software design and also development. He is also the founder and the leader of Big Data Lab. Regarding Henrique, who is joining us online, he conducted his PhD research as a member of the Grid Computing and Clusters Group of the Barcelona Supercomputing Center. Since 2015, he is part of CERN, and he leads the operations in the SWA. Regarding Leonard, the speaker who provided the recording, he is a member of the Business Information Systems and Digital Transformation Research Group at the University of Potsdam. Regarding Leonard, the speaker who provided the recording, he is a member of the Business Information Systems and Digital Transformation Research Group at the University of Potsdam. Regarding Leonard, the speaker who provided the recording, he is a member of the Business Information Systems and Digital Transformation Research Group at the University of last but not least, we have Ron Trompert. He's the group leader of the online data services group at SURF. He's also responsible for the SURF object storage service, which is known as SURF Drive, and he has been involved in the LOFAR long-term archive. So thank you very much for being here with us, also our online speaker, and I would like to pass the floor to Marcin, who will start the session with his presentation and demonstrator. Welcome.
Slides?
You can use your computer. Just
don't want to.
What is the mouse bar?
Where is it? Here?
Yeah, is this?
No, the second one. Oh no, the first one, yeah. Yeah. Okay. No, not.
The second or the first?
The first is the restart. Yeah. Ah. Yeah. Okay. This is the same slide. Okay, I just wanted. Okay. Hello. Hello. Hello, my name is Marcin Sieprawski. I lead Big Data Lab in SoftwareMind. I'll present how Voila and Voila dashboards can be used to create powerful interactive dashboards based on Jupyter notebooks for Earth observation data science projects. Let me start with a very brief introduction to data science environments of ScienceMesh. As a core component, we created a Jupyter Lab extension integrating with ScienceMesh, which allows us to provide additional sharing and collaboration features in Jupyter Lab. The share functionalities are available directly in Jupyter Lab Fire browser, the sharing buttons, entries in the menus. The share window presents the status of the share, the list of grantees, and it allows searching across the connected federated sites of ScienceMesh for users by name, surname, full name, username, or email to create new shares or manage shares, like changing the role from viewer to editor. The shares tab that we added allows me to see the file shared by me and also the files shared with me. Collaborative workflows allow a group of users to work on the same notebook and are powered with ScienceMesh locking mechanism for override protection. The file locked pop-up allows to open the locked notebook in read-only or create a copy. The collaboration workflows will be demonstrated in a moment in high-energy physics talk. I'll focus on the interactive dashboards. So we can share the notebook as read-only for the viewer role, and then the users, the grantees, cannot change the notebook, cannot change the code. But the code cells are still visible. Something plugged? Okay, again. Sorry about it. 5. Fortunately, I know Polish, so. Voila allows to create automatically standalone applications or dashboards from Jupyter Notebooks in a way that only the interactive outputs of the notebooks are visible and the code sources are hidden. And Voila simplification library developed by JRC, this is dangerous. JRC, the Joint Research Center of European Commission, the Earth observation use case of ScienceMesh. The library helps in easier creation of complex combined Voila dashboards from the notebooks, and the library is now ready to be published and as open source. Voice library facilitates using advanced sets of widgets and combining the widgets in a consistent way with less code. So those are the actual elements that allow users to interact with the notebook's outputs. Voice library also helps integrating interactive maps, CSS3 tricks for supporting full screen and responsive dashboards for various screen resolutions, plots or custom charts based on vector graphics and supporting the events in the JavaScript. As you can expect in this talk, the library also has a big set of features supporting creating powerful interactive visualizations of geospatial data. Here you can see the dashboard that allows interactive creation or definition of such a visualization based on a couple of sets, and the user can define the visualization following self-service BI trend. And so probably this is too much for this laptop. Okay. Okay, so this is last slide. So finally, this is the summary of ScienceMesh Earth observation use case. The Joint Research Center of European Commission created JRC Big Data Analytics platform with multi-petabyte infrastructure, and one of the service layers of this platform is based on Jupyter Notebooks, allowing interactive analysis and exploratory visualizations based on geospatial and non-geospatial data. And Voice Library is used inside European Commission Big Data Analytics platform to communicate research results to a wider community. So this is enough for talking about visualizations. So we can see multi-page dashboards, geographical visualization, interactive maps connected with various widgets, the changes or interaction with the widgets change the data that are displayed, and also data in other widgets. Yeah, the map is interactive. The interactive maps combine the tiles of the map with the augmented layers of data. Also allow additional layers for other components, the charts. We can connect with various data sets. So this is important that this supports very large raster data that can be visualized quickly. Again, we can see multi-page dashboard. Can drill down to detailed data. You can use the data catalog. Thank you. Hope you liked the music. So basically, what is if somebody is up to date with current business intelligence and various big data tools, this is nothing unexpected. But so there's a lot of solutions like that, but usually they use very expensive tools. So we do that in many projects, but usually it's backed by some very expensive platforms, and this is all created with open source software, and can be created quite easily. So yeah, once this library, the voice library, is is open source, be invited to use it, and also check our Jupyter Lab plugin for ScienceMesh data science environment. Thank you.
Thank you, Marcin. So this was our Earth observation use case. 4 questions, if I may, for the benefit of time, if you have any, please save them till the end of the session. So we'll see the presentation of the 4 use cases, and then at the end we'll respond to some questions. Thank you, Marcin. Regarding the computer, we are working towards to get a new computer, so that is work in progress. And in the meantime, it's time to hear to our online speaker, Henrique Tejador, who will talk about the high energy physics use case. Henrique, are you online? Can you talk? Hi. Henrique?
Yes, I'm here.
Hi, good morning. How's everything on that side? Wait a second, we cannot listen to you. Now, can you try?
Yes, hello, can you hear me?
Yes, we can. Welcome, and thank you for joining us remotely.
Yeah,
whenever you want, we are ready to start.
Shall I share my screen then?
Yeah, sure.
All right. Okay, I hope you can see my slides.
We can.
Okay, all right. So yeah, thanks again for the invitation. I'm Enrique Tejador from CERN, and I'm the service manager of SWAN. SWAN is the service that we provide at CERN, which covers several use cases in the field of data analysis for high energy physics. And in my presentation today, I'm going to describe a little bit what those cases are. So SWAN is a service that allows you to do interactive analysis with a web browser. This means that you connect to this online service. You don't need to install anything locally. You connect with your browser, and you get this Jupyter Notebook interface where you can do your analysis. So basically, all your calculations, the code that you run, the input data that you need, everything is on the cloud side, on the server side, right? And then this kind of service enables for easy sharing of scientific results. You can, through SWAN, you can choose to share your work, your analysis with other scientists, your plots, your data, your code. I'm going to give more details about that later. And it's, in general, it's a service that is good for data analysis and exploration, but also for teaching, as I will also mention a bit later. So the interface is Jupyter Notebooks, but what really makes it useful in the context of CERN, because in the end, there are tons of Jupyter deployments everywhere. What makes one useful at CERN is that it integrates with CERN resources, and in particular for software with CBMFS, for storage with EOS and CERNBox, and also for computing. It bridges you to be able to use computing resources, for example, Spark clusters or HT Condor pools at CERN, or more recently, we have added the capability for the service to provide interactive access to GPUs, which is something that is in growing demand from our users. So these are all the building blocks of the service. I already mentioned software, storage, computing resources, the interface. I will just mention here the analysis frameworks. For this service to be useful, it has to provide all the analysis frameworks that scientists at CERN they use. Mostly, when people use SWAN, they prefer the data science ecosystem provided by Python libraries. So Python is the most used language in SWAN, but there are also people that are doing things in C++ with other analysis frameworks. And even more recently, we added Julia, because it seems that it has also a growing interest in our community. But what is important here is not to tie yourself to any particular framework, but to provide as many as you can and cover more use cases. About software, I mentioned we use CBMFS. CBMFS is a distributed file system that has been deployed at CERN, that has been developed at CERN as well. And in that distributed file system, there is a team of librarians at CERN that maintain software packages, software stacks. So basically what they do is they gather all the requirements from all the experiments at CERN, and they construct these software stacks that have hundreds of packages. And then in Swan, we rely on that, and we make those software stacks available. So when you log into Swan, you don't have to worry about installing stuff most of the time, because you already have a lot of packages available there to do your analysis. So this is what is called here the LCG releases, these hundreds of packages bundled together and offered to the users. So you don't, as a user, you don't need to provide any Docker image with the software or anything. You don't need to worry about that. What you can do, you have the possibility to do it, is you can add more packages than those provided by CVMFS by installing them on your EOS space. Because in Swan, we also make EOS available. So EOS is the mass storage system for CERN. It's where all the experiment data is. And when you start a session in Swan, your home directory is actually your EOS user directory. So it contains your personal data. And in that directory, you can create your projects. You can create your notebooks, input data, output data that you generate. And then you can leave Swan and come back the next day, and everything will be there for you to resume your work. You can also access other repositories on EOS that belong to the experiments, so that if you are collaborating with an experiment and you need some data, it is there. You can use it as well, and that's available in Swan. And then another integration we provide is with CERNbox, with this layer on top of EOS for sync and share. So that you also have the option as a scientist to say, okay, now I have this analysis that I produced on this data, and I want to share it with my colleagues. I can do that through Swan. And in particular, how this is done now, this sharing part with CERNbox, is by means of cloning. This means that I can be a scientist working on some analysis, and then when I'm done and I want to share it, I can share it with one or more other scientists via Swan. And then the scientists, they can see what I did. They can inspect the contents of that folder that I shared with my notebooks and so on. But in the moment that they want to write, that they want to edit those notebooks, they want to produce maybe another version of that analysis, they need to clone. So they clone, they copy that project into their own space, and then they continue working with their own copy, and they might modify their own copy. So of course, this is not ideal. Why? Because, well, once I made a copy and I generate a new version, and maybe I need to share again with my colleague, that colleague will need to create again another clone, right? So you create this proliferation of clones, which is not ideal. It was done like that because when we implemented this, the collaborative sharing or collaborative editing of a notebook was not really supported, in the sense that if you wrote at the same time, two scientists writing the same notebook, they stepped on each other, they basically overwrote their work, and this was a safe way to prevent that. But maybe we could go now towards a better model, which is actually something that is proposed inside CS3Mesh, which is this parallel editing. And here, parallel editing means that I can create my analysis, and I share it with someone else, and that someone else actually is going to work on the same copy, on the same original analysis that I did. And when that scientist opens the notebook that I produce, it will, she or he will acquire a log on that notebook, and this way we cannot really bother each other. Right? So the user will work with a notebook, maybe produce another version that then maybe when they are done with the notebook, I can go and can inspect the notebook and maybe continue modifying it afterwards, right? So, and then I don't have this back and forth of the clones, which poses a little bit of a problem. It is true that still this model is not fully concurrent editing, because it's not two scientists editing the same notebook, different cells at the same time. It's not that. But to be honest, at least the experience that we have from our users, no one has really told us that they need concurrent editing of the same notebook at the same time for their work. So I would say that most of the use cases would be covered by just parallel editing, and it would improve already on what we have. Then going a bit on the use cases that we have at SWAN. So what do people use SWAN for? The biggest use case is using SWAN for physics analysis. These in the context of CERN or in high energy physics in general. This means analyzing data that comes out from the LHC, from the collider. So these are collisions. These are data events about collisions that are stored, they are collected and stored, and then they are analyzed by physicists. When they analyze this data in SWAN, this data, they look like basically columnar data, where the columns are just numeric types or arrays of numeric types. And with this, the scientists, they just produce their plots in SWAN for their final analysis. And another thing we've seen more and more is that people for analysis in the context of high energy physics, they are using machine learning. And this links with the provision of GPUs that I was mentioning earlier. This is becoming more and more important because they incorporate machine learning in their analysis and they need GPUs to speed that up. So it's important to provide them with interactive access and also batch access, but this is the goal of other services at CERN. But in our case, interactive access to GPUs and to software that can run on those GPUs, right? So this is very useful for them and has a growing demand. Then another use case we have at CERN is non-physics analysis. So this means that not all people are going to analyze data that comes from the collider, physics data. Some of them, they analyze other kinds of data. They are not physicists, they still are scientists or engineers, but mostly what they do is they analyze data that comes from the monitoring of the machine itself. So they collect all these logs, all these measurements from several devices that are connected to this big machine that is the LHC. And they want to know how the machine is doing, how is everything going, if the operation is normal, and so on. So they query that data from SWAN and they produce plots to analyze what's going on also from SWAN. And that's also quite a big use case, I would say. Then education, I mentioned earlier, we have many requests from schools, workshops that want to do trainings and they want to use SWAN. So they create exercises in the form of notebooks and they want to use SWAN for giving those exercises. And more here as well, we are getting requests for machine learning tutorials that need GPUs. So GPUs are also in demand here. And then finally, outreach. SWAN can also be used to do analysis of open data in high energy physics. And this actually links with my last slide, where I talk about open science. So at CERN, we have this initiative, CERN Open Science, which wants to make available the research of CERN to other researchers around the world and in general to society. And this means not only publications, but also software and data as well. So CERN and the experiments at CERN, like CMS, Atlas, and so on, they have opened their data. So this means the data that is collected from or extracted from the collider, right? Collision events. From a few years ago, they have released them, they have published them, and then people can go and see them. And this is useful, for example, for training of future scientists, or in general for outreach and dissemination of the kind of research that is done at CERN. And maybe related to the previous presentation by Marcin, actually Voila could here be a good tool for showcasing this research, because one can think that we can have also physics analysis in the form of a notebook, and then we generate a Voila dashboard out of it, which is actually what I did here in SWAN. So you have Voila in SWAN as well. And what you see here is just the last part of an actual analysis, physics analysis that uses the open data of an experiment at CERN that is called CMS. And this Voila dashboard, it doesn't have these Jupyter widgets that were presented before, but it has this interactive display. So this plot is actually interactive, and people that are using this, they could just go and play a little bit with this display. So this could actually help also in these dissemination activities at CERN. And with this is the end of my presentation. Thanks for your attention.
Thank you very much. Let's leave the questions till the end. And now let's go with Leonard, our speaker, who unfortunately could not join us, but kindly prepared a recording of his presentation. So I think, is it playing? Oops, sorry. Can we have audio from this computer, please?
Welcome to this presentation.
Okay, that's the problem.
Skibo RDS benefits
Let me
RISE
go back to
SMA.
the beginning. Okay, let's start.
Welcome to this presentation on how Skibo RDS benefits RISE SMA. My name is Leonard Hofeditz. I'm a research associate at the research group of Business Information Systems and Digital Transformation at the University of Potsdam, at the chair of Professor Stefan Stieglitz. Our research group is part of the RISE Social Media Analytics project. This project is an EU-funded project, part of the Horizon 2020 funding scheme, and considers social media impacting, on the one hand, society, and on the other hand, crisis communication. We consider information extraction and also do research on information dissemination, and consider topics and different dynamics and also actors and roles from crisis communication in different organizations, for example. When I mean we are a group of universities from different countries and also practitioners from different countries. So our research group used to be part of the University of Duisburg-Essen, now moved to the University of Potsdam in Germany, and also part is the University of Leiden from the Netherlands, University of Agder from Norway, the Kristiansand Kommune, which is a city government in Norway, Virtimo, a developer of Berlin, Unisinos, university from Brazil. Then we have the University of Indonesia as well, and then two universities from Australia, so the Queensland University of Technology and the University of Sydney. And all these actors have different expertise, so researchers from business information systems, computer science, mathematics, and communication science. And together we conduct research on these two topics: societal impact of social media and crisis communication, and how social media impacts crisis communication. So let me give you one example of a project, sub-project we are conducting in this project, this main project. So one research project I was involved in considered conversational agents in crisis communication. Together with colleagues from my university, from University of Sydney and University of Edinburgh, we considered how we could derive design principles for conversational agents to support emergency management agencies. We published this article already in 2021, and I want to give you this article as an example of how we conducted this research. So we had two different data sources. On the one hand, expert interviews with representatives of emergency organizations in Germany, especially from the lands of Northern Westphalia and Hessen. So these were 6 interviews with practitioners, experts from organizations like the Johanniter, for example, and experts from state institutions as well. And on the other hand, we had data from Australia, after we interviewed experts with representatives of emergency organizations from different states there. So this are 13 interviews, so from different states and different organizations. And in the middle, you can see a few keywords. We also tracked social media data to get an understanding of their problems. So for example, in Australia, one of the biggest problems is bushfires, also floods, which they have in common with Germany, who also more and more has a problem with flooding. Yeah, and considered these two cases. So when we did this, we used Skibo, which is based, so it's a sync and share service based on OwnCloud. And we used it to store our data, to work collaboratively. So creating folders, working in shared documents, so like Word documents and Excel files, for example, Excel sheets and so on. Yeah, and used it. And one problem was that it was very difficult to give everyone involved in the project access to the folders. However, we could solve this problem by using Skibo RDS. So just to give you a few screenshots, this is a screenshot of how we worked collaboratively. So I, for example, created a guest account for one of the authors from Australia. And when we worked on the documents or the article, the research article, yeah, we used the commenting and editing functions here of OnlyOffice, which is included in Skibo. So Skibo is limited to Northern Westphalian universities in Germany. So if you are not part of one of these universities, one who is part of the universities has to create a guest account for you. So, but this is not longer necessary. So if you, for example, want to share data sets, you can do this by Skibo RDS, which really helps us. And which is also very helpful is that, for example, another partner, University of Leiden, they have their own cloud service, their Serve cloud, and so also the sync and share service, and they can use the service and provide us access to their cloud, and we can provide access to them from Skibo. So this is one improvement which we really like, and another improvement is the Skibo RDS, which I will explain in a second. So when we published the article, there we considered the publication steps of the journal we wanted to publish in. And they said on their website, if you want to publish, then it is important to consider the research data. And the journal encourages and enables you to share data sets to repositories. And it's possible to link the published articles and the data sets, which benefits you with, for example, more citations and more visibility and also reputation. So that's why we considered to publish our data, and this was difficult. For example, if you do it via the Open Science Framework or Zenodo, because you create an account, download everything from our Skibo cloud where we had the data, and then uploaded it again on the data repository. However, with Skibo RDS, it's much easier. So this is one suitable data repository we considered, the Open Science Framework, and here you can see some of my projects I already created manually, and this is not longer necessary because we ask ourselves, how can I apply this uploading process as a researcher with as little effort as possible? And Skibo RDS helps us with this. This is a screenshot from Skibo RDS, how it looks like at the moment. On the left side, you can see that there are 2 repositories selected, the Open Science Framework and Zenodo, and we aim to publish a dataset at the OSF. So this is why I want to show you in a short demo how we did it and can do it in the future. As you can see here, we also used the OnlyOffice option in Skibo for this presentation. We can go now to the folder here. We have here our data. Go here to the RDS app. And can see now, okay, there are different repositories. So the OSF, we want to connect the OSF to our account, approve this, and now the OSF is connected. And we can create a project here by picking the right folder, which is here. Select only the data folder. We want to have both codings and transcripts. Select it, give it a name, so just an exemplary name. Skibo RDS RISE SMA, and can now select the OSF here. Press continue. Now we have the option to select some metadata. So a title, which is called conversational agents in crisis communication. We can select a category for the OSF. It is data what we have. Add a description, project, part of the RISE SMA. And now, by pressing continue, we can see, okay, we have data, which is in OwnCloud. So as I said, Skibo is based on the OwnCloud, so you can share service, and we can publish it to the OSF. I'm not going to press the publish button because it's already live, and I just want to demonstrate how we can benefit from Skibo RDS when publishing data sets and when working collaboratively when we use Skibo and the OnlyOffice collaborative working. So this is a short demonstration from the RISE SMA project. Thank you for your attention. And if you have any questions, I can't be here today at the conference, but feel free to email me and ask whatever you like. Thank you.
Well, Leonard's not a round of applause. We thank you, Leonard, to provide this. As Leonard said, if you want to reach him directly, you can come to me and we'll provide you his email address. Moving swiftly on for our next speaker, Ron, who is going to present a use case related to astronomy. Welcome, Ron. Let's hope the PowerPoint works smoothly this time. And this is it. Yes, okay. Go ahead.
Okay, good. Still morning, right? Good morning, everyone. Well, it's funny that my colleague Sagar from SURF is also in the audience. So now, finally, after traveling all the way to Poznan, I get to tell my colleagues at SURF what my group is doing. Any case, on-demand data transfers. That's it. What I'm going to discuss with you now is just, let's say, the work that we did within the course of the CS3 Mesh for EOS project on data transfers, and more in particular also about the demo that we're going to show a little bit later on. About the demo, there has been the ESCAPE project that ran a few years, and it ended in January last year. We're also in the company of Xavi, the work package leader of WP2 of ESCAPE, so all the questions about ESCAPE, they're Xavi. Yes. Okay. This project was about addressing the common needs of several S3s, more in particular also astronomy, high energy physics and others. And yeah, the work has been done within this project on a number of components that those S3s have in common, and those are listed here. Due to time, I'm not going to discuss too much detail here. But about the work that we've done on data transfers, basically we have addressed two types of data transfers. First one is more just the ad hoc data transfers, typically from one user to another user at another single share service, or one research group to another research group. Not really organized scientific communities, but just individual research groups. And we've developed something that is based on rclone, which is a well-known tool to, let's say, address storage spaces at something like 40 plus different cloud storages. The other one, that is the managed data transfers. That is about, let's say, the organized scientific communities that have petabytes or even exabytes of data that they share together. Communities that have evolved around them, they use typically tools like the file transfer service developed at CERN to copy files from one place to another, and also this involves a federated AI system, which can also be connected to the ScienceMesh, by the way. Okay, well, this is the ad hoc data transfers. I'm not going to say too much about it, because this, yeah, it's a little bit of a complicated picture, but basically what you do is one person invites, let's say, another user to have, let's say, a transfer type sharing request. The end user accepts that, and then at the sync a share service, let's say an rclone daemon is fired up that collects the file from the originating site. Well, this is a typical example, of course, of managed data transfers. This is the stuff that WLCG is doing to copy the LHC data all over the planet. So, okay, about the demo, it's really about, let's say, getting the data from the telescope, so astronomy use case, getting data from a telescope, put it in a data lake, and from there to get it into the ScienceMesh and to distribute this data to other users not directly connected to that data lake. So in fact, what we're trying to do here is to, let's say, connect. Kuba was already mentioning it this morning, that to let's say, connect one infrastructure together with another. And here we have three actors. We have Stella, that she manages the data coming from the telescope, and she has access to storage infrastructures belonging to the ESCAPE data lake. And there we have Jan, our primary investigator, that has access to a sync and share service at SURF. And that sync and share service also happens to be part of the ESCAPE data lake and is also a part of the ScienceMesh. And at Chestnut in Prague we have Mirek, and Mirek has access to his own sync and share service. And what happens next is that Stella says, okay, replicate data from LAPP to SURF. And what the FTS does is make sure that, let's say, the storage element at serve will pick up the file. And if that happens, the file is copied to serve. And then what she does, using federated AI, logs into the serve sync and share service and shares that data set with Jan. Okay, Jan sees that, accepts the share, sees the file, and then he will just share it with Mirek, and Mirek accepts the share, logs into his own sync and share system, and sees the federated share from Jan. So, and now I can show the video. I'm not touching anything because I will break things. Okay. I feel discriminated. There's no fancy music underneath. Okay. Well, here's the FTS. Sorry, this is the only command line stuff that you're going to see, but apologize for that. Here's the FTS that copies the file from LAPP to serve. Then you look at the status of the transfer. Transfer got stuck. Yeah, and lo and behold, it's finished and successfully finished. So from LSWP, the file has been copied to serve. So now we're going to see GUIs. Stella logs into the serve sync and share service. And this is our favorite customer, Miskatonic University. And there it is. The file that she copied to serve. Now it's going to share it with Jan. And now Jan is going to log into the serve sync and share service and accept the share from Stella. And there we have the file again. So, and now Jan is going to share the data with Mirek, and of course Jan needs to find out the sync and share servers Mirek has access to, and also Mirek's ID. And for that we have an invitation workflow. I'm not going to show it here because of time, but there is an invitation workflow put in place where we can find, let's say, the user ID and also the remote EFSS from the user that you want to share with over the ScienceMesh. But here we have done this invitation workflow, and here we see Mirek, and we can now share data with Mirek. So now Mirek is going to log in into a sync and share service and accepts the share and then has access to the file. And that's it. And that's all for me. Thank you.
Thank you, Ron. Okay, I believe we are quite late, so there is time for only one question. If there is any question from the audience here in the room for any of our speakers. Okay. Any questions from the online audience? Letizia, Nothing? Okay. Marcin, Ron, Enrique, and also Leonard, thank you very much for being with us. Now, let's move swiftly on for the next session, the last one before lunch. So it's our first panel discussion for the day. I would like to invite to the stage Pedro Ferreira, who is the CS3Mesh for us technical coordinator from CERN, and also like to invite Xavier Spinal, also from CERN, in representing the Escape Former project, Andreas Klotz from HIFIS, and here in Poznan, Joszek, I hope I spelled properly your name, from the PSNC, and also we have one remote panelist. His name is Robert Scheidt from University of Paderborn and a member of the High Performance Computing RHW project. So thank you very much for joining us. And I'll pass the floor to my dear colleague Pedro, who will manage the session, and I'll introduce the panelists.
Thank you. Is this on? Yeah, I think it's on. So yeah, thank you very much for this introduction, Rita. So the title of this panel is Trends and Priorities for Cross-Border Multidisciplinary Science Collaboration and Innovative Technical Partnerships. It's quite a long one. But to put it short, so I think everyone in this room agrees that has been a lot of progress in the last decade or so in providing tools to researchers, and there's a wealth of options and tools and workflows available. Of course, the question is, will we somehow converge at some point into some sort of solution, or at least a set of solutions which researchers can use at a European and even, who knows, at a worldwide level, and how do we democratize access to these tools? So if you want, we will be going a little bit bottom up, looking at the use cases that we have at our various institutions, at our various federations, and working up from there and trying to make sense of the current panorama and what can be some of the aggregating efforts that we can go for. So I would suggest that we start by introducing our speakers. So I would ask, perhaps we could start with Robert, who's on Zoom. So Robert, if you can give us just a very quick introduction about yourself.
I'm happy to, and it's a pleasure to be here. My name is Robert Schade. I'm technically a scientific advisor for solid-state physics and quantum chemistry at Paderborn Center for Parallel Computing. That's a NHR, so National High Performance Compute Center in Germany. So my job is basically to support users in their day-to-day life and workflows and everything in the context of physics and chemistry. On the other side, as was already mentioned in the beginning, I'm a coordinator in the competence network HPC NRW, so the competence network for high performance computing in North Rhine-Westphalia in Germany, where also Skibo is located. And there we deal with all the problems and challenges that we have in high performance computing, from compute time proposals to data management and everything.
Thank you very much, Robert. So maybe Andreas, you can go next.
Thank you. Yeah, I'm Andreas Klotz. I work at Helmholtz Center Berlin, where I manage the local HIFIS cluster. HIFIS is Helmholtz Federated IT, and I'm basically the architect of the Helmholtz cloud.
Morning, everyone, or afternoon. I'm Xavier Spinal. I'm leading the engagement at CERN for the research and computing sector, and also member of ESCAPE.
Hi, I'm Wojciech Stefaniak, machine learning and robotics engineer at PSNC, and also an educator for high school students. I educate about data science and machine learning, and probably that's why I'm here to talk about our use case of Jupyter notebook platform.
Okay, so just one round of applause for our speakers, please. So I would suggest that we start from some general questions, very open questions, and then maybe start getting into the details. Towards the end of the session, then maybe we can open also the discussion to the floor if someone has some questions for our speakers, or if they want maybe to provoke them in some way. So I would start with a very specific question, which is, so let's start from your local environments, and maybe we can start with you, Andreas. Starting from your local environment, from your perspective of, in this case, of HIFIS, of your federation. What do you say are the main pain points that the researchers face in the handling of data, and how can the ScienceMesh help them?
Yeah, the ScienceMesh is especially for us in Germany, it's extremely relevant. We have this weird limbo situation where we want to have even more and more data sovereignty, have data on-premise instead of in the cloud, not have scientists use Google and such. And so we all have these enterprise file sync and share systems, but we still need to collaborate somehow. And up until you from ScienceMesh came along, federation of EFSS meant that you exchange the whole user database, and you might imagine how German data protection officers might like that. So now we have the option of a more data GDPR compliant way of sharing data and collaborating across institutions and across research fields. So thank you very much for that.
Thank you very much, Andreas. A very good point. The data protection, GDPR, of course, is something which these days is extremely relevant. So I would move on then to Xavi. Would you like to make the same exercise from your point of view as someone working in high energy physics, doing engagement with high energy physics at CERN, and also from your work with ESCAPE, which Ron has already mentioned? What would you say are the main challenges that our researchers face today, trying to collaborate in a pan-European environment?
Okay, good. Yeah, so I think one of the important aspects is that the way the users do analysis is evolving. I mean, when I was doing my PhD, we were practically working on terminals and then doing basically pre-staging the data and waiting for some days. So right now, the way of working changed. All the panorama of notebooks, web interfaces, the availability of data is changing the paradigm. So the fact that the ScienceMesh and CS3Mesh project is kicking in, and it's interesting to narrow the gap between what is the experiments big data, these data lakes, or basically the catalog of the experiments, and to put this data really at the level of the users. Now, the users are I would say two types. Ones are the hardcore people doing PhDs and large-scale analysis, where they should run probably thousands of jobs. But there is also another aspect, which is the one when the analysis is much more advanced and you have a few data, which is the one that you really want to analyze, and then you start writing the paper and you need to share it with your collaborators. So these are two aspects that are different. And the later one I mentioned is the one probably addressing better now in ScienceMesh. But there is the possibility to bridge what I have seen today, this voila inside the notebooks, that you can have kind of interactive way of moving the code and then plotting the data. This is really a point where I think we should put the focus on the next years. The fact that the gap between large-scale analysis and very focused analysis is large is because that probably this large scale needs thousands of jobs, hundreds of terabytes. What we really need, I think, our users is to be able to to play with a subset of data, and then from there, from this notebook, from this mesh, be able to fix and to tune the analysis and then scale out on local resources. We have seen from Enrique this interaction with local clusters, with GPUs, and eventually with HPCs and cloud. So this is probably one of the things that I think we are moving towards, a kind of a holistic approach on the analysis.
Thank you very much. And you've mentioned notebooks and visualization tools, and I think this is a really great segue for Wojciech. So would you like then to present your perspective on this?
Yeah, when we talk about science, we usually focus on scientists who do it as their jobs. But we in Poznań deal mostly with students which are setting their first steps in this field. They are just getting to know data science and machine learning. And to be honest, while I was studying, it was very hard to go through all those steps of getting to know the system of Linux or macOS and the terminal. And then you have to put your data somewhere, then make a virtual environment. And now all of those problems are fixed with the frameworks, the solutions that are made here in the ScienceMesh. So yeah, that's great for sure. It enables youth to just it brings down it all to the simple user interface, and they can just play with the data, play with the notebooks.
Thank you very much. And you, Robert, I expect that in your case the level of complexity and user-friendliness will be completely different. Would you like to present then your perspective on these? What are the main problems that HPC researchers dealing with HPC face in this moment?
Yeah, I'd be happy to. So we have basically two aspects. On one side, the already mentioned like large projects that have their own data management section and so on. They work usually flawlessly, but we also have a really big crowd of, let's call them the normal HPC users. They come from smaller systems, then go to higher tiers in the HPC pyramid to larger centers, have to transfer the data between centers, between their home workstation and the HPC centers, and then suddenly this one HPC center is too small, then they go to the next level and to the next level, then maybe even to the Trace level or to the GCS level and so on. And this data migration is a huge pain point for us in HPC, because you might remember in 2020, 2021, we had these security incidents in HPC where attackers got root privileges on one HPC system and then hopped from one system to the other and infected a chain of HPC system. As a consequence, most HPC operators nearly completely locked down their systems to prevent that in the future. But that also prevents data transfer, obviously. And that's one of the biggest pain points that we're having today, and that where, for example, Skibo, that we're actively collaborating with, and ScienceMesh can hopefully help us to connect all the levels of the HPC pyramid, all the different sizes of HPC clusters, and together, not just the large ones, but also especially the small ones that don't have a lot of personnel to actually maintain their own ScienceMesh node or something like that.
I'm curious to know, Andreas, do you share these this view with regards to the mesh? Because I see that one of the roles that ScienceMesh could play in HIFIS, for instance, could be enabling connection between people who are currently part of the HIFIS ecosystem and other ecosystems outside. Would you say that this also applies in your case?
Yes, so Helmholtz is a big research community in Germany, but obviously we have so many researchers who work across Europe, across international boundaries. This would absolutely help our researchers to connect within other people in their community and to collaborate more efficiently. Yeah.
Thank you very much. So, staying still in more or less in the same subject, I know, Xavi, that there's been an effort within the mesh to provide some sort of hybrid node which allows, let's say, mesh users to also benefit from escape functionality. Would you like to elaborate a little bit on that? And do you see this also as an enabler of possible, connections between communities?
Yes, exactly. So one aspect is connect people, but also another aspect is connect communities and different experiments and different sciences. One thing that is also evolving is the way we do science. Take the example of physics. We are running an accelerator at CERN. We are looking for a kind of the secrets of the universe, and we are colliding particles, but also cosmology, astrophysics, and radioastronomy. They are looking probably for the same things, like dark matter or other cosmological constants, and they are looking at the space. So the fact of having a place where the researchers can mix these different kind of data, collider data, telescope data, astroparticle, this opens a new scope, which we call multi-wavelength. You are looking the nature with different glasses. But up to now, it was very difficult for the people to have data from this experiment, from the other experiment, combine it in a visual way. We did something also with the help of LawFire, combining data from the radioastronomy, data from the optical views from the space. And this is just starting, and this is really something which should put the focus in the future. Also opens the door to this multi-messenger astronomy. There is one event, could be a supernova, then there is a network of experiments that will open the triggers. No matter what, they will record everything in short time, and then you put this in place in a kind of easy access for the people to do this combined analysis, and this is something which connects people and collaboration and experiment.
Indeed. Robert, yes, Robert, indeed. I know that you guys are also working together also with colleagues from WWU on establishing some sort of project of effort which would allow ScienceMesh to be bridged with HPC capabilities. Would you like to talk a little bit about that?
Yes, of course. So the main driving force behind that is Holger Angenent from Münster. You already mentioned the WWU, so that's the university he's at, and he's currently trying to bridge that gap. So basically try to connect our fast parallel file systems that we have in HPC more or less seamlessly or directly to Skibo or to a data exchange service that then can easily connect different HPC centers and avoid this problem of direct data give us a workaround for this problem of direct data transfers between HPC centers that we are struggling with. It's currently in the prototype stage, and probably you should ask Holger to talk about the details, but I think that's a great effort. It's nicely, it uses an Nextcloud as a background service, directly connects to the parallel file system, and then exports that as basically something like Globus Connect in that sense, but something that we can maintain ourselves and develop ourselves and don't have to pay a lot of money to Globus for, and be a lot more flexible in how we use it and how we connect it to our HPC systems. If you have questions about the technical details, probably better to ask Holger, but if there are questions about the concept, how it's supposed to work, I can go into detail if that's...
Great, thank you very much. So I don't know if there are any reactions from the panel to still on this subject. Otherwise, I would have actually one thing one question for Wojciech. So you mentioned before that you're trying to take these tools which are currently using, that the researchers are currently using for their own data analysis, for their own job processing, and so on. And my question, maybe a little bit provocative, is, does this make sense? Does it make sense taking software, specialized software that is currently targeting researchers and moving it to education. How does it map in practice? In your experience, do people, does this end up producing, practical results? Is it user friendly? How do you see this transition from the research environment to a more educational one, where it's dealing normally with undergraduate students and or do not necessarily master? As you said before, there's been this great evolution in usability of systems, but still there is a barrier, or is there not?
Yeah, I mean, they have to start with something. Yeah, to be honest, they are using the same packages as the scientists in data science, for example. It's all pandas, NumPy to operate on the data. It's all TensorFlow and PyTorch to train the models. Sure, there are some easier things to do. Maybe some solutions like platforms which allow you to just connect the dots and make the model for out of prepared segments of code. But from my experience, that does not lead to understanding any of it. So yeah, we just work with students from the basics, and surprisingly, there are some good projects after 2 or 3 months. Even projects which are deployed outside of Jupyter notebooks, they end up as Google Chrome extensions. For example, one of the examples is a project which recognizes a bad posture, bad posture of the person behind the screen. So yeah, good for us. So yeah, they are useful projects, and they are all starting from the point of knowing nothing, to be honest. So yeah.
So Andreas would like to pick that up.
Yes, thank you. It's an excellent question whether the technology you develop is not only relevant for science but also for other fields. And yes, it's absolutely relevant for education. But I might want to argue that like there's a lot more EFSS users, also large-scale EFSS users, be it federal institutions, and so for whom this may be relevant. So I urge you, move out of the scientific bubble, get into these other fields, into education, into federal institutions, and present what you have. Huh?
Citizen science.
Citizen science, yes. Also, and this will also put your technology to the scrutiny of this large community of EFSS users, and this is a great thing.
I would like to comment very quickly about exactly this. So the citizen science is something which is really expanding, and we have now the tools to really involve society. It's not only on the outreach and teaching, which is a fact, but themselves, but really we run some projects on cataloging of galaxies, different type of interaction in neutrino experiments, training machine learning algorithms and AI, and involve society and students on that has a major impact. So this is really an aspect we should pursue.
Yeah, definitely. And how do we see then the federated aspect kicking in? Okay, we're talking about local things, right? You set up your own notebook, Jupyter Lab server, or you name it, and tell them, okay, let's install pandas, let's do some analysis. How does the federated aspect then get in? How can the ScienceMesh add value to this?
Yeah, sure. Thanks for the question. I would say that there are some stars among the students who are really, really good at IT. Maybe they have some IT background. Maybe they are enthusiasts. And earlier in our bootcamps, we had a really hard time bringing them together to work on some projects, and they are distributed among different schools. They don't know each other, and such initiatives as ours could bring them together and work on the same project, and maybe the project could be even better than those projects that we had that won our yeah. Yeah.
So okay. Yeah. Perfect. Thank you. Yeah. Very good point indeed. Maybe we can leverage on these federated aspects to make that possible. So great. So I suggested we start talking a little bit about the future. We're more or less halfway into our panel. So I would maybe start with you, Andreas. How do you see the role of ScienceMesh in with regards to the future of HiFIS? Or let's put it another way, what would you like to see in ScienceMesh that would help you fulfill your mission in HiFIS?
Yeah, so as you guys from ScienceMesh at least know, we in Helmholtz are also working on federated sharing, but based on groups instead of user bases. And we also, in our technology, we have lots of open questions, which actually you may be able to answer for us. So I see a large possibility for future collaboration, maybe bringing the two technologies together and integrate this in a deeper technological level so that we have a sturdy base for collaboration cross-institutional.
Great, thank you. And I would ask the same question maybe to Robert. So how would you see, how can ScienceMesh, which future improvements, developments would you like to see in ScienceMesh that would help you in your own mission?
What would help us is to, on the one hand, focus on the whole life cycle of our terms of compute project, and but more importantly, make it easy for smaller institutions to connect to ScienceMesh. Opened up. I mean, we here in North Rhine-Westphalia have the pleasure of having Skibo here, which is a part of ScienceMesh, which does a great work for federated sync and share and so on here in North Rhine-Westphalia, but opening it up to users from, for example, all over Germany, because we are a national high-performance compute center. We are not just serving users in North Rhine-Westphalia, but all over Germany. And then you run into problems that if a user comes from North Rhine-Westphalia, they can use Skibo. If not, then not. And all this kind of things that block certain workflows. Especially, so to sum up, to especially make it easy to connect your own services to ScienceMesh and to open up for also smaller like work group clusters, for example, that have maybe half a person or a quarter of a person as an admin and still should be connected, but don't have the manpower to like larger projects have. That would be something really helpful for us.
I see that there's really a focus on the long tail, so to say, on the smaller institutions that don't have maybe the means. So, Xavi, would you say that it's the case also in your opinion?
Yeah, I think one of the beauty and the power of ScienceMesh is close to academia, is close to universities, and the thing is that the local groups, which are in my case physics groups, they could be another science, that are closer to the institution. They have a node where they can find the needed pieces to do analysis and to perform their work. Now, this links quite a lot on the initiative, which are now, I would say, starting on analysis platforms, analysis facilities, with research environments. If these people can link this kind of personal, local place to work with the facilities, with the big science, with access to resources, with access to HPCs, I think we will really narrow the gap to enable these local facilities, local communities which are working in institutes or physics labs to really have this kind of overview and this ability to get the data from different experiments and access different kind of resources, GPUs, HPCs, etc., etc. This is a long work, and it's not simple, but I think the pieces are there. We're just starting this kind of movement.
So, and in your view, the ScienceMesh can then help bridge this gap, or?
I think so. I mean, ScienceMesh, what they have seen, and you have the notebook as a platform. We are working on in virtual environments. You are bridging with local storage. You can mount external repositories like CPMFS. We see that there are some nodes that can be part of a data lake or can be part of distributed storage. So this kind of interoperability and integration, I think, is there. We are talking about protocols. We are talking about software, but this is basically coding and basically rowing into and agreeing in some kind of standards and protocols and technologies.
Thank you. Wojciech, so with regards to education and to your own use case at PSNC, then what would you like to see in ScienceMesh do, which would make it easier for you and for your colleagues to do their work?
I mean, it's already easy, to be honest. Yeah, comparing. Yeah, comparing to all the things the data scientists have to go through, and the graphical user interface that students are presented with, I think it's really easy for them to get around to upload their own data, to make something of this data. Even after our classes, they are told to make a project. We have a small competition, and they are bringing their own data to this platform. They are working on their own data. So we just leave them alone with our platform, and I would say that it's a great value, and that is a great point thing to see.
Thank you. So we are already at the half-hour mark, more or less. So I would suggest maybe can we start with the questions from the audience? Would anyone like to participate, to ask a question to either of our panelists? I don't see any takers. So in that case, I will ask the questions. So let's maybe stay with you, Wojciech. There is, lots of hype right now with AI and machine learning, and okay, I don't mean to jump on the bandwagon, but still it's something we cannot, as a topic, we cannot avoid at the moment. How would you say the ScienceMesh enables research in AI, and students especially, how it enables them to play with AI and learn AI and machine learning? And I guess in this regard, the Jupyter interfaces are probably the most relevant component. How do you find that? Do you find it is helpful?
Yeah, Jupyter notebooks really are helpful, and what ScienceMesh brings to it is to enable the user to upload your data more easily. For sure, Jupyter notebooks are not the only solution. I mean, if you are going deeper into the project, you are abandoning Jupyter notebooks because you want to end up with some kind of repo which is consistent, on which code is refactored, and you can't have 100 notebooks. But to take your first steps, to just see the data, to explore it quickly, it's a really good tool. And to be honest, sometimes I also use our platform to just upload the data quickly, not making data transfers through rsync to our data, to our HPC. and just upload the file and see within 15 minutes what's going on in the data, what's wrong, or what may be interesting.
Robert, maybe you want to step in here. Well, I'm saying this because, okay, we're talking about...
Let me, I also wanted to raise a point here, so sorry to interrupt you. So that's exactly one of the problems, one of the challenges that we have as a HPC system provider is to bridge the gap. So I mean, if you look at your typical machine learning AI user, they want interactivity. If they want to start a Jupyter notebook and use number of GPUs, they want it now and not in like 2 hours or 4 hours or at night at 2 a.m. when our scheduler in the HPC system says, yeah, no, there's resources free, but they want it now. And to bridge that gap of interactivity for smaller jobs, and then on the other side, large production AI, large language model, or other machine learning jobs that use tens, hundreds, or even thousands of GPUs. This is something where ScienceMesh helps us in terms of bringing the data together so that in the Jupyter notebook, they can work on the data and make their first experiments with like a few GPUs, but not idling a larger number of GPUs on our HPC system while doing their experiments. And on the other side, when they come to the production style machine learning workloads, they have the same data provided by the same servers on the HPC system.
This works, so I understand this compute capability can be distributed across different nodes. So if I submitted a job at a given node in the mesh, how could then this allocation of computing happen? How could the negotiation between the different nodes happen? Do you have any view on that, or is it something that will have to be defined in the future once we start getting, into that territory?
So in the mesh, this is not, as far as I know, not happening right now, and it's also a question if that will happen like this distributed way in the future. But on a just a two-level basis, where you have on the one hand smaller clusters with maybe some less expensive GPUs where people can run their initial tests. That is then for ease of usage, for example, directly connected to Skibo, and on the other side having the larger HPC installations with hundreds of GPUs, bringing them closer together and connecting them via ScienceMesh, not in a dynamic way that you maybe envisioned right now, but just in this stuff is, one side is for like smaller experiments, the other thing is for production style. Bringing them together with respect to the data is something that ScienceMesh can do and is already doing.
So we're nearing the end of this panel, so I would take this opportunity just to check one last time if anyone in the audience has any questions. Okay. In that case, I would just ask the speakers for, if they have any final statements. Maybe we can do it once again a round table. Do you have anything maybe you'd like to say?
Of course, yeah. So about the topic of disseminating this technology, introducing more participants into the federation. There's always the possibility of smaller communities which may find it to be a bit daunting to join this large kind of federation. And maybe you want to, for the future, put some thought into having the option of multiple federations, maybe not even being dependent of a central federating component, but being based more on peer-to-peer technology. That may be very interesting. And as such, integrating this federation component more into the EFSS applications natively. That would be very interesting to see.
Yeah, a very nice is peer-to-peer idea. Moving from, let's say, federated to decentralized, truly decentralized. Very good point. Xavi, would you like to go next?
Probably a final word is that we say this, the long tail of science and different communities. This long tail of science right now, I would say that this tail is not small. I mean, scientific communities, scientific experiments, and the different clusters in Europe, they are going into the direction that they need more and more common tools for data management, for data transfer, for analysis. And I would say, my desire would be that we work this together, we collaborate, we see which things we can do together, in which tools we can collaborate, and if there is a possibility to go hand in hand. This is a massive, I would say, effort that we will be saving, because if every community develops the same things or try to go in a different way, and everyone is paid or is funded for doing the same thing, if we do it together, we'll have probably less tools, much more powerful, and from the sites providing the resources, the computing, the notebooks, the infrastructures, the more common we are, the easier for them to put the resources and the manpower into the place where it's important. I'm talking about the ML, AI, and the future quantum, these kind of things which are outside the main mandates of a computing center, which probably is not maintaining end systems for data management, storage, etc. So the more we can talk with the communities, the more we can find commonalities, the more that we can pursue, like in these projects that we are talking today, EOS Future, Escape, ScienceMesh, the better, and we should keep this.
Yeah, and just a provocation, and Rita is going to hit me for that, because making it longer, but would you agree that this is something that should be a grassroots and something that should grow organically? Because until now I've seen people trying to do that top down. What would you say about that?
We need top down to have the umbrella, but we need the bottom up. Is fundamental. One of the beauty of Escape is that things happen basically sporadically. There was the will to collaborate and talking to the sciences, having the PhD students working with these notebooks, having the community, the data manager of the experiments, the people doing the analysis at the top level, at the bottom level is fundamental then to go bottom up, because then the top down approach at the end we will meet. We only have one of the two, this doesn't work.
Yeah, thank you. Yeah, Andreas wants
maybe from a more technological standpoint, the way of making this broader may simply be standardization. So if anyone has the issue of federating EFSS and they look into the RFCs and they see, oh, this is how it's done, then this is how they will do it, and they will join the effort, and maybe this may be a route for you in the future.
I think that there's particular people in the audience that we would have to convince first. Can think of one at least. But yeah, very good point.
I assure you it's worth the effort.
Yeah, I completely agree. Thank you very much. Wojciech, any final statement?
It's hard to add something to what you said. I would only say that bringing those tools to the communities will result in really innovative projects. We see this among our students who come up with really great ideas about which we wouldn't thought about. So imagine if we didn't bring it only to the, I don't know, thousands of students, but if we brought those tools to everyone, we could end up in really good solutions, really innovative things.
Indeed. Thank you. And so we started with you, Robert, and we close with you.
So all I can say is basically that Xavier put it perfectly with combining efforts, because we have funding on the local level, we have it on the statewide level, Germany-wide, European-wide, and often, in my view as somebody who runs HPC systems, they right now don't coordinate and communicate enough to join forces, and that should be one aspect for the future, to combine these levels, make something great for everyone out of it, be interoperable, have nice standards, solutions that can be nicely used in small systems and very large systems, maybe have different focuses, and bring everything together, basically.
Thank you very much. And thanks a lot to Andreas, to Xavier, Wojciech, and Robert. So a round of applause for them, please. Thank you.
Thank you, everyone. Now it's time for lunch, right? So we'll start again back at 3 p.m. But if you have time, we invite you to attend the EGI closing session that takes place here as well, but at 2 p.m. For those that are at home, we'll see you at 3 p.m. Enjoy lunch. See you soon. And Pedro has a note. I don't hate you, at least for this. See you soon. Thank you.
Good afternoon, everybody. And we are at the formal closure of the conference, although the conference will not be over. It will continue until the end of tomorrow. I'm Sergio Andreozzi. I'm the head of the strategy, innovation and communications at the EGI Foundation. And I will convene the session that will last 1 hour. We have 3 main parts. The first part, we have a special guest, an invited speaker who will give a keynote on the future of computing. Then we will have a QA session in interview style, and also I will invite you to propose questions for our expert. And then we will go to in the very last part, in the last 10 minutes, we will go to the final remarks to wrap up the EGI conference for 2023. And first, some housekeeping information. This session is live streamed, so if you want to intervene, just be mindful that it will be recorded and will be available on the YouTube channel of the EGI Foundation. You can participate in the QA afterwards, and also the session will be made available. If you want to tweet or write on posts on LinkedIn, you are invited to use the hashtag EGI2023. And now I have the pleasure to invite our keynote speaker, Sagar Dolas from SURF Innovation Labs. SURF, I guess, is known to most of you, is the national center in Netherlands providing innovative services to support digital research and education. And in this, they did an interesting work recently. They analyzed the technical trends in computing, and that will affect all ICT sector for research. They published a report, which is called the SURF Tech Trends. You will find the link in the footer of the slide. And because of this work, we decided to invite Sagar, who was in charge for the future computing networking, to give us some highlights of what they found out and how the findings can influence the direction of the EGI service strategy. He will give a keynote on the future of computing and its impact on grand challenges in society. I would like to invite Sagar on the stage. Thank you.
Well, hi everybody. I hope everybody has a nice lunch, and I don't bore you enough to sleep, so please feel free to exercise a little bit. Thank you, Sergio. Thank you, EGI, for inviting me here. You can also ask this question to actually ChatGPT, and you can get a very nice response, and then my job is done. But I'm not here to provide you with the standard responses. I'm here to uncover those driving tensions and those driving forces which are shaping the future of compute, and how will it impact the way we do research, and how will it impact the way we would like to tackle societal challenges. And that's why I have titled it From Edge to Exascale. I think it's mostly like 10 to 15 minutes of my talk, and then we go into the Q&A. And I would very much like that you can interrupt me, that you can raise questions, or also challenge me that, oh, this is wrong. Okay. So as Sergio told, I come from SURF. SURF is the Dutch ICT organization, or a cooperative for education and research. It facilitates, provisions, and maintains the national ICT infrastructure, compute, data, networks, but also education ICT infrastructure for Netherlands. But it also partners with international consortiums, and EGI is one of them. I come from SURF Open Innovation Lab. It's the place within the SURF Innovation Department to foster the philosophy and mindset of experimentation, open collaboration, open sharing of results, but also fast prototyping, and technology exploration and assessments. And I lead one of the programs within the Open Innovation Lab. It's called Future of Computing and Networking, where we try to understand what's coming ahead. Can we test, experiment, and can we understand the impact? So I also welcome you to join the effort. We are very open to collaborate with stakeholders, partners, to understand and uncover hypotheses or challenge hypotheses. Okay, so enough about me, enough about SURF. Let's take a pause. Let's try to understand the context. What do you see on screen? If everybody could see the screen, then this is the kinds of headings that you see in the media. And I would like to move away. We see that how things are advertised, especially when it comes to hot topics like this. When it comes to quantum computing, when it comes to deep learning or how deep learning has been advertised, when it comes to old programming languages, when it comes to mixed precision and low precision for my technical geek friends, and also about how HPC and cloud will interact in the future. And I call them myths because this is not the way the future is going to look like. And we are going to understand why, but you can also are welcome to question this. Okay, let's take a step back and let's try to see what's the long-term envisioned value of advanced research and computing and how is it changing. In the last 3 or 4 decades, we have seen that the entire ecosystem and infrastructure is moving away from just a research tool to addressing and tackling pressing societal challenges, economical challenges, and how research and researchers contribute to these challenges. And we depend on science and research computing infrastructure more to address, tackle, and understand those challenges. Let's take a little bit deep dive or say a little bit intro into what are those challenges. I think you hear a lot about these, high fidelity simulation and analysis. So at the moment, in terms of global climate simulation, modeling and analysis, we are at a range of, for example, 100K by 100K by 100 meters. If you want to go 10 times more fidelity and 10 times more better analysis, then it means that we need 1 million times more compute capacity, more compute processing ability. And if somebody asks me why 1 million times, then I can answer them that if you want to go 10 times faster in each physical domain, you also have to reduce 10 times the time steps to actually validate and make mathematically correct predictions. So you are going 1 million times more. You need an ecosystem which can do 1 million times more processing capability. If you think about multi-scale embedded workflows, especially in biology, we think about simulating the whole biology of human cell, right from the mitochondria in the cell until the whole stack, which is until the molecules. It is a humongous simulation and humongous compute challenge, which is still yet to be, we still have to understand how to do this within the realm of a computing. We can do this separately, but we cannot do this at the same time. We cannot do at the moment multi-scale embedded biology simulation to the detail that we need. If you think about the plasma, and I know some people here are involved in those efforts, we are looking at exabyte per year storage, processing, and movement of data. And this is just for some simulations. There will be a network of such plasmas or nuclear fusion reactors, and then it will be an avalanche of data that it's difficult to comprehend and understand and process. So we are looking at incomprehensible ability, or at least we need to increase that ability. If you think about AIs, or if you think about what people want to do with AI, it's all of this at the same time. It's not in isolated, siloed analysis. And this is again a grand challenge that requires a coordinated set of, or coordinated usage of multitude of computing infrastructure and applications to be able to come up with such holistic analysis and simulation. Let's go to more home ground, more data processing workflows. And I think in terms of CERN, we are moving away from 100 petabytes to 10 times more. And also in Earth observation, we are moving 2 exabytes per year of movement, processing, and storage. We need to understand that these numbers are quite big numbers when it comes to network movement of data, when it comes to storage, when it comes to analysis, when it comes to compute. Let's take a little bit different approach. Let's move away from science and simulations to more global science collaboration. So you have students in the university, in the classroom. They need to be able to collaborate with a researcher who is a field scientist, who is collecting data on the ground. This needs to be coordinated by other set of researchers across the globe who are collecting maybe similar data in a similar domain. And then this needs to be coordinated with the science instruments that are spread across the globe, connected by a network and compute. And this is a different challenge. This is a challenge of regulations. This is a challenge of infrastructure federation. And this is a challenge of human collaboration. And what it demands is unconstrained ability. And it really doesn't matter where compute, data, network come from. To be able to make such collaboration successful, we need completely unconstrained collaborations. And I think this is still a challenge. Let's go to a little bit more hype or more fun. If you look at the graph, and this is the analysis published in the Nature. The paper is called Brain-Inspired Computing. And if you look at how the language models have evolved over the years, especially from 2015 to 2023, you would see a jump of 10 raised to power 7 or 10 raised to power 8 flop days of operations. So we have really, it's a jump, it's a 1 million order jump from the way we are computing or training, or the ability to compute and train. So all in all, I think the hypothesis is that we need a little bit, the ecosystem needs to be able to deliver in the next 1 decade or so about an ability to have 1 million more times of compute capacity. And when I say compute capacity, I mean not just computing, I also mean data movement, I also mean data storage. So it's about information processing, 1 million times more information processing in the next 1 decade or 2. A little bit more technical, you see here evolution of algorithms and how they have been doing with respect to Moore's law. And you see that until 2020, and I will show the graph after 2020, until 2020, when the Moore's law have been progressing very nicely, there have been tremendous algorithmic developments, and I would say tremendous algorithmic speed increase. But this is not the case anymore. Especially because in the domain, in the next 5 years or so, we are looking at the slowdown of the Moore's law itself, and we cannot, and the algorithmic speed up itself will not continue unprecedented. They will also stop with respect to Moore's law. That's one. So we have, the first hypothesis is that the conventional approaches to information processing, especially when it relies a lot on Moore's law, is slowing down. And second is, you see evolution of energy consumption. And on y-axis, you see the energy consumption for ICT infrastructure. And on x-axis, you see decadal consumption projections. And we see that in the next decade or so, we are aiming for more than 20% of world electricity just for doing ICT or information processing. I'm not saying that this is just for the researchers. A part of it is for research computing, for science. But you also have to realize that we only have so much electricity in the world. We do not have infinite amount of electricity in the world. The global energy production only grows 1% per year, but our demand for computing is exponential. And it grows non-linearly, and it will grow non-linearly over the next decade or so. So even though the research demands might not be as humongous as ICT infrastructure or big tech or clouds. We only have so much electricity available in the ecosystem, and we do not have unlimited. And that will influence the way we compute and the way we access compute. This is an example of what are realistic workloads, and this example is an analysis on the Dutch national supercomputer. Many of you might be driving electric car now, and if you know that it consumes around 75 to 100 kilowatt hours, for example, for the full charge. So if you think about 25 kilowatt hour for 100 miles, it's about 0.9 million joules for 1 mile. And we see that this is quite dramatic because simple scientific simulations and analysis can consume as much as an electric car. And unless and until we don't become aware about it or conscious about it, we don't realize that simple scientific computing causes humongous amount of energy consumption. And if you're not aware about it, it's very difficult to optimize, tune, or at least reduce it. We also see the cost, and you can project the cost of such for the other workloads as well. But you see that for GPT-3, the cost of simulation itself, the cost of training itself is out of reach of any of the academic centers or academic research institutes or as a community. And it becomes quite impossible to train or deploy such models just by us. And this is just GPT-3. We have GPT-4, GPT-5, and more coming in. And this is primarily because you see, this is the data from 2022, February 15th. We see that how much investments is going on when it comes to big tech and cloud providers, and where investments have shifted. And you see that the shift has been from the traditional vendors to more cloud and big tech companies. And the scale at which this investments is going on is very different. It's an exponential difference. On one side, you see something like $500 billion, and on the other side, you see something like $300 billion. So the scale is almost like order of 10. And this is only going to increase, and this will control who influences the computing ecosystem. And this is the primary reason also why, because we as an academic community, it becomes impossible for us to train ChatGPT-5. We just do not have enough capacity available to do such computing. So my hypothesis and a little bit break is that conventional approaches are maturing. So we see this is in terms of technology and also in terms of algorithm. At the same time, their use is not maturing. We have more and more usage. And other paradox is that it's becoming very costly to compute, both in terms of operational cost, the human cost, and also the energy cost. And we, as a community, our drive is not just to make everything faster. Maybe some of us have that drive, but I think jointly our drive is to make sure that science crosses its boundaries. Science crosses the barriers of what is possible, and I think that's why most of us here are. So let's take that into the thought to move into the next part, where we a little bit try to uncover the directions and the intervention points. But until now, anybody, any question, reaction, comments, or concerns? Yeah.
So the one thing I would say is that your log linear graphs are conservative. Several of your charts are log linear.
Yes.
And they should be log. They're exponential even in the log scale.
Yes.
So it's actually worse than you're presenting.
Yeah.
One other thing I would comment on is the efficiency of algorithms is actually not so terrible. A lot of work in the exascale computing project, work here in Europe, is allowing previously difficult calculation to be done more efficiently, but the energy cost will continue to go out of control.
Yes. And I think in my end of the presentation, I also have some of the ways in which algorithms or the techniques that have been employed. But what I wanted to showcase, and that was the data until 2020, if you have seen, that the traditional algorithms which have been responsible for doing traditional simulation and analysis, there is a limit to how much you can improve on algorithmic basis, and it's just stops, and we cannot indefinitely improve on algorithmic developments. You had a question, Tijana?
I have a question which is about the scope of IT, which is not covered so far, which is networking. I'm interested because that's my background, so I have a curiosity, and I know Surf is also in the business.
Yes.
So what are the trends, if you have any thought to share?
I'm coming to trends now.
Right, okay, so
this
we'll
was
wait.
This was just the context of why the trends or the intervention points I have will make sense, but the trends are now in the next part of the presentation.
So perhaps let me change the question. What are the challenges for networking? Because you've pointed out the challenge of international collaboration, the need of sharing data worldwide, and then we need the networking to make it happen.
Yes.
So where is networking at the moment?
Okay. Well, there are more networking experts, I think, in this room. I can spot some. But I think the evolution of, and I see, let me call it more pillars. So one is data movement, data sharing, and data collaboration. So network in itself will become enabler for data movement. So I think the infrastructure layer. The next side is orchestration, network design, and traffic. So how do we design cost-effective research networking such that it becomes easier for us to manage network traffic when it comes to research collaborations? And orchestration becomes a very important part there. So more automation, orchestration, and slicing. And I think the third part is, which is also very important when it comes to infrastructure federation, is authentication and access. And how do we enable that, which is also interoperable across geographical boundaries? So I think we see three of these big directions or trends that will influence future of network. There are more, but I think this is also the driving part when it comes to future of networking. But let me see if I can do that in the next part of my presentation. Yeah.
Yeah, a brief comment. The number in terms of energy consumption are definitely very high. But those numbers do not account the savings that we are generating in other sectors, because we are more efficient, because the heating of buildings and blah, blah. So those numbers are not telling the entire truth to me.
You're absolutely right, but we also do not have a systematic analysis. And what we call as systemic analysis, where we need an entire system and the analysis on the footprint available there. We need to put more organized effort as a community to make sure that that analysis is done. And what energy numbers I show, are only operational energy numbers. We are still not know what about the carbon emissions and energy cost when we try to do mining, production, commissioning, decommissioning, and there are different levels. And that is also not accounted yet. And so the complete accounting framework is missing. But highlighting these numbers only makes us aware that such accounting frameworks and standards needs to be developed. Otherwise, we'll never aware about if we are consuming a lot, where are we saving? And that systemic analysis is not there. But we are pushing for more and more compute. And from here on, more compute means more energy. The initial, the advantage of Moore's laws will slow down. And anymore, we will not have more compute within the same power density. Okay. So, to respond to Tijana, I think the first intervention point or the upcoming direction is really hyper-connected, interoperable, federated infrastructure, and that means network, compute, data, and I will also add on top of that applications. And this needs to be connected, this needs to be available in an ecosystem which is easy to access and easy to compute. And when I say interoperable, hyper-connected infrastructure, I also mean not just the cloud part, but also the high and mid-range and exascale supercomputers in a geographical region. I also mean data lakes, data repositories, and I also mean mid-range to small-scale HPC clusters and cloud. And without this, we are unable to deliver the compute capability that we need to be able to solve next generation of challenges. And when we come one layer above, we have the workflow and what I call is, and I think this is term already available since a couple of years now, what we call Internet of Workflows or Internet of Orchestrators. And there we see that, and I'm thinking in this community, it is much more aware that the workflows itself are becoming much more integrated, complex, convoluted, and dependent. And we have a combination of workflows where we see the use of an HPC system just as a stepping stone to something bigger. And I think that realization becomes an important part, because until now, just submitting a job into an HPC system was considered the research workflow. But I think it will move away from just that. And the HPC system, supercomputing system, will just become a stepping stone in the overall chain of workflows. But this needs to be orchestrated, and we are not there yet. And especially combining the network and data infrastructure. The one layer deeper is when we have the workflow orchestrators, or if you want to do workflow orchestration, how do you deploy and optimize it for leveraging capabilities of different specialized hardware technologies? So it could be quantum computing, it could be specialized architectures, it could be neuromorphic computing, it could be supercomputing, it could be cloud. And I think that deployment and that mapping of that workflows a layer deep when it comes to hardware is also very important. And this is something we have been very actively working towards. That how do you map a specialized architecture on the workflow? Because it will not happen that any one architecture will shine or any one architecture will provide performance that will help us solve problems. I think we need to do combination and orchestration. And I had a video here, but I think we are running out of time. The one part of it is especially energy optimization and tuning. I think operationally we can solve this problem, and I was talking yesterday with some people and they say, okay, 10% energy 10% energy reduction is really possible within the limits of optimization and tuning. And I think we have to evaluate where we can optimize and tune when it comes to energy consumption. And I think this is something, and this is not on the infrastructure level, because I think when it comes to heat reuse, when it comes to making sure that while commissioning a computing system, we have the low carbon footprint, while decommissioning, we are making it proper, while operational energy usage also could be reduced and optimized, because operational energy usage and the capital investments, there is no stark difference anymore. You might have a 20 million euro system, but you might spend over a life cycle of 5 years, 10 million euros on just energy cost. So it becomes not just a financial challenge, it also becomes an operational challenge to optimize energy consumption. And I think energy will become the fundamental design point for future of computing. I think without this, without acknowledgement of this principle, we cannot really move ahead or advance future of computing. And in that respect, for example, there are some architectural innovations that are incoming. And when we think about GPU architectures, there's a wall of performance per watt. And we are looking at other architectures which are crossing that wall. And then we are again looking at other architectures which are more analog computing type architectures, which have really the different order of magnitude when it comes to performance per watt. So again, I think we are looking at in future architectural innovation which will cross those walls. I think one direction is international science collaboration, but at the same time maintaining technology sovereignty in a geographical area, and that becomes a more important part. And how do you go for international collaborations? So you still do that, but you still maintain geographical sovereignty. And by what I mean by geographical sovereignty and autonomy is also securing of the supply chain of technology and a local ecosystem which provides you with the technology. And I think that is becoming more important. And we see definitely in the EU circles that it's pushing for more sovereignty and autonomy in the geographical region, because we are too much dependent and vulnerable when it comes to global supply chain of of the chip or semiconductor technology. And I think if you want to read more about it, there's a very nice book. It's called The Chip War, and it's written by Chris Miller, and it explains right from the evolution of early semiconductors to what challenges we face now and what will the future look like when it comes to sovereignty. The last part, or the last few slides of my presentation are, for example, on trusted data exchange, secure processing, and confidential computing, and all of this has to come together as well. And three things at the moment are different. And trusted data exchange is more about, for example, some people call it secure multi-party computation, but also enabling ways to exchange data in a trusted manner. And confidential computing is really at the architecture and technology level, that how can we make sure that what we compute, how can we make sure that researchers or research projects have access to technology which is confidential by design. And I think that is a different concept than secure processing. And all of these three areas, we have some initiatives where we are making some steps. One is more regulation-driven, and one is more technology-driven. And I think this is, Tijana, your question. What we are looking at least in the European ecosystem and in terms of network, is a capacity or the technology which will enable 1 terabit per second of network bandwidth. And I think this should enable us to do seamless connection when it comes to really data movement. Other geographical regions are pushing for the same, and I'm sure, I can say this, that in Asian region and in the US Pacific region, there are a bit more ambitious roadmap to support the network capacity of more than this. But I think this is something technology will deliver. I think it's not a problem, and it's not a challenge. It will come anyways. What is more important is that science beyond cultural and geographical boundaries becomes the norm, and I think this will become more of the rule, and 1 terabit per second of network capacity will just be an enabler for such norm in future. So, to conclude, I think we see 3 different timescales and 3 different evolution. One we see, which is we are in now, next 5 to 10 years, which is efficient architectures and packaging. The other is 10 to 25 years, which is new models of computing. And the third one is, for example, where we really transcend from the conventional materials, which is CMOS based, to more different materials, which is spintronics. But this is really, really far away. And this is some of the words that might catch you. We are moving to heterogeneous packaging, more chiplet-based design, 3D stacking to do energy-efficient computing, but also having memory close as much as possible to compute. Then the next paradigm, and this is a paradigm shift to more adiabatic, analog, and quantum-based computing. And then the third evolution, or I would say it would be breakthrough evolution, would be new materials, which would really drive the future of computing. But this is really, really, really in the research phase. We are looking at spintronics and graphene-based material for doing computing. And I think when it comes to algorithms, I very much agree with you, but I think there were some of the things that people have been exploring for the next 2 to 5 years. And the point here is that these algorithms exist, and they have been part of the exascale computing project and big initiative, but it takes time for such methods to become part of the daily course of a normal science communities. And I think this is where the challenge is, because normal science communities do not have expertise available such that these methods could become part of their workflows, their softwares, and their libraries. And I think one of the key things that we're looking here is exploring data sparsity, compression, and the shift of algorithmic design from matrix vector, which are the core of PDE solvers, to matrix, which is the core of, for example, large language models. And I think so I'll stop here. And to conclude, I think these are the fundamental dimensions by which we can start looking at future of computing. I will not say that this is what will be the future of computing, but you can use these as lenses to look at future of computing. On one side, you have environmental footprint. You have integration of emerging technology, for example, quantum. You have unconventional applications and workflows, which are too much convoluted, but also interconnected. You have broader reach in the communities. There are more and more communities which would like to have access to computing platforms, infrastructure, and services, and we have to make sure that we can enable them. We can support them having an access. We are looking at sovereignty and governance models, which will be much different from they were 10 years ago. And they are looking from big data processing to insights from big data. So I think that's also a cultural mindset shift, that we are not just looking at processing, we are looking at what we gain from that processing. So in total, we are looking at a human-centered ecosystem of compute, data, and networks, integration vertically, integration spatially, and this supports the future applications in different science and research domains. Okay, let me stop here, and then Sergio, you want to present?
You can go down. Thanks a lot for your many interesting insights. And now what we want to do in this next 10 minutes, 15 minutes, we would like to try to link what we heard with the EGI service strategy that we published last year. So you will find the document around printed at our booth. And also in the slides you find the recording from the last year where it was presented at the EGI conference. This is a 3-year strategy that has 5 top priorities, and starting from the first one, which is in the area of federated compute continuum, it builds on the origin of the EGI federation that was born around 20-25 years ago, in early 2000, by federating at the time, the type of computing that was available was more the commodity clusters to run batch jobs and deliver distributed computing as a large virtual facility, but mainly working on batch systems or interactive jobs. Later we got virtualization became a commodity, and it was cloud emerged as a new paradigm, and also to provision infrastructures on demand. EGI also integrated the cloud, and it kept on this approach to federating GPUs. Now we're working on HPC. So in a way, okay, we have been building on the trajectory a federation of heterogeneous computing capabilities, and we will continue on this. This will remain a priority of EGI. And SURF was also, as one of the key members of the EGI Federation, has many of these capabilities. In the you move from the research cloud to supercomputer. And first of all, okay, I would like to ask you, what trend do you see at the moment in the way supercomputers are used, in the type of workloads they can operate? Because also they've been evolving, and also they're getting into virtualization and so on.
Thanks, Sergio. I think that's a very good question. So what we see is, especially when it comes to evolution of workloads on the supercomputer, is that more and more inclusion of new kinds of workloads. We have workloads which are traditional in sense, scalable parallel computing. But I think after a point, we also see that we also have workloads which are more ensemble based. So you have these workflows orchestrators, and these launch a lot of jobs, and each job is moderately parallel. We also see workloads which are embarrassingly parallel in nature, especially when it comes to ML-based workloads. But ML-based workloads also has a lot of parallelism in them when it comes to training. And we also see, for example, in the last couple of years, we have been supporting the social sciences and the humanities communities on the national supercomputer with what we call the secure supercomputer services, where the Central Bureau of Statistics data sets gets transferred to the supercomputer. Researchers could access such data sets. They can compute on them, but they cannot download them. They can only download the analysis. And then the data goes back to the Central Bureau of Statistics. So we also see different ways in which supercomputer is used to advance research, and for different sectors, domains, and communities. So I think the traditional definition of supercomputing usage has become much more broader and much more evolved.
And there was an interesting comment you made before that I would like to pick up. You said that the supercomputers also a stepping stone on something else. Can you elaborate more?
Yeah, I think when it comes to launching a scientific workload, the way we have been doing that traditionally is logging in, preparing our job, launching it in a batch way, in batch processing, and then trying to make sure that we get the results. It's a very linear way of looking at how we do computing. But I think in future, supercomputing would just become one of the enabling pathways for the entire workflow, which will span much bigger than the supercomputing itself. It will involve IoT-based sensor, streaming data, data repositories, cloud-based ML emulators, but also somewhere remotely an interactive visualization and steering happening, which is also, which you can also call a digital twin. So I think we have to become aware that the way traditionally these bigger infrastructures have been used, they will be used by some communities in that way for a sufficient long time, but there will also be evolved usage where supercomputing would not be an isolated infrastructure, it would become the enabling infrastructure for the bigger science workflow.
So in a way, okay, now I get it. So for those researchers who join or start by getting maybe a quota of resource in a supercomputer, that they can learn the environment, they can see there is much more, a wider ecosystem that they can integrate into the workflow.
Yeah.
On the other side, yeah, in EG, there can be also the option that somebody comes more from the cloud side and goes into the supercomputer.
Yes. So I can share one experience of one of the prototypes very shortly. We have been doing this prototype with one of the universities in Netherlands, and it's like interactive computational steering, where you launch a simulation on the supercomputer, but you steer it and control it using an XR front end. And the hosting of that visualization happens on the cloud infrastructure, but the instantiation and the actual running of simulation happens on the national supercomputer. And this is all orchestrated and coordinated by the network. This is, we have to look beyond the traditional notions of privacy and security in these things, because some things need to become open, and traditionally we are not used to that. Supercomputers are very critical infrastructures in national science, yeah, but I think evolution has to happen, and it will happen.
Okay, thanks. And what about quantum? You mentioned quantum technology and integration in the context of the compute continuum. When do you think that quantum integration may happen in the future?
We are very actively part of the quantum computing ecosystem, especially on focusing on the area of quantum integration with the traditional computing infrastructure. I think we are in a very, very, very early stage of that integration. We did this prototyping with Quantum Inspire, the Dutch quantum computer provider, and I actually had a video to show, but I think it's time. But I think the way we see quantum computer, especially in the news and in the media, is very different from the way we see the integration. And that integration is very messy. That integration is it will take some time. We have to be patient about when it works. The entire software stack needs to work. The entire hardware integration needs to happen. There are different orchestrators on both the sides. You have an orchestrator which will control a quantum machine. There is an orchestrator which will control the traditional job. Both of these orchestrators have to talk to each other. And this is not an easy job, and we are very, very, very early stage of. So the first step that we have taken at the moment is really putting an HPC machine next to the quantum computer, and this year we will make the first steps for the software-based API integration. So we are really in the early stage of that integration, and how will that look like? Yeah.
Okay, interesting. And I would like to open maybe for one or two questions from the audience at this stage. Do you have any questions for that?
So I have a question about your opinion. How do you see the role of the research community in driving the future of future computing in some of the areas or axes that you presented? And the reason why I'm asking the question is that I've seen the research community in Europe and worldwide quite instrumental in driving innovation in IT in a few sectors. So if you look at networking, in fact, in the very early stages, at least in Europe, networking was highly driven in terms of innovation by the research community, and then the telecoms were just following, and in a way they were precursors. And likewise in distributed computing, I believe in Europe still the research community is far ahead of the commercial sector. So back to my question, where do you see the research community contributing and being an enabler to push computing to the future era?
I think at the forefront, at the forefront of this. And I think we also have to realize that the core nature of organizations like SURF is supporting, enabling, and making sure that the questions are, scientific questions are solved with the best use of technology. But I think the push for innovation, the drive for innovation is, the communities are at the forefront. But I think what we need to offer them is additional perspective into, we also have to realize that this, this question in the context of technological change. I think we are in unprecedented change in technology, and just today, I think one of the big tech providers, I will not name it, but has released a tool by which you can using a language model, you can instantiate a workflow. You can launch that workflow on a quantum computer in the cloud. And so I think it's both ways now. It's also looking at the future demands on the research side, but at the same time also stimulating innovation, and it's now the coupling that is more important than just passively waiting for push or the drive from the research communities. I think it's a balance that we have to strike. We cannot push anything. At the same time, we have to be respectful and mindful of the demand side, because what we do should be useful. At the same time, it might happen that what we do might create a different way of working on the research side, which researchers have yet to discover. So it's, I think, and that is a balance that is very delicate, and that is something we have to, I think, make sure that happens. Yeah. And I might not be more definitive than this, but yeah.
I would like to pick up also on this topic, and we have seen many technological trends that you mentioned. Organizations like SURF, they offer advanced services that are scarce on the market, and for researchers that are they not only need advanced infrastructures but also expert support.
Yes, yes.
And I wanted to ask you also from your experience from the Netherlands viewpoint, how research support is evolving to accommodate all this variety of innovations, also considering the various layers from university to specialized data centers and so on.
I think this is a very good question, because developing expertise and capability in the ecosystem is one of the pillars that we have to rely on to be able to deliver. And what we have been experimenting in Netherlands, basically in the recent years, is not just the federated and interoperable infrastructures and how to enable that, but also federated expertise. And what we have at the moment, or at least what we're trying at the moment, is that we have a federated help desk and the network of federated help desk across the tier 2 sites, what we call, which are sufficiently large HPC cluster systems in Netherlands, and they have their own support, and we try to coordinate this support in a federated manner via SURF. So which means that we try to build a network of research support and expertise such that not just the big communities or big research projects or only key research groups could be supported, but also support is available through distribution of expertise at every level. So it could happen that if you're a researcher just starting with computing, you might go to your local expert and then say, I want to start, and then that person just gets started. But it might be that a local expert cannot solve your problem because it's outside the bounds, so you can come to serve. And then there is also the spread of infrastructure and expertise that this can happen, and this is the model we are trying. We cannot say for sure how successful it is. It is pretty successful, but I think we have to wait and see what impact it creates in the long term. But I think this is something we are trying. So what we call as federated help desk support.
Thank you. And yes, and this experience links well to our, first of all, to the experience of EGI, and in terms of federating both infrastructures and expertise, and also to our strategic objective number 4, which is about growing this network of experts that are available to support research in Europe and beyond. And we are a bit constrained with time at this stage, and anyway, we'll keep having a conversation with Sagar in Amsterdam, and bring more of these insights into our work. Maybe we can pick up a very final question from the audience, if you have any burning.
So maybe I can ask the final question then. So, and I said on Tuesday already, so the companies, the big companies are developing their hardware which will not be publicly available. So let me draw a picture of the future. So we don't have any small computer centers anymore doing simulation, maybe except those running instruments, but anyhow. And we all go to Google or Amazon or whoever. So is this the future of computing for science?
I think this would be a very dystopian future of computing. I think no. Everybody wants a little bit of autonomy and sovereignty, and governments especially would keep on investing in maintaining and operating the academic computing centers. But I think the scale and the size of it will change, because I think much more exponential investment is going in by other people and other stakeholders in the same ecosystem. And I think I get a lot of these questions on whether we are going one way or the other. I think it's not about one way or the other, it's all about collaboration. But I think the form and the shape and the nature of that collaboration with big tech has yet to be defined and refined. And we have not come to terms with that yet, because I think it's very new, very fresh, and very fast for us to realize that what has happened in the last 10 years, especially when it comes to big tech computing. And I think in the next 5 years or so, we have to make sure, or at least come to the realization that we have to collaborate with them rather than compete, because competing is not an option yet. It's not in the bounds of. So we have to see where we can collaborate and where we can maintain our strategic autonomy. And every geographical region, I would say, country would want that. They would not just give it away in the current context. So I don't see that the future of computing is just only few cloud tech providers providing computing access.
Thank you, Sagar. On this positive message, I will close this part. Let's thanks again our guest speaker.
Thank you.
Can you keep it full?
Yeah.
So now we are at the very short part, but very important. Closing remarks and information about prizes, and also some numbers about this event. So we are closing now formally the EGI conference 2023. We have 240 people on site that came, plus 85 more were participated to online, watching the plenary, so maybe some speakers and some side presentations and sessions. And yesterday we had a very wonderful networking and dinner event. Under 50 people attended, and I really enjoyed it, and because it was not the usual play event where you sit, but there was opportunity to move around, to network, and I guess not only me, but I guess you also you bring back home some new contacts, new people you met here, some old colleagues, and some new ideas also for your work. And we have a number also about many people dancing. For those who left early, there has been some wild dance at the end. It was very enjoyable. And we cannot provide yet the figure about how many number of vodka shots have been consumed. We are still running the process on the supercomputer, but there were too many, so it takes more time. And so all this event is organized mainly for you, so we thank you for your participation as a speaker, or as a contributor, and it's very important to meet not only outside our, say, Zoomverse, and it's very pleasant to see also that many of you enjoyed and were happy for the event. Now let's move to the prizes. First of all, poster competition. The winner is a poster number 3, Building OpenStack Cloud with Kubernetes as Undercloud. And do we have Adrian Rosinec of Klara Moravkova here? That's an applause. No, okay, then we will arrange the prize. So congratulations to them for winning the best poster. And now we go into the best picture, the photo competition that also last year, if you remember, for those last year, there was a digital twin game. Let's see now who are the winners. So we have 2 winners on the first prize. We have Oksana, and okay, the other name is missing from the other picture. Okay, okay. Okay. Okay, so congratulations to you, and also you will get a prize. And now we move to the thanks, because an event like this requires months of preparation and a lot of work with them to make it happen and run smoothly. So first of all, when we organize an EGI conference, we always look with a local partner, a local host. And we check within our partners who was willing to organize the event locally. And here we need to thank the enthusiasm of Marcin and the power of Agnieszka, who helped a lot to make this happen, this event happen here. You can come for a prize, we have a gift for you. And they not only offer the great opportunity to have this event in this very good venue, but also they cover the full 360-degree experience, from Marcin being an historian, telling about the stories about the city, being also the guide for the parties and after parties and after parties. Congratulations. And also Carolina, we mentioned here as he was part of the PCNC team. Now we go to the next people to thank. We have from the DGI staff, we have Ela and Shamara, who have been very instrumental to both get ready from the admin viewpoint, and also they were at the reception to help. So let's thank Ela and Shamara for their valuable work. And last but not least, we have the EGI Communications Dream Team, who made this event happen, and with the not only for the event, but also the communications, all the brochures. We have been producing and finalizing lots of new material. You will see lots of more coherence and more quality in our publications and for the event itself. So let's thank all the Gwen, first of all, who is our event manager for the event. And then we have Magdalena as a communication lead, and Ilaria. Thanks a lot. And the last message. So, as I mentioned, this event is not finishing here, so it will continue. In the afternoon, we have the Intertwin closed technical meeting. We'll continue. And then we'll be in the Barcelona room, we have the EOSC platform session. In the Oslo room, we have Euroscience Gateway and the Polish Data Repository for EOSC. Then in Dublin, Federation Management Solutions. In Berlin, Data Spaces Governance Consultation. And tomorrow we have still a list of very interesting trainings for you to enjoy and learn from the experts. Thanks a lot, and see you next year.
To the ScienceMesh session. How was lunch? Are we happier with the belly full? Always easier to work after we eat, I suppose. So I would like to welcome also the online audience that in the meantime patiently waited for us to start. And also in the morning we had the more user experience presentations, and now in the afternoon, as informed in the morning, is a more technical part. And with this, we are going to open the afternoon session with the technical demonstrations from the CS3Mesh for EOSC colleagues. So we have three panelists, as you can see on the screen. We have, someone fell down. So we have Milan Dashnek, he's from CESNET, and he's presenting from home. Then we'll have Elisabetta Ragozzina from CERN, which will be followed by, also from CERN, Giuseppe Lopresti. So I would like to call on stage my fellow colleagues, Giuseppe and Elisabetta. Welcome. And then just to provide a short overview, let's start with Milan. Milan works for CESNET since 2016. His main responsibility has been to develop close collaboration with research communities within the Czech Republic, and he also focused on supporting the specific requirements in the data storage area. Regarding Giuseppe Lopresti, so he works for CERN since the last 18 years for large-scale storage services targeting the scientific community. He has been contributing to development and operations of the tape storage system for the experiments at the Large Hadron Collider. Last but not least, we have Elisaveta with us, who has been working from CERN since the last 3 years in the storage team. She has been contributing to the front-end development and the UX design of CERN Box. Let's start now with Milan, who should be online. Milan, can you talk, please?
Can you hear me?
Milan?
Yes.
Hello. Hello, we can hear you.
Yeah, perfect.
Welcome. So I would kindly invite you maybe to do the presentation from your side, sharing your screen.
Okay, I will try to share the screen. Give me a second. Okay, can you see my screen?
Yes, we can.
Okay. So, good afternoon. My name is Milan Danicek, and I'm working in SysNet. And with my colleagues, we have been mainly responsible for the development of so-called invitation workflow, which is a part, let's say, very important part of the ScienceMesh. And I would like to briefly introduce you the invitation workflow, and then I will show you short demo. So what is it, invitation workflow, and why actually we need it? There is a so-called Open Cloud Mesh protocol, which has been used to create federated sharing between sync and share systems. This protocol was already established before the ScienceMesh project itself, and it enabled users to share their data with known users across the sync and share system supporting Open Cloud Mesh API. Known users in this term means that the originator of the sharing, so the person or user who wish to share the data, must know the target user system and the identity of the target user in that system. This is a bit inconvenient because there are cases where you simply know only the email address, which doesn't need to be necessarily the business address and so on. So we develop invitation workflow, which this invitation workflow provides a user discovery mechanism for the users. This workflow establishes the trust relations between users from two separately operated sync and share systems. And this invitation workflow provides invites, which these invites or invitations are sent via any textual communication like mail, chat, or any other preferred way. Once the target user accepts the invitation, the trust is established between the users, and the user identity is revealed to the originator, to the originating system. So the user which wish to share the data can simply find you in the context or in the search button and can start sharing. This invitation workflow is bidirectional, which means that once there is established trust between user A and user B, that the trust is also established in the opposite way, so that later on, for future purposes, user B can share also to user A. So we prepared a short demo, which demonstrates the invitation workflow between OnCloud 10 and Nextcloud. The demo is performed between two users, between Miroslav from PSNC using Nextcloud and between Milan, basically me from SysNet, using OnCloud. Miroslav wished to share the data with me, but however, Miroslav doesn't know what is my target sync and share systems, or where is my organization, what is my identity in the system. So he generated an invite. Then this invite he will send to me by email, and then I will click on the URL in the email, and I will reveal my identity during the acceptation process to the Miroslav Nextcloud. After that, Miroslav can find my identity in his Nextcloud and can start sharing data with me. The accepting of the invitation established the trust relationship between the users, and this trust relationship is used to share various resources. In our demos, it's used to show how to share the data, but it can also be used to share applications, and it will be introduced by my colleagues consequently. So I think that's the introduction, and if I can ask you, Rita, to play the video. Is that possible, Rita?
Is ready.
And please, can you mute it? I will comment on it so there is no background.
Can you see the video?
Yeah, can you mute it, please?
Wait, I need to adapt the audio a little bit.
Okay.
Can you see the video?
Yeah, I can see the video.
Okay,
but please lower the volume of the video. You can
sure.
Mute it.
Can I mute completely?
Yeah, you can mute
okay.
it completely.
So I'm gonna make play.
Perfect. Thank you. So now we are going to the demo itself of the invitation workflow, and I will demonstrate the cooperation between Miroslav from PSNC and between me from SesNet. So now Miroslav is going to log into PSNC Nextcloud by the federated using his federated identity. So now the login is done. Miroslav will now upload the data which he wished to share with me. So now he's uploading the dataset which he wants to share. Okay, the dataset is there. Quick check if it's complete. Okay, dataset is correct. And now Miroslav is going to generate the ScienceMesh invite. So now the link is generated. He will copy to the clipboard, and Miroslav will send me this link via email, which is the only contact information which he knows. So yeah, he will compose the email with the invitation link. Perfect. Yeah, and he will send it. Good. Now I will go to my inbox. Well, I see I have new email from Miroslav, so I will click on the invitation link from the email, and I will be redirected to the Mesh Directory service, which is the service to choose my home sync and share system, and where I can perform the acceptation of the invite. So I will reveal my target sync and share system. Now I will log in into our SysNet service, which is on cloud, and now I will accept the invitation from Miroslav. So click. So it was successful. So now back to Miroslav. Now Miroslav can already see my identity in his sync and share system because I reveal it by the acceptation. So now Miroslav can share the folder to me. So now Miroslav will find my my identity. Good. So and he can start the sharing of the dataset. Now it's complete. Now back to my OnCloud accessNet. I will check the files shared with me. Now I can see there is the incoming share from Miroslav, so I can accept it. And once I click on accept, I can see the dataset being shared from Miroslav. So it's finished. Okay, so that's all from my side. Thank you.
Please. Let's leave the questions for the end of the presentation of this session. In this case, I'll call Elisaveta to come here to start her demo. Oi.
No sound? All right. Hello, I'm Elisaveta, a software developer at CERN, working for CERN-Box. And I want to showcase the outcome of our work on implementing federated sharing between CERN-Box and an on-cloud infinite scale-based platform. Yes, so for that we integrated OCM layer, similar to the previous demonstration, into our backend Riva. So the first step is also establishing trust between two users, and for that, let me just stop. We implemented an extension that manages the invitations between users. So as a user who wants to invite another user, in my case it's me, who want to invite, for example, Albert Einstein to collaborate. As this user, I generate an invitation in this extension. I can add a description to this invitation. I can also enter an email of the invitee. And in this case, our system automatically sends an email to invitee. So I'm creating it and generating the token. You see that here I see the overview of all invitations. Albert receives these invitations. He follows the link that leads him to this ScienceMesh directory. He selects his provider. In this case, it's Marineford, an OSIS-based platform. He clicks on accept, that redirects him to his platform. And he basically accepts the invitation. He can also select and manually enter some information. Once he accepted, we both appear as federated connections by each other, and we are getting notified that a new federated connection has been added. And now I finally can share with him. He can also share with me, so it's a mutual sharing possibility. So I create a share, select his account type as federated. Now I can find him here. I give him the editing access rights and share with him. And by him, in his platform, he can now go to his shares and find the shares that I made with him and basically browse through this share. And what else he can do, my colleague, sorry, my colleague Giuseppe will also show you. Yeah.
Oh, thanks, Lisa. Yes, so now we play the role of Albert, but of course I'm not Albert Einstein, but still. So the idea here would be to also, to show a bit also the added value on top of just sharing data, right? So in this case, the idea would be that I have this view and I dare showing it live so that we see it really like with the browser. So I'm actually browsing what I received from my remote colleagues. In this case, I have this shared science that these are shared with me. So what is the extra added value of ScienceMesh? One of the values that we discussed already even this morning is that it's not only about data, it's also about applications. So I can also open this file using the remote application. So you see that here I'm at this site, which is my own cloud. And in this demonstration, Lisa belongs to a different site with a different prefix. So now I'm actually navigating into her system. And I'm editing together with her, and we see here that we are two collaborating. So she is the owner of this file. I am a remote user, and we can actually collaborate together on this editor. I mean, this is one of the many common editors that exist in the open source market to do markdown editing. It can actually be anything, in fact. I mean, this kind of process would work actually. So what we integrated is, as we mentioned this morning, Collabora on the Office as on-premise solutions for collaborative editing. And of course, I can type, and Lisa can type on top of me. I think she's even typing on mobile. Okay, why not? And yes, so then you really get the collaboration going across clouds. And you see here, we're not using any Google account, any Microsoft account. You know, there are no big clouds, no big data players. We are just sharing across the two systems that we belong to, so the two institutions to which we belong to. Okay, so far for the demo, and I will actually jump into some more slides to give a little bit of more context on this part. So yeah, let's go even. Let's work even with the full screen. Yeah, that works. Yes. So yes, essentially what we discussed, what we demonstrated here, what already we discussed during the session is indeed trying to build on top of an existing layer, and the existing layer being what we call the OCM. So OCM is the Open Cloud Mesh standard. So I wanted to give you a little bit of context on that, also to anchor this into something existing, not just words or acronyms. So I'm going to introduce a little bit what is this standard, how we expanded it, and how we are looking forward into evolving this also for the future. So this Open Cloud Mesh, actually, this is a standard that exists already for several years, in fact. Initially, it was adopted, it was actually formed within the giant kind of framework or envelope, and then it was adopted by our project, the CS3 Mesh for Use project. And in fact, it's just a simple protocol to do vendor-neutral sharing. So it's a way to share across multiple enterprise file system sync and share systems. So those are like on-cloud, Nextcloud are the prominent ones, but in principle, this can work with any of these kind of systems. And the idea would be, so this existed already in the first place, so why don't we build on top of it? And indeed, there are implementations on Cloud and Nextcloud are the most prominent ones. So the idea would be to indeed build on top. So build on top, what does that mean? In fact, what existed in the market was a kind of preliminary implementation. And within our project, we managed to standardize to have a kind of a first official version at the very, very beginning of the project, and an extended one just a month ago. And what do we have in this standard? In fact, we have the sharing itself, which I call multi-protocol, and you already saw how it is multi-protocol, but I will give you a few more details in a moment. We have what we call the invitation workflow that has been demonstrated by Milan first and also by Lisa. So this is the way to establish a network, what they call a curated network of trusted users. Curated in the sense that here the idea is that you contact other users for which you know the institution, and the institutions are themselves establishing trust via this directory of trusted sites. And this would overcome the limit of just sending over an invitation by mail, which is like spam. I mean, you cannot really trust just an email address. This would be a way to have a trusted recipient for a share. And, okay, some kind of discovery capabilities, because, okay, those protocols expand, and then you have to know what the other system is capable of doing. And so in terms of really technical endpoints, just to have an idea at least how this protocol works, so there is a discovery endpoint, where there is no need to get into many details there. Then there's this share endpoint that is actually how you tell a remote end, I want to share something with you. And this is actually what supports multiple protocols. Then we have the invitation itself. So with the principle that I send an invitation to somebody else via mail, via whatever I like. The recipient will send me via this endpoint, so via OCM, the fact that, okay, they accepted it, so we are ready to exchange information over the two systems. And then there's also a notification endpoint that is actually there to notify about changes. So I want to change the properties of a share, I want to actually drop a share or whatever else. And in fact, for the specific details, those protocols, what we call protocols, are actually the way by the protocol, by the OCM exchange, to describe those two most important added values. One being the applications, like we just demonstrated, and the other one being the data transfers that Ron described early today. I will concentrate here on the applications because this is actually what we have demonstrated. And so here really the model is it's kind of simple, but you have to already split it into multiple layers. Because one thing is that you share as a site some data, but also some services. And this can be anything indeterminate. We demonstrated with an editor. This can be Jupyter Lab platform, can be really anything. But it's conceptually a different resource compared to the data, right? So those two go via different transports. And the recipient, the remote user, should be capable, and it is enabled actually, to either browse the data, and this is typically via WebDAV, or also access the remote application. So it's given a link. That's why I'm really giving a link to navigate into my colleague's system, and so that I can interact with the other system. And this is how then things work. And of course, if I have also my local application, I have to be careful in not making it collide. I mean, ideally, I want to use the remote one to collaborate. But it can also be that there are cases where I want to use my local application. Why not? So this is a little bit the context and the principle how we are building on top of OCM. So OCM is just there, and this is a kind of added value on top of OCM. And a typical question that we got, and I want to kind of reassure, is that it's clear that this is like exposing services, so potentially there are licensing issues. But at the same time, what we see typically with those systems is that they already offer what we call public links, which is exactly the same like we have in Dropbox or in Google Drive, where you have a link which is anonymous and can be accessed anonymously. And so this is in a way something similar, where we have some kind of authentication, but effectively it's a kind of anonymous link. And typically applications are already enabled in those public links. So after all, even vendors are, we have been in contact with the typical vendors in this case, like Collabora or OnlyOffice. They already supported this kind of model. So it's not really breaking very much the licensing principle of those providers. Let alone the fact that platforms like Jupyter Lab, they are anyway on the open source. So it's kind of logical that they are even more open in this way. So to summarize, so you see that here the goal and then the key is really the sustainability. So OCM is there, it's already implemented by the vendors, and we are just building on top to provide those what they would call added value services. So applications on top. And what is coming next is that, well, at least the good thing of this project was that there has been some renewed interest. There is even one partner, well, not really partner, it's a contractor, but is partnering with us in doing some developments that went the extra mile in asking for more funding and keep the wheel going in terms of how the standard itself can evolve and how can other features can be added, for example. So I would actually expect once all of this is really deployed at scale, and we are still at the kind of commissioning phase, so this is really being installed, that then more things will come because of the user, how the users will adopt it, essentially. And with that, I thank you, and I guess we can go to questions and discussion.
Thank you. Is there any questions from the audience here in Poznan? On questions? Let's see, we have half an hour left.
We have quite some time.
So is there anything you, Elisaveta, and also our online speaker would like to add before maybe we can go for the coffee break? Milan.
Maybe that is remote.
Are you still with us?
We should switch maybe to Zoom to see Milan at that point.
Can we go? Is there anything else you'd like to add, Milan, before at least here in Poznan we go to the coffee break? I don't think so. It seems. Okay, so in that case, thank you, Giuseppe, Elisaveta, and Milan for your presentation. I think now we can consider this part is over. We can go for for a break. So there will be the EGI conference coffee break from 4 till 4:20. So we'll be back here at 4:20, and we'll start with the presentation from Ron Trompert about the OSC and the ScienceMesh. So thank you very much, and see you in a few minutes. Thank you.
Thank you.
Recording stopped.
Solution is encircled the bottom left, and that is about a web of fair data that is going to solve the issues around fair data and open science. And that's the whole idea of the EOSC, that you have a set of services centered around services that provide you with data. Okay, and in the meantime, this European Open Science Cloud also has an architecture. There are, you have, let's say, the EOS core, where you have the core services, policies and procedures that you need for the whole infrastructure. And then you think about rules of participation, security coordination, help desk, what is it, AAI, things like this. Then, of course, you have the EOS exchange layer. Those are the services that interact with this open data, and there they envisage a number of pillars that are, let's say, either regional e-infrastructures or e-infrastructures that are centered around scientific user communities, each having their own middleware, portals, dashboards, and what have you. On the left-hand side, there is the support activities, and on the right-hand side, the interoperability framework to make sure that everything is able to talk to each other. Now, about this project, the CS3Mesh for EOS, that stems from the CS3 community, and the CS3 community consists of a number of sites that run sync and share services for their own constituency, their own people. Once every year we join, we meet at our yearly meetings, and well, the last one was in Barcelona, organized by Gideon. Thanks still, Gideon. What we also do during these meetings, we fill in a survey. And it appeared that, let's say, last March at least, that there were something around 20 sites available there, and altogether more than 600,000 users, which is a hell of a lot. So where we started with, so to speak, with already existing sync and share services that are already sustainable, financially sustainable. They do not rely on European funding at least, but only on national or institutional funding. Join together to, let's say, federate the resources and to enable users to share data and services. And that's what we call the ScienceMesh. Of course, there's a very lightweight central component there, which contains the central services like help desk, monitoring, a site registry where all the sites are listed, usage metrics, and the like. And the rest is just, we have just a number of sites. And of course, these sites can already exist without the central component. If that were to be would be down for a day, it would not be much of an issue. It would only be problematic to add a new site or to remove a site, but the whole infrastructure would just function normally. So it's a very lightweight component, which is not critical for the operations. Okay, well, over the last, we started with our sync and share services at SURF in 2014, and most institutes started around that time, or maybe a little bit earlier then. Since then, and then you talk about the 2013s, 2014s, so on, let's say the on-premise and also cloud-based sync and share services have increased steadily, and I'm not just talking about the big guys like Google, Microsoft, but also things like Ignite, P-Cloud, the Box, and there are a gazillion EFSS service providers. Most of them are in the cloud, but some, like also OwnCloud, NextCloud, provide also sync and share services that you can run on-premise. And of course, I've just also been discussing the user numbers that we have. these services have become quite popular. And why is that so? Because they are so incredibly easy to use. It's a very low threshold for people, even people that are not really tech savvy, they can handle sync and share services. And the good thing is that wherever you go with your laptop or your tablet or phone, you get your data with you. You have always access to your data. It's also easy to share data, not only with your direct colleagues, but also inside, outside your institute, whatever you want. And that is also a development of the last number of years. Although a lot of these services just started out as Dropbox clones, let's say there has been a lot of effort into let's say to integrate those kind of services with well, let's say all kinds of business applications like Salesforce, Zoom, Slack, Atlassian Suite, what have you. But also, let's say, in the science domain, and we've also been discussing this today, like with just Python notebooks, Moodle learning platform, and the like. So this is also a very important thing, that you can integrate these services with all kinds of other stuff that is useful, and not only integration with other services, but as we've seen this morning with the integration of Escape and the ScienceMesh, also integration with other e-infrastructures. Okay, and it is expected, because I also need to explain this picture, of course, that the enterprise file sync and share business is going to grow up until something like $26 billion by 2027. So the growth is still there. So yeah, where do I see the ScienceMesh? And that's the let's say the European Open ScienceMesh Cloud. Is I see the ScienceMesh just among the horizontal services that are there and play their part. So, reason for that is that, of course, it's not the horizontal services are those services that are not really related to a particular type of user or user community or whatever. This just for the general public, and that's exactly where these sync and share services are shining. Difficult sentence. Yeah, what is the good thing about this? These services have the potential, as I've already discussed with you, to reach an enormous amount of people. I mean, just now I've been talking about 600,000 users. Now, not all of them are researchers, of course, but if you think that in the whole of Europe there are something like 1.9 million users, means that these services can, let's say, reach a large portion of them. And the good thing is we already talked about integration with all kinds of stuff. These services can also integrate with services delivered by EOSC, which means that these services have the potential to, let's say, bring EOSC to the masses, not just the certain user communities or things like this, but just everybody. And that's also a good point, because you as a user are just using the sync and share service of your own institute, and then immediately you should be able to access resources from EOSC. Well, it doesn't get any cooler than that. So, let me see, yeah. And of course, yeah, there are also users that do not directly have access to EFSS because their institute or whatever does not provide that to them. But there are also other options. I mean, a lot of sites have a sync and share service just for their own organization or let's say the collaboration they're part of. But of course, there are also partners, or at least potential partners, that are allowed to deliver these kind of services to a much broader audience. So those kind of services would be a way in to them to use the resources of the ScienceMesh. Currently, there's also a procurement in progress that's called Managed Services for the EOS platform, and there's a lot 3 which deals with enterprise file sync and share services, and of course, this procurement will be won by a consortium or an organization. And of course, through the winner of that procurement, it's also possible as, let's say, what we call a homeless user to be able to use the resources of the ScienceMesh. Yeah, I'm done.
Thank you. Any questions for Ron before we go to the panel? Any questions from online?
No, everybody is looking forward to the panel.
And you were very clear in your presentation. Thanks, Ron.
You're welcome.
So a round of applause to Ron. Okay, now it's time to start our second and final panel of the day. So I would like to call on stage the moderator of the panel, Guido Adben, who is a senior international strategist officer at SUNET, the Swedish ANREN. And then we have 4 panelists with us. The first one is Andrea Cristofori, Data Solution Architect at EGI. So welcome, Andrea. We will welcome you to come on stage. Then we have the ScienceMesh for EOS project coordinator, Jakub Mosiski, who is also from CERN. Then we also invite on stage a person who was not here before. He is Gideon Vandenberg. He's a research and project manager at ESADE. And last but not least, we have 2 online panelists. One is David Antus. He's the head of storage department at CESNET, based in Czech Republic. And then we also have Christy Holmes from the United States. So she's presenting, if I believe, from Chicago at this moment. And she's the director of Galder Health Science Library. I see on stage Kuba, Gideon, Andrea, also Guido. And can we listen also from home, David and Christy? Would you mind to talk to us? Andrea, David Antus?
Yep.
Hello, good afternoon, welcome. And then now Christy Holmes.
Yes, good afternoon.
Hi.
There you are. So they're over there. Ah, there they are. Fantastic. Wonderful. Both of you.
Okay, excellent. It seems we are ready. Guido, over to you.
Wonderful, I'll take it. So, question of order. Is this still the prank laptop that can fall down? No, it's the other one, right? Okay, because I break everything. And the second question is...
Don't touch, please, then, if you break everything.
Okay, I won't touch anything. Won't touch the subject.
Put your hands down. It's not necessary
to be like that. You don't want me to do that. So what microphones do we use? We've got 2 on stage. Can I use that one to walk around with?
Of course.
Wonderful. Thank you very much. All right. To set the stage, and riffing on the description that Ron gave about the premises of the project and how we think it's going to pan out, at the same time, most of those conceptions were... We came onto those conceptions about 5 years ago and drafted the whole proposal. Surprisingly got funded, yay, but that was 4 years ago. And you know how it goes as a project, you go nose down, you hunker down, you start developing. Then we were hit by COVID, which made it into an even more sort of isolated effort. And now we emerge, we're like 5 years after the first draft of the tenets. It would be hubris to think that nothing has changed. I know that we've had a bit of scope creep. We haven't delivered precisely what we said we were going to deliver. And meanwhile, we're delivering to EOS, which itself has shapeshifted a fair bit. So we thought it would be wise to ask a few people who have had exposure to the wider audience, the use cases out there, how the environment has shifted, because we don't do this in splendid isolation, and those people who have some contact with where EOS is going and where internationally this is going. So we thought we'd throw a few questions at them. And I had trouble figuring out whom to give the honor to, because they're all luminaries, like the nicest person in the world who organizes conferences, person representing the people who organize this conference, boss, my boss, and then there's 2 people who took the trouble. Can we get them back on stage? the heads. Oh, you're doing this. Well, I'd like to have the heads of the people on the, yeah, there we go. So 2 people who actually took the trouble to arrive virtually. David, thank you. But I think the greatest honor goes to the only non-European in the room who took the trouble to talk to Europeans. Thank you for doing that, Christy. Would you mind if I opened the debate with you?
My pleasure. Sure, that sounds great.
Because for you, it's what? It's 5 a.m.?
It's actually just after 9:30.
Oh, still a lot of respect, but a little less. So we've got you here because, first of all, you're a non-European. That gives us, that stops us from navel-gazing too much. You have a view on what has been developing and how useful that all is. Secondly, you're in the medical field, who are a crowd that's hard to please. So anything that's developed, if it's not properly useful for a researcher, you will know this as one of the first canaries in the coal mine. And the second thing is, you have proven that you care about international collaboration, given that you're on the Invenio RDM development team. So there's two questions really I wanted to ask. First of all, assuming that you're relatively aware, somewhat aware of where this whole IOSC thing is going, can you see parallels between what's happening here and what's happening in the US? And if so, which of the ones that we're doing is useful to you, and which of the stuff that you're doing should be better known here? How can we intertwine the two?
Sure. So I will attempt to answer this. I think, you know, as we've you mentioned navel gazing, and I am very certain that the people in the United States are also navel gazing. So first and foremost, perhaps one of the most important things that we can do is to work with one another, you know, be able to foster more international collaborations that are genuine and authentic. I think so many times bureaucracy gets in the way and it limits our ability to actually dig in and do good work together. And so, you know, I've been absolutely thrilled to read more about what's happening with EOSC, and certainly think about it in the context of what's, you know, our very young attention to open science at a much broader level. And I can see that there are a number of exciting advancements that are happening within EOSC that I certainly think that we in the United States can take advantage of. You know, I've said before that sometimes the best way that I can seem like I'm really paying attention to what's on the horizon is just to look to the European Union, because I do think that because of the structure there and some of the other contexts, there are more opportunities for collaboration and cross you know, kind of cross-domain and cross-national collaborations that actually result in real work. I'm sure that there are things that are happening here. Certainly there's been, I'm on the leadership team for our Augmented Intelligence in Medicine Institute. And we are, you know, really excited about some of the technological advancements that we've been able to do, and how do we think about you know, being able to do this work in the context of a more open ecosystem, you know, doing AI and machine learning, which has been, there's been a huge attention to that, obviously everywhere. So, you know, I wish that I could bring to this conversation some, you know, this brilliant statement about how we should all be working together and what we can bring to the table and what you can bring to the table. But I guess what I would suggest that we all do is to come together and, you know, open up those channels for dialogue so that we can learn from one another and see where those collaborations make sense and where we can begin to grow, you know, the larger ecosystem together.
To throw a curveball at that, I think it was Zbigniew Brzezinski who, thank you, I pronounced that correctly, absolutely did. 15 paws twitching right now. Who at one point in time made the remark that you can't deal with Europe because you can't pick up the phone and call them. We're in the strange situation right now, I feel, that it's become hard to pick up the phone and call the US. Who do we ring to get a grip of coherent policy around where research infrastructures are going? I can see excellent work being done on a university by university basis, but whom would you recommend we liaise with on a regular basis to figure out where the ship is sailing?
That is a tricky question, so thank you. I will suggest that there are a number of important initiatives that are happening at the federal level. Certainly, we've had a renewed emphasis on open infrastructure and open processes, particularly from the White House Office of Science and Technology Policy, with some of the open policy mandates that are coming down the pipeline, the first of which landed at the National Institutes of Health in January. And that's really, I think, brought an incredible amount of attention and enthusiasm around some of these open science topics. Certainly NASA is very early to the game. They're really leading the charge with open science in the United States right now. So I do think that there are those individuals and certain organizations who can be that champion, that advocate, the glue that brings people together. There are also, I think, good opportunities for either domain or national dialogue. For instance, in July, there is a NASA CERN Open Science Summit. And so we'll see a number of people coming from many different domains, from our side of the pond and yours, getting together to talk about meaningful progress to support open science. So I think, providing more of those opportunities where we can get together and connect is important. There's a huge amount of attention at the federal level on this. So it's really about thinking about how do we want to make those connections, and then providing the opportunities for real dialogue, many times face to face. It helps to build trust, helps to build teams in a better way that can be more productive. And I do think that there's a large amount of interest and enthusiasm here as well. And, not that I certainly can't speak for the entire United States for sure, but there are folks that we'd be delighted to help to make those connections with.
No, fair enough. Sorry for that dig. All right, thank you. Moving on to our next remote speaker, David Antos. I'm sure I pronounced that correct as well.
Yeah, excellent.
Twitching as well. Sorry about that. So, not only are you a member of the CS3 Mesh for IOSC project team, you also sit in on one of the TFs of the IOSC Association. Am I right?
Yes, I was volunteer for that.
It's the long-term data preservation TF, isn't it?
Yeah, indeed.
It is, right. So what intrigues me is that the project that we're running here has the potential to hoover up a lot more of the born digital data that otherwise would get lost or slip to grey IT or sit on NASA's under desks, etc. But that doesn't mean that we also we present the danger that we present a greater influx of data that needs to be preserved in the end. Would you agree with me up to that point?
Well, yes.
So the point is that typically what funders like is data that can be linked to a peak science funding stream or experiment or the typical curing childhood cancer, healthy aging, etc. They love to fund that. What we seem to represent is enormous amounts of, as of yet, unclassified data. And we're about to move that into long-term storage or present it to long-term storage. Have you heard inside of your TF people talk about what sort of merit allocation mechanisms need to be applied to long-term data preservation? Curveball?
Yes, I've heard people talk about that, but first there is a slight disclaimer because the outputs of the task force are under review by the EOSC Association, and before they're approved, we are not expected to present them. So everything I say is just my personal opinion, and I would like to ask you to take it like this. Anyway, the difficulty is that the task force hasn't actually discussed the processing of the data and the annotation of the data. The task force mostly focuses on recommendations for data repositories, which is not only another league, that's probably another sport in data storage. So I'm afraid that there is no meaningful way to answer that, because the data must be reasonably annotated, equipped with metadata to be stored in the repository, which on the other hand should not be the cemetery of data, the final resting place. It should be a place from which the data is again taken up for processing. So I think that nobody has answer for this at this point.
All right, fair enough. But an analogy that you could draw is if you aim to preserve data for very long and you do so with the intent to eventually mint it for useful nuggets, you know, your future Nobel Prizes, then it's somewhat akin to an insurance proposition. You're insuring against a future event, but you don't know which event it's going to be. And the answer typically, oh, look at that face. You don't like this question, do you? And you don't quite know what the event is going to be. If you knew, then you would actually build fire breaks around the house that is going to catch fire. But what nobody does is insure absolutely everything against everything, because then you're basically bankrupt. So is the TF avoiding this question? How are you dealing with this in Czechia? I know you're the head of the storage department. You must have an opinion about this. If you don't answer this one, I'll stop teasing.
There were two questions. How we handle this? We built a platform to operate data repositories, and we are pretty well aware that this is a serious problem that mostly needs people to get educated about handling data, to build an infrastructure that consists not only from the technical part of things, but also from people who are trained to be reasonable in handling data and to act as data stewards. And we basically offload this question to them. And we probably lost you.
What did you say there? Oh, sorry, I thought I interrupted you. Okay, I'll repeat. What we're building here is essentially a data hoovering system, right? It makes sure that data that's born digital gets hoovered into a proper data managing system, rather than people dealing with it on a side-by-side basis and it potentially being lost for well-governed IT. Are there things that we can do to help the policy people that you just described? Are there mechanisms by which we can mark particular data sets or pre-nominate, or do you have recommendations for the system that we're building here to make sure that it allows those policy people and their funders to better recognize the data that's coming out of the system?
Well, I don't think it's possible to do on the infrastructure level. I'm afraid this must be done by the user communities who have understanding of the meaning of the data. It's very difficult to say from my perspective. I store a lot of data I completely don't understand, and that's my role as an infrastructure to handle the infrastructure part. And there must be another role for people who are able to mark the data sets that really are important and should not get lost. I don't think that there is a silver bullet to solve this issue in general, and I believe that the only recommendation is invest in data stewards who need to understand the meaning of the data.
Yep, that's fair enough. I'll park that for the moment. I'm sure we'll get back to it. Kuba's scribbling frenetically. There must be something in his answers right there. But we'll get to that eventually. Andrea, would you mind if we move to you? Because you're the Data Solutions Architect at EGI. That's quite the day job. Can you, Kuba, could you? Oh, you're giving him the microphone. Wonderful. So the main thing is, I know of no organization besides EGI who have better contacts in the Brussels area. And one of the most interesting things to come out of Brussels after we started this project was this whole concept of the data spaces. It sounds like it might be a match. It also sounds like it's way too lofty to be a match. What's EGI doing to position itself, and what recommendations do you have for what we're doing here and how the whole thing could be a fit? And take half an hour.
Well, okay, it's a bit difficult to...
I know it is, sorry. But it's so intriguing, I had to ask.
Yeah, okay. Trying to put together all different type of data and anything. Okay, like with the ScienceMesh is a very good opportunity, I think, because you are trying to connect.
Speaking
to sorry, yes. Trying to connect all different EFSS. So is a very good thing. There is of course interest in that. It was mentioned before that there were also projects with AI that. They might require data of different type. So, okay, there is interest in that, and there will be more in future for sure, because, okay, a lot of data that is stored in different institute should become available, and probably through also this project put together and analyze together. So these data spaces, I see it like coming together, but not in only one place, coming from different places, connected together, and in different combination, depending on the project, on the research that is being done, and okay. I don't get exactly the data hoovering that were discussed, because most of the time probably the data will remain in the institute where it's produced. They will stay, but then the researchers will just want to access it from time to time, or download a part of it to work and build something new. And I agree that is difficult to understand what is the data that is important, because it's really difficult for a non-expert to define what is important, and then it might be important even for an expert, but it might be too expensive to keep everything. Oh, yes. So it should be balanced, what is important and how much should I spend to keep it available. So yeah, I think is complicated.
Yeah, very true. So in a very short explanation, the hoovering part is the sync and sharing. The syncing part makes sure that the data that lives on laptops, etc., gets synchronized to more central locations, which I know must sound like a pedestrian thing for people used to the sort of level of EGI, but very often in the long tail of science, a lot of data is produced locally. And then only by the time people realize that a petabyte is a lot to move, do they go, oops. Okay. So when you're able to move that stuff as it's being generated, so facetiously we tend to refer to that as hovering up the data before it becomes a problem. Okay. Does that change your answer?
No, not exactly, because I was thinking to that as a kind of granted that it doesn't sit on my laptop, but is in the data center.
See? Naive assumptions. The tool you like to use is not the tool users use. In fact, I've sometimes made the remark that if you see a user ram in a nail with the heel of their shoe, give them a stronger shoe. Don't try to lecture them about pop nails or whatever. It's not going to help, right? That's just, users are a special breed. Mm-hmm. So the second part of the question is, governments have a tendency to allocate funding to organizations proportionate to the size of the funding. The data spaces are billions. How is EGI positioning itself to make sure that that doesn't end up with the usual suspects? I won't mention names, but there is a tendency to chunk that up in maybe 4 bits and give it to people who can handle 1 billion. I don't know whether EGI can handle 1 billion, but oops.
No, probably not. I don't know.
You know what I mean, right?
Can try to give and then we see.
Yeah, absolutely. Oh, somebody's Italian.
Accept the challenge. Well, okay. We were trying to give all the opportunity to all the participants, and as participating in a different project, I've seen that we're trying to give to use resources from all the participants. Of course, there are some that are bigger, and then they might participate in more projects, and they might then end up with a bit more funding, but still they tend to be fair in a different way as the fair data, but to allow all especially even the new participant that might have just joined to try to make them part and grow with everybody else, so that they can shine with everybody.
Yeah, wonderful. Not an easy job, but
no,
we do the good work, EGI. We rely on you. All right, moving on to Kuba, man of many hats, head of the storage department at CERN, head of this particular project, also in the interoperability TF, I believe. I had some questions for you, but you were scribbling so furiously that I wonder whether I should be allowing you to answer your own question. Which one is it?
Well, you know,
on Polish pronunciation?
I'm with the hat of the TF interoperability of the EOSC Association. However, I can't help of remove, you know, it's not easy to remove the hat of the project coordinator, and part of the job description of a project coordinator is to have an opinion about everything. So I wanted a little bit maybe to relate what Christy was saying and David.
Is any
if
of
you
us
allow me?
Is any of us in trouble?
No.
Phew. In that case, go ahead.
So for Christy, I think, well, I had two thoughts when I was listening to what you were saying. Maybe one mechanism to enhance, you know, somehow to incentivize a little bit more the collaboration across the Atlantic would be to use some funding platforms which has specifically been designed to do that. So, for example, I'm thinking of NGI Atlantic, which probably is something that ended this year, but it's a good, maybe it's a good example of something that we could try to exploit in the future. We've actually in our project we were thinking about that. I remember
we went further than thinking.
Yeah. So there could be some opportunities along these lines, and then of course what you are doing with Invenio RDM, essentially, you know, this is a wonderful example of you identify a need in your user community on some service that you want to provide, and essentially we collaborate based on very concrete services that you, on both sides, we find useful for our respective user communities. So I think definitely there's a lot of space and different possibilities and pathways how we could try to strengthen these relations. And so I don't know if you agree with that, but I just wanted to share a remark. And for David, for the preservation, you know, we also have a lot of discussions at CERN about preservation. And my personal take on preservation is that it suffers from the same problem as for metadata annotation. Essentially, it comes as an afterthought, typically, at the very end of the research, life cycle, data life cycle, and essentially, this is the moment when it's already very late, or possibly too late, because essentially, once you publish your result, you are so much relieved with the fact that you've achieved that you are probably not so much inclined into, looking into kind of secondary things like this. So one of the possibilities within the ScienceMesh is to try to, enhance the workflows that we propose, like we are doing for firm metadata annotation. We try to bring it earlier on into the data research data lifecycle, and something similar could be done for data preservation. And here, maybe the technology could help. because a lot of systems around data preservation are based, for example, on containers, where you, as a way of capturing the applications and also maybe some smaller data sets. We also have an active discussion at CERN right now how to provide the next generation analysis facilities and also how to evolve our computing model essentially. So something like, you know, trying to evolve it from massive batch job queues into something maybe more based on containers. So maybe we'll have an opportunity as well here, if our analysis platform evolve and are kind of convergent with a technology that is also used for preservation, that it will be a very, very easy and natural technical, you know, capability that we could exploit. This convergence. And then for data spaces, well, I can't think, you know, I can't help of not thinking about data lakes, and I'm trying to figure out what the difference is.
As soon as you know, it strikes me as, but this is just my view of things, it strikes me as something that started in policy and is slowly trickling down into, can I say reality, but at least implementation. We're not there yet. So as it trickles down and as the EC itself is beginning to find who its partners might be, but then there is an onus on us to make sure that they don't drift into people who tell them that everything is possible.
Yeah.
You know, there's a lot of snake oil and emperor's new clothes, etc. And before you know it, it's 1.6 billion pissed up against the wind with another beautiful platform that never sees the light of day. But oops, that was a bit negative. Scratch that out of the whole recording.
No, but you're absolutely right. And I think the role of our community is to ensure that we provide solutions that are used by the users, by, you know,
yeah,
by the researchers, and then whatever new concept comes in, it will be much easier for us actually to get hold of it in you know, in a sense.
Yeah, actually on that, given that there's the largely positive development of the EC itself, so rewarding this idea with pride of place in the procurement, the US procurement action, which will end up with the EC owning a large EFSS system, which is good, mostly, but also means that we do have to influence them into the right direction, because you know the lay of the land. The community has a tendency to form itself around the biggest funded thing in the middle, right? CERN knows this. You have a fairly big funded thing in the middle. It does mean that we need to make sure that they make decisions that we think are clueful. I mean, they are the EC, they are clueful enough, but it's not their primary mode of existence, right? Running a system. So, do you have any ideas about that? Or do you want to ponder that for a while we go to Gideon?
Yeah, maybe. What exactly is your question?
It's out of form for you. You can just grab this one and turn it into whatever you...
Okay, I'll try to make something up from this, and let's give...
By September, there will be a central, a node of an EFSS, rather well funded, that notionally runs all the protocols and interoperability standards that we believe in. But it doesn't itself have any governance. It's the EC running it. Notionally, by the architecture diagram Ron showed us, but that thing as well is 3 years old. So where's that going to go? How do they influence this thing? Do they take their governance from the IOSC Association? Who knows? So it's still not a question, but...
Yeah, but okay, so essentially this is a question of sustainability. And I think then we have to look into the bigger picture, because if that node, and I think the idea is that node is part of this, is a ScienceMesh node as well, so essentially it will be one of many nodes which are provided as a part of ScienceMesh. We know that the nodes in ScienceMesh that are provided by existing nodes, institutional nodes that are provided in ScienceMesh, they already have a sustainability model because they have a very large local user group behind. Okay, we are running CERNbox at CERN because it's used by 15,000 people. Okay, Surf is running Surf Drive and Research Drive because it's used by I don't know how many, 60,000 or whatever. And similar story for all other nodes that we know of. That node, the EOSC node, well, we'll also have to find some kind of a model, sustainability model at the end of the day. So if there is a big uptake of that at some point, probably people will be, you know, if you get enough critical mass, probably it will make sense that people will, you know, it's a real resource that you're offering, right? So it's nice to offer a real resource for free, but at some point, you know, it depends also on the scale. At some point, maybe you want to do some costing of that. I don't know, but certainly there must be some kind of economical model that could also be related to the open, you know, to the, let's say, business model or economic model of the companies or the industry that is involved in this, like OnCloud or NextCloud. Because at the end of the day, maybe for them it makes sense that they run this service because this is the way also to kind of aggregate, you know, get enough of a critical mass for their technology also to expand towards other markets or something like this.
Yep.
I don't know, I'm just speculating, but...
Fantastic segue onto our next speaker, because he said business models.
Yeah.
And everyone goes to sleep.
No, well, not so much that, but everybody knows that everybody else is trying to wheedle out from underneath that. And you guys represent the people with the nous and the sense of what actually works and doesn't. And you're in the researcher engagement TF, aren't you? Or is that Angelo? You guys in the broader sense.
Yeah, so for the record, I'm not in the task force. So take whatever I say from here on forth with a pinch of salt.
Shall do. But you guys are the reality check people for us. That's the reason why you're in the project. There is a tendency, as I'm not gonna bag you for it, Andrea, but the fantastic remark you made about, oh right, users don't behave like I do. It's something we have all the time. Like, and then you give them the command line and everything is rosy. So we have the people from Asada in this project for that broader view of what's sane, what works, what do researchers actually do. So having been in the game of researcher outreach, science communication, etc., are there things? So let's start with the self-congratulation. What is the stuff in this project that you think made it work? What could work from a user engagement point of view, and what could work better? What are the threats? How could this go off the rails?
Sure. You know, I think in the context of the ScienceMesh, well, let me back up. I think I was reading a little bit earlier about EOSC, and you know, I'm very new to that space. And one of the overarching principles of EOSC, you know, is that research has to be at the core of the initiative, right? Which means that real deep engagement with research communities is needed. We need to understand what are the needs, what are the requirements, and make sure that how EOSC operates and the services it provides serves those needs, right? Your specific question again?
What's going right here? What might go wrong? And if you want to take that to a broader context, I'll spike it a bit. If you've seen the architecture diagram for how EOSC is supposed to work, then the democratized stuff that might hit every researcher, is sort of hidden in the middle as a glue layer. Like CS3Mesh sits in the middle as a glue layer. And the way clearly the EC itself thinks about researcher engagement is spikes high up, thematic portals that actually hit particular research cases. That works well for those cases that you manage to get funded. Right? And some of them are always popular in particular points in time. Right? There's always some, you care about climate change, it's in there, right? There's always something about peaky medical stuff, not broad medical stuff, that's unfundable, but peaky medical stuff, that's always there. But you can't really reach all researchers in a broad outreach sense by doing all kinds of pinpricks into the research landscape, and yet that's the way that typically funding is thought of. But at the same time, we pretend to be building a cloud here. It's a democratized thing, a cloud. You can tell because the clouds that we used to try to emulate in the broader sense were sort of the competition. There was a degree of envy, like why are the hyperscalers so successful at scooping up researchers, and why is grey IT so successful? Can't we counter that? You might be able to counter that by having a democratized initiative that, you know, a tide that floats all boats. And yet, inevitably, the funding structure is again moving back to funding peaky stuff and dealing with the horizontal broad stuff as an afterthought or as something that's sort of in the middle of the layer cake, not the prime thing that we do. So on the one hand, we care about user uptake. On the other hand, it's not really what we fund. How could that be done better?
You did not simplify the question, you are aware.
That's because it's frustrating, but it's so close to how funding bodies work anyway. And you guys are a business uni, you might know. or you might not know.
Yeah, I think it's the second.
If there is no answer, then at least I feel less frustrated. To know that somebody has the answer and nobody's asking them is even more frustrating. But
yeah, I mean, I think people are definitely thinking about that, but I'm not sure if there's a coherent answer.
No, it's hard. How do you structure funding in such a way? How do you incentivize policymakers? How do you incentivize people at the government layer to think of funding that does not end up in a ribbon-cutting ceremony for a bit of research that is to be done in 2 years' time? How do you incentivize them to not only fund that? They'll always do that, but not exclusively. How do you incentivize them to turn something like an EOSC into a properly broad-based infrastructure that scoops up an enormous amount of users and lives on the strength of its user uptake, not its peak science? So you're the only one I can ask. I know I'm putting you on the spot. Nobody else has, well, Christy might have a decent answer here, but nobody else, I know nobody else has a decent answer for this. Not even you, Kuba.
Well, but I have an opinion. I have an opinion.
No.
Yeah, well, I mean, in this task force, for example, I mean, you're alluding to sort of long-tail research, right, and how we can... So the nice thing about this research engagement and adoption task force is that, yes, while we're looking at specific structured research communities, its activities are organized by organizational level. So there's a European subgroup, a national subgroup, and an institutional subgroup. So the idea is that the task force should expose research and capture the perspective of long-tail researchers as they engage with these different bodies, right? So I wouldn't say that we're missing the perspective of long-tail research. It's just about, you know, what after that.
Yep, no, understood. That's fair enough. Rita, how much time do we have left? None? It should be over now. That's harsh. This whole thing should be over now. None. 4 or 5 minutes, exactly. Fantastic. So, throwing the floor open. Does anybody have anything to say about anything that anybody else has said?
So can I make a comment about the last question? This is certainly not at the scale in which we're talking about now, but I did want to put on everyone's radar. There's an initiative in the United States around research repositories. So it's called the Generalist Repository Ecosystem Initiative. And this is a collaboration that we have with the Zenodo team. We're one of the partners on it together. And then there are a number of other repository platforms that are well known, I'm sure, to everyone in the room. But the entire premise is that you're bringing together commercial and open source partners in what they're calling a model of co-opetition. And so there are funds to basically support everyone coming to the table, establishing some clear guidelines around best practices to support interoperability while still allowing each of the repository platforms to be able to advance their own goals. So, I mean, maybe this kind of goes toward what we've been talking about throughout our time together, but, you know, how do you bring people together? And it's not a lot of money, but it is enough so that we are invested and we're paying attention and participating and helping to drive best practices forward. And so this is through the National Institutes of Health.
Well, wonderful, thank you. It's just the fact that you've been able to get funding for that sort of stuff. And often what it takes is just to roll over 1 or 3 funding cycles before you can actually start building a proper community. That's how Gravitas works. A lot of stuff, unfortunately, just withers and dies within the funding cycles. Not good initiatives, but they bloom and they wither. At the same time, David, I know that you managed to get something similar funded in the Czech Republic. And you're a modest person, so you're going to deny this.
Not yet, but it's in progress. We are just building an infrastructure of or basically a platform that allows user communities to build their own data repositories, and they don't have to take care of the low-level technical infrastructure stuff by themselves.
How did you argue to get that funded? Not so much the tech. I know in your hands the tech is going to be solid. How did you manage to get that funded?
It's not a question for me. It's about my pay grade, definitely. All
right. Any further questions? Questions from the floor? Anybody wants to bag Kuba because he's had too much time? No? All right, then can I incentivize you to give these people another good round of applause? Thank you for joining, and I'll give the rest of your day back to you, Christy.
Very good. Thank you, everyone.
Thanks for having us. Bye-bye.
Up to you. I expect you to be chased off the podium. I expect you to be chased off the stage, but I'm not. Oh, I am. Wonderful. Thank you.
Okay, thank you, Guido. Thank you, everyone. And the panel 2 is over. Thanks a lot. I think Gideon can stay because we still need you for the next one. So don't leave the stage. We still want you there, if that's okay. I think now is time to. We are almost done for the event. Only 2 presentations missing, and they are short compared to the 45 minutes panel. Guido, thank you for leading the panel and making some popular and difficult questions, which require technical and expert answers. So I think now, moving swiftly on to the next session, we will have 2 speakers. One, you already know him. He's Gideon from ESADE. He's there. And we would like to call once again on stage Pedro Ferreira, our technical coordinator. So we will start with Pedro, who will talk about the future of the ScienceMesh. He'll talk about the technical development and the user onboarding, while Gideon from ESADE, he will talk about the business impact of the ScienceMesh. So as you have been seeing till now, we've been talking about the motivation behind the ScienceMesh, how it has been helpful for different researchers, what was the technical novelty behind the ScienceMesh, and also what will be the contribution of the ScienceMesh towards the OSCE open science landscape. Now it's moment to talk about the future. And with this, I'll pass the floor to Pedro. Are you ready? Okay, go ahead.
Hello. Oh, no, okay, that sounds much better. Thank you very much. So, and thank you for the kind introduction, Rita. So, indeed, I will be, this presentation will be shared by myself and Gideon. And so I've been tasked with doing the first part, so talking a little bit on what are our plans for the future. So I will start by first of all, making a bit of a summary of where we are at the moment, what have been the latest developments within the ScienceMesh, and then finally I'll switch over to talking about the future, and in particular what are the plans for the continuation of the project, both from the technical but also from the, let's say, federation point of view and the community building point of view. So where are we right now? The mesh right now consists of 5 interconnected pre-production sites. So it might look like 5 is a very modest number, but actually, you know, the amount of work that has been invested into this will contradict that. It's actually this pre-production mesh at the moment is actually an interconnected set of nodes which are able to share, let's say, to share files and to use the invitation workflow, which has been demonstrated already before, between them, and this irrespective of their vendor. So we have sites which are using OnCloud, sites which are using Nextcloud, and even different versions of the same software. And you've noticed I've added an asterisk next to CERN. That's because we are already on OnCloud infinite scale at CERN. And right now we are still having some issues, actually, which is one of the things that are currently being worked on, which Giuseppe, Gianmaria, and others are working on, sorting out the connection between OSIS and Nextcloud, because there are still some bugs, let's say, there, which are now being sorted out.
So this is the current state. So these sites are in pre-production. This means that we have we are using basically the software which would be otherwise in production, or which will be soon in production, and using an infrastructure which corresponds to the production infrastructure, user database that corresponds to the production user database. Of course, then the data which is available to users on these pre-production sites is not the same that is available in production, but this already gives us, quite high certainty that it will work out in production. So one of the things that is currently being worked on is, of course, the stabilization of Riva intermediated transfer. So this is what I meant before by the work which is currently being done at CERN and also by PonderSource, which is making sure that the compatibility between all different versions of vendor software is achieved fully. And we're already pretty far into this process. At the previous presentation we've done at the CS3 conference in Barcelona, I actually mentioned that we managed to get the major vendors on cloud and nextcloud to include some patches which we have produced into their own stable branches, which means that this made basically integration fully possible on our side. And now, of course, we are going to we are again in a dialogue with them to ensure that these bug fixes that we found along the way are included in stable versions. And this is, of course, one of the reasons why we are not in production yet, because that has to be done, and then we will be moving to production. So in terms of deployment, we have a regular federated deployment task force, a weekly task force which meets weekly, which has been doing a lot of coordination of the deployment of the effort deployment effort throughout the road to production. And big thanks to David Antos, who was here just before on Zoom, and who's been leading this task force for the last few months. And through this FDTF, we are working to move the remaining nodes to pre-production, because the remaining nodes in the consortium are still in, let's say, proof of concept state, and consequently to production. At the same time, we are also working on continuous improvements in the documentation of our processes, our onboarding processes, our configuration processes. It's of course very important that it's as easy as possible for people to install the software, to set it up, and to get it running. And at the bottom of the slide, you actually see the really nice table that David and the guys put together, and which shows the tests that have been done in the pre-production environment, and show, all these green boxes are basically successful tests which have, proven beyond any doubt that the transfers can be done between these systems. So let's then go from where are we to where are we going. And this, of course, is a discussion which is much more open-ended. There's still a few things that we are, of course, uncertain about. Tomorrow we have our last all-hands meeting, and we will also probably take some decisions which will influence some of the things that I'm now saying. But nonetheless, we have an idea of where we're going in all of these matters. So with regards to technical development, we will of course be advancing the OCM standard, and I believe that someone, maybe even Guido, mentioned before that one of the companies which is participating, to whom we're outsourcing some of the effort, is even trying to get funding to work on OCM and to improve OCM. So I think there is enough interest in the community, also from the vendors, in advancing this standard and fixing maybe some of the kinks that still exist here and there. Of course, then, if we want to keep the ScienceMesh alive, we want to also provide continuous updates on ScienceMesh, on the ScienceMesh app, and on Riva. Riva, of course, there's something that, for instance, we use at CERN, and it's something that's actively used, so that there is a very little risk that in the future that won't be done. The ScienceMesh applications, of course, that involves already additional investment, but I'm sure that within the consortium we will find enough willpower to work on this in the future. Then, with regards to the onboarding, the focus is now to move the current nodes to production as soon as possible. There is some technical work, which I've mentioned previously, which has to be done, but it is advancing steadily, and we're nearly there, so it won't take long until we will be able to do that. At the same time, we are trying to start onboarding also some new partners. There are a few interested organizations would like to start working on joining the mesh. So, and this is also acts as a reminder of maybe some of you in the room or online who may be interested in joining this effort. Just let us know, because this is the right moment to start working on that. Of course, there will also be some continuation work, which was also already mentioned here. Well, that was the second item. There is a subset of the consortium, of the current project consortium, plus other friends who are working on a proposal for EOSC, for an EOSC service based on which integrates with the ScienceMesh and based on the technology that we have developed. So this would, of course, be great for the continuation of this project if they succeed in that. And there's also a growing list of interested parties in a follow-up project. So once again, if you are interested, if you have interest in joining this effort in helping us continue this project and making the ScienceMesh a reality, a production service, and start growing it from there, let us know, and let's talk about it. So just some conclusions. I think we managed to prototype and bring to pre-production state the base technologies of the mesh. You've seen the demos before. I think they're quite clear on what is possible and what this technology can deliver. And the consortium remains committed to a move to production, despite the formal end of the project. And we know that officially we are just weeks away from finishing everything. But we have plans, we have a constitution, we have a series of bodies that we are going to establish, and tomorrow, of course, some of these questions will be clarified. And we are certain that the ScienceMesh will remain alive through the administrative bodies that we will set up. So yeah, more on that tomorrow. So I will just finish by reminding you that our site, ScienceMesh.io, contains all general information about the platform, the application catalog, and also documentation resources. So feel free to go there if you need any information. And I believe that's it. So I think I will.
Thanks, Pedro. Yeah, pass the floor to Gideon.
Very good. Okay, so by now you guys know our role was really thinking a little bit more about the longer term sustainability of the mesh, what happens when the project funding ends, funding models, all these things that get us very excited. Because of time, I think I have negative time, Rita, if I'm right. So I'm going to give a very brief, very surface level overview of these 3 topics, but if you want to know more, I really encourage you to read this document that should be publicly available quite soon. Before I get into it, there's just one thing to remember, I think. From a purely technical point of view, sustainability was a core component of the ScienceMesh from its inception. And I say that because it's built on a mesh of sites that themselves are sustainable and funded, like Ron said, typically through national means. And the actual meshing of sites is completely end-to-end, which means that there aren't really that many components to the direct ScienceMesh cost structure. With that in mind, though, there are some essential operations that need to remain in place. Bear in mind, this is a moving target, like Pedro said, but what I can say is that this will likely be as lean and lightweight as possible. So there'll be an executive board, for example, ratifying governance documents that are binding for all the mesh members, a steering group where you can have all members can have voluntary representation, an operations team, a help desk that's been set up and needs to remain in place to deal with the various onboarding issues that might arise. And of course, we need some dedication to software maintenance. A large part of our work was thinking a little bit about funding models, financial sustainability, and these sorts of things. This is also still a work in progress, so consider this simply an ideas bank for future iterations, like the possible follow-up project that Pedro mentioned. I'm sure we'll work on this a lot more then as well. So firstly, as a public service aiming to serve the wider research community, grant funding remains the most natural choice to fund an initiative as ambitious as the ScienceMesh, especially in its early years as it adopts its first users. And the CS3 Mesh for EOSC funds have been instrumental in securing the future of the platform. And with it, we believe to have created the conditions for the mesh to demonstrate real benefits to its early users. The second, call it idea, is this, some sort of membership fee structure, whether that be at the point of, let's call it research institutions, or further upstream at the sync and share services and sites themselves. The big challenge here is, convincing everybody that the ScienceMesh generates enough value to justify any kind of fee. For both of these sort of sub-models, it's important to note in that picture, free at the point of use for the individual researcher. That's something we obviously value quite highly. So now, completely opposite to what I just said is service fees for researchers themselves. We've included this idea just to be thorough, but for a lot of reasons, most of them quite obvious, this is something we want to avoid as far as possible. Hence the thumbs down. Third-party vendors could also offer products or services that might integrate within the ScienceMesh architecture. The two things here being convincing vendors that the platform is viable and having them produce content that end users value. And then finally, some sort of subsidization from commercial activities. The exact pathways to make this work haven't been defined, but the idea is simply to leverage the financial capacity of industry users. So where to from here? So we've identified a few sort of areas for priority investment moving forward, all of this being underpinned by the essential operations that need to remain in place. So for example, enrollment of new nodes, making sure the ScienceMesh is always expanding, developing admin capabilities, so making sure that ScienceMesh members are empowered to manage their respective nodes. New user communities, this might seem like an obvious one, but crucial to think about. We could have, in my opinion, all the connected nodes in the world, but without a strong user base, without researchers that know about the mesh and that use the mesh, our efforts might be futile. And then, of course, keeping a constant eye on the ever-developing advances in data science and machine learning might present some opportunities for new applications. To put this in some sort of broad timeline, the immediate needs is obviously to bridge the ScienceMesh into that early adopter community and further explore funding and sustainability pathways. But like what's been mentioned a couple times before, I think achieving that critical mass for the ScienceMesh is really important before we can have real grown-up conversations about some sort of membership fee structure, right? Over the medium term, the ScienceMesh can grow by expanding the network of nodes, engaging with more scientific communities, and in the long term, we might find ourselves in the position of sustaining the ScienceMesh, where we've become one of the main platforms enabling fair data and open science for researchers Europe-wide. And I think I'll end it there. Thank you.
Thanks, Gideon. Okay, last questions for Gideon and Pedro. From online audience, do we have questions from the online audience? No? Just checking quickly. There is something there. Okay, no. Pedro and Gideon, thank you very much for your presentations. And now it's almost over. So we are going to close this event how we started, listening to our dear Kuba, who was the coordinator behind the overall ScienceMesh for IOSC, who will say a couple of words before we can call it a day. Kuba, thank you very much.
Okay, so, well, I think everybody just wants to go home, so let me be brief. Thank you very much. Thanks a lot for staying the whole day. So, as it was, I think, highlighted, it's not the end, but there will be a continuation of different activities that have been initiated by the project. So definitely watch this space if you're interested in knowing what's coming up next. And yeah, and that's essentially it, I think. I just wanted to again express my big thanks to Rita and the team that prepared the event. It was very nice. And thank you very much for your participation, and that's it.
I'd like to add a couple of words to what Kuba just said. I would like to thank, first of all, for the invitation from EGI for us to organize our event during your annual conference. We really appreciate that. Also to thank your presence for those who are here in Poznan, but also of the online audience who followed us online. And also like to thank the technical team, which is also Jakub. I would like to thank you for his support. And also to my more personal note, to my colleague Ruben, my colleague Letizia, and also another colleague who is supporting us from the office, Luigi, who also worked well together, worked hard to deliver this event. As Kuba said, this is not the end, so if you want to be in touch, keep in touch. We want to keep in touch with you and touch base in the next days, in the near future. Thank you very much, everyone.
You can go.
You are free to go. Enjoy the city. There is a world out there to explore in Poland.